From the people who brought you Angular Connect 2015 and Angular Connect 2016 and Angular Connect 2017 and Angular Connect 2018. Angular London Meetup and White October events bring you Angular Connect 2019. Please welcome onto the stage Josh, Ed, and Pete.
Hello everybody. Hello.
Welcome to Angular Connect. We're so excited to be here this morning. If you didn't hear just then, my name's Pete Bacon-Darwin. This is Ed Connolly. This is Josh Moont.
Hello.
We are the founders of the Angular London Meetup, which was started all the way back in 2012 when Angular wasn't even Angular. We work with the White October events team, who are amazing to put on this conference, and we're very happy to have you here.
Thank you. Whoa. So this is our 5th year. So I can see some familiar faces out there. I can see some new ones. So whether this is your 5th year, your 1st, or anywhere in between, thank you very much for joining us for this journey. So I want to just take a moment to think back when we started this conference and think about what we were looking to do and highlight some of our key objectives. So we wanted to create a space where we could connect with developers and experts. We wanted to celebrate and learn Angular. And we wanted to be able to grow and support the community. And that's how Angular Connect was born.
Now, if you've been here to Angular Connect before, you'll notice that we're actually in a new venue this year, and we're very excited to be right slap bang in the heart of London, the QE2 Conference Centre. We've got so much stuff going on that we've had to split over 2 floors, as I'm sure you've seen. This floor has got tracks 1 and 2 behind you, and also the sponsors hall. Please go and say hello to all of them. And then downstairs, we've got another floor on floor 2, which has got all of the other crazy and exciting stuff going on.
So, what can you expect from the conference this year? We've been trying really hard to find new ways to make the conference experience even better. So we've kept some of our favorites, like awesome talks and the mini workshops. And we've added some new things, like the expert zone that Pete will talk about a bit later.
So Angular Connect just wouldn't be the same without our amazing talks. All the talks are here on this floor, as Pete said. We're in track 1 right now, and then behind you, the empty room is track 2. We'll be putting up a partition between the two when the conference kicks off fully. You can check the schedule for the talks directly on the website. You can also check out a map there so you can understand your way around the conference a little bit better. We're live streaming the conference to people all over the world to bring them all the amazing content that's happening over the next couple of days. But also, you'll be able to find recordings for the conference afterwards on YouTube. Now, thank you. You might have noticed that my words are being written up on the screen to my right. This is happening by the brilliant Andrew up in Scotland. Hello, Andrew. How are you? Hey, I'm great, thank you, Andrew. Thank you so much for asking. It's very kind. Our talks on tracks 1 and 2 are going to be captioned by the amazing Andrew and Amanda from White Coat Captioning over the next couple of days.
So like I said, we've also got mini workshops. We have 4 awesome mini workshops over the next couple of days. You'll be led through steps, and you bring along your own laptop. There'll be some additional experts in the room to help you if you have any questions or want to be pushed a bit further. If you want to attend any of the workshops, you should have a look at this website because it tells you more about it and has some prerequisites you should download before you attend. The first workshop is actually happening straight after the keynote, so take a look at it as soon as you can.
Cool. Now, as Josh mentioned earlier, we're trying something a little bit new this year. And this is this concept of expert zones. We've combined what we previously had as the Q&A panels and office hours into a single, more focused kind of mini unconference that hides inside the main conference. Each of these sessions will last just over an hour, and maybe some of them will start with maybe a brief talk, and then we'll go to the moderated Q&A like we do with panels, and then we get to break out and interact more informally with the speakers and chat and discuss what the topic is about. And these topics are the important ones that we got from you as the things that you wanted to discuss.
But wait, there's even more. So we've set up some lunchtime discussions around topics of diversity and community. They're going to take place in the mini workshops zone, which is downstairs. They happen at 1 o'clock, but you don't need to grab lunch in the main hall. You can grab lunch there. So if you want to head down there, you can go there straight away at 1 o'clock. Also, if you'd like to take a break from the main Angular conference, you can do that in our quiet zone and our chill out zone. In our chill out zone, you'll find arcade games and some board games and probably a bunch of interesting people to speak to. But if you want to step back even further from the conference and have a bit of peace and quiet, you can do that in our quiet zone. We've also got 4 mindfulness sessions in the quiet zone tomorrow, starting at 10:45. You can check out the times for all 4 of them on the board outside of the quiet zone. We've also got dedicated prayer and nursing rooms downstairs as well.
Now, the main talks finish around about 5:30 this afternoon or this evening, but it doesn't stop there. We're going to have food courtesy of City Pantry and drinks, including the classic Angular Ale that we all love, and that's thanks to Oasis Digital. There's going to be some jazz music playing that you can live jazz band, or you can just go and chill out in the games area and just hang out with your friends. But then from 6 o'clock, we've got 3 activities going on. First of all, Bonnie Brennan's going to be hosting our lightning talks, which were so successful last year. They're going to be in track 2, and if you would like to give a lightning talk, we'd really love to hear from you. Go and sign up on the board outside track 2. Then breaking outside of the conference zone, conference venue, we've got 2 guided walking tours around London. So if this is your first time to London, or if you would like to find out a bit more, get downstairs to the ground floor where you'll find someone with a green T-shirt on, and you'll be able to go and join the walking tour. There's limited spaces, so first come, first served. And also Ed here has volunteered to take anyone who's interested on a brief bar crawl around local pubs in the area. So if you want to get sociable and hang out with Ed and other members of the community, then please join him downstairs also on the ground floor at 6 o'clock. And then finally, Josh and I are going to be running an Angular London meetup over in Moorgate, starting at 7:45. It's over in a place called Skills Matter, and in order to go there, you have to actually register with Skills Matter on their website. So go to their website, search for Angular Connect. The first link will be our meetup, and you can then register. Otherwise, they won't let you in. So there we go. We'd really love to see you all there. There are going to be a few of the speakers coming along, so you'll have even more opportunities to connect with the experts.
So we wouldn't be able to do all of this over the next couple of days without some help. So we invited some experts from the community to join us as hosts. So let's hear a nice warm round of applause for Alyssa, Tracy, Shmuela, and Bonnie.
Give us a wave. Give us a wave. Where are you?
They'll be keeping us informed and entertained throughout the next couple of days. Keep an eye out for them, and thanks very much.
So if you haven't done so already, you can hop on the Wi-Fi by going to the Angular Connect network and using the password Angular Connect 2019. You can also find the details for the Wi-Fi at the bottom of your pass. Once you've done that, you can get tweeting. So please join in the conversation. We love seeing your tweets. Use the hashtag AngularConnect. There's also going to be some prizes tomorrow for the best and funniest tweets. And to be honest, just people that tweet the most. So just quantity over quality will be great. Right, but okay, fun exercise. So we love hearing your feedback about the conference, so we can put on a better conference each year. So what we're doing today is we're going to be gathering feedback using Slido, but we're also going to be having some fun polls on Slido. So can I please ask you all to get out your phones and head on over to slido.com or slido. And if you put in the event code Angular Connect, you should see a couple of rooms then. If you select the Get Interactive room, once you've done that, we're going to be asking you the question, how many years have you attended Angular Connect? And if everything goes right, we should see the results up on one of the screens. Here we go. Look at this. Okay. So cool, it's coming in. Okay, so most of you, this is your first year. Welcome, everybody. That's so cool. New people going back for 3 years, 4 years. 5% of people have been all 5 years. That's amazing. That's brilliant. Well, awesome.
Well done to those 5 years.
Yeah, that is great.
We should give you like a special badge or something.
So, welcome to everybody that's new to the conference, and we'll be doing a few Slido polls throughout the day so we can learn more about each other.
So I'm really proud that Angular Connect has always been a very warm, welcoming, and safe place for all of us to attend. And it's all of our responsibilities to ensure that continues. So please do go and read our code of conduct and make sure you understand it. The website has the page with all of the information on about it. So please go there and check that you actually understand what is expected while we're here. If you do have a problem, or if you see someone having a problem, then we really want you to let us know. You can either find someone with a green t-shirt on, and maybe with the word staff on the back, or if you don't want to do that, you can contact Megan, our event organizer, event manager. Her mobile phone number and email is up here. You could take a quick picture of that, but also it will be on all of the code of conduct boards around the conference. So we take all of these things really seriously, and we will deal with your problem as quickly as we can.
So that's nearly up for us, but before we go, we just wanted to mention our sponsors, because without them, we just wouldn't be able to put on a conference like this. So you can see them all here on the board, and they're outside in the sponsors hall as you came in. Thank you to all of them, especially our premier sponsor, AG Grid. Let's hear it for them.
All a round of applause. Thank you.
So some of the sponsors will also be giving some short talks on tracks 1 and 2 through the day, so watch out for that.
Great, so I think it's time to get on with the show. So let's kick things off with the ultimate Angular double team. These two speakers don't really need much of an introduction. They've got really broad and diverse roles on the Angular team, and I think that makes them pivotal to the success of the project. While it's fair to say that their razor-sharp minds are completely focused on the Angular project, it's really a big thing for me to say that their hearts are devoted to the Angular community. So please welcome onto the stage Igor Minar and Stephen Fluin, who are going to get things started today. Thank you very much.
Thank you so much, and good morning. Good morning. That was pretty good, pretty good. I do want to give a huge thank you to everyone that is here in person and everyone that's watching online. It actually means a lot to us that people come to these conferences and are so engaged with everything that we're doing. I want to start off with a little bit of a story about an event that we ran a few years ago from the Angular team. What felt a little bit like a normal Angular meetup that we run in Mountain View that was really co-located next to the team started to feel a little bit different. We had the same sort of normal food, we were catering the event, we had the same sort of attendees coming, speakers presenting about what's going on in Angular, but this one was a little bit different, because as we started setting up, we had to do things a little bit differently. And Igor, you're going to have to unlock your laptop if that's all right. So, much like the beginning of this keynote, that event was a little bit different.
Technology. Okay.
If it was easy, everybody would do it, right?
Yeah.
All right, there we go. Thank you so much, Igor.
Sure.
Igor, round of applause for Igor. All right, so as I was saying, that event was a little bit different, because as we were doing this setup, we actually brought in a few props. And so this was us bringing in giant balloons into that event, because it wasn't just a normal meetup, it was actually the release of 2.0.0, which I know was a big release for a lot of people, because there was a lot of anticipation for what was coming. People wanted to really understand what was going to be the final version of that API. And so we brought in balloons, we had a big celebration, and that was September 14th of 2016. And so we are just about at the 3-year anniversary of that release of Angular. And so I think it's a really good time to reflect back on the 5 years of Angular Connect, the 3 years that Angular has been final and stable, and really think about the successes that we've all had, both on the Angular team and within the community, as well as think a little bit about the promises that we made around helping people, helping developers with their productivity, helping them with innovation, and giving them stability and APIs and commitments around release schedule that has really been effective in helping everyone stay up to date and understand what's going on in Angular. Over the next day or so, you're going to hear a lot about the Angular team and the things that we're working on, the things that we're excited about. But as always, I really do think it's really insightful to think about the values that the team has. But I don't want to just say these things. I want to actually give a couple examples from the team of things that we've cared about and ways that we've tried to embody and reflect these values. When it comes to applications that users love to use, we do a lot of surveying to figure out what developers care about, what users care about, and there's sometimes actually a mismatch between those things. We've talked a lot in the past about how a lot of Angular applications are behind the firewall in captive users where users don't have a ton of choice, and that for some developers, bundle size doesn't matter very much. But we feel like we always need to care about the user. We feel like they are essential to our workflow. And so as we've been considering features, even going back to the days when we were in conference rooms and on calls talking about features like differential loading, where we could change the way that we do some of our bundling in order to give users a better experience by giving them more performance, we really wanted to take that to heart and embody those things and build those features, even though not every developer was out there asking for it. Because at the end of the day, we think that if users can be successful, our developers are going to be successful. Another example of where we want to have applications that developers love to build is really focusing on our ecosystem efforts around ng-add and ng-update. We've talked about this a lot in the past, and we're going to keep talking about it because we really do see it as a big opportunity to act as a multiplier for everything you do. When you create ng-add and ng-update schematics, or when you build a builder, as one of the new capabilities that we've released recently, it really does not only improve your life as an engineer, but improve the collaboration across teams, because most of us are not building software in a vacuum, right? At some point, there's going to be other engineers working on the same thing that we are. And so having that sort of collaboration, making it easy not just for myself, but for all of those around me is really, really critical. We also care deeply about a community where everyone feels welcome. One of the things that we do before actually going to a conference like Angular Connect is we ask them, how are you going to make the conference welcoming? How are you going to make sure that everyone feels included? How are you going to help us engage and be a part of the community, help the community engage with us? And so what I want to do is I want to actually tell a few stories about what's been happening in the community recently. One of the things that we announced on Twitter recently is actually the number of events happening across the globe is exploding. And so we posted the number 7 new events in 2019. And this was actually really funny because all of the responses that we got to that post on Twitter were like, hey, me too. I launched a conference. I launched an event. I launched a meetup. And this is so fantastic to see that everyone is so passionate about being engaged, that technology is not just about lines of code. It's about the people. It's about the developers. It's about the communities that we build around these things. And that's what ends up truly making us effective. And so a huge thank you to everyone that attends a meetup, that starts a meetup, even if you just talk with your friends about technology, because sharing is how we all get better together. Another organization that I'm a personally huge fan of is NG Girls. They work very, very hard to train new engineers using technologies like Angular, RxJS, and so on. They've actually had a huge amount of success over the last year or so. If you look back, they've run 25 different workshops. If you look at the number of attendees, I was actually astonished by this number. They've had over 700 participants coming through. They had over 250 mentors. And they actually have 9 more events planned in the upcoming future. And so if you're interested in supporting events like these, definitely take a look at the NG Girls website and think about becoming a volunteer. Think about pulling other people that you know that feel like Angular or JavaScript or web development could be an opportunity for them, and think about encouraging them to attend one of these workshops, because we do really see this as transformative for a lot of the people that attend. One of the things that we've done a pretty good job of in the past that we haven't done for a couple years is we actually wanted to hear from some of the people that are using Angular on a day-to-day basis. And so what I want to do right now is I want to take a brief moment and actually reflect on 4 different stories of teams that are out there integrating with and building on top of Angular, and really understand the things that they've figured out and how it works best for them. And so first up, I want to invite a couple of my friends from Deutsche Bank, Renee and Florian, who've been working on something they call business components and dynamic processes.
Hello, folks. My name is René Christ. I created DB Core, our Angular-based front-end platform at Deutsche Bank, along with my fantastic team. Our vision is to help people do better work by using better tools. And Angular is our noise cancelling tool to focus on the cool stuff in web development. My department roughly deals with 60 single-page web applications, and we have frequent changes. Small changes like text changes, as well as more complex changes in order to comply with regulations, and also building new websites from scratch. In order to cope with such an amount of sites and business requirements in a fun and efficient way, we came up with the concept of business components to reuse code across domains. Our goal is to change a component once and let the changes explore to all our applications. So, we have basic components such as a button and input fields, and we combine them so that they fit a single business process, hence the name business component. This business component, for example, deals with customers' personal data, and it is connected with the corresponding backend service. And every time we use this component, we use the same backend service. The final result is a combination of business components. And however, you don't have to build these 60 sites by hand. And now I hand over to the really cool part to Florian.
Thank you, René. So, okay, as you heard, we have nearly 60 applications. So instead of coding every application again and again, we zoomed a little bit out and we concentrate on the structure of our application. That led us to an abstraction model. And with this model, we were enabled to build a no-code editor for our processes that is based on top of our business components. With this editor, our business people are able to create applications via drag and drop and to set the focus for them for the customer information, the legal stuff, and the sales funnel. To complete the cycle, we also built in a live preview and a one-click deployment with audit-proof versioning. From the technical perspective, the whole editor is built on Angular and Node.js and produces Angular applications. We use the Angular CLI for the builds. We use schematics for creating our final code for the application, and we use the workspace concept for handling multiple themes. With the great support from the Angular team, with their innovations and on GitHub, it enables us to optimize our workflow within Deutsche Bank and to bring crazy ideas to life. So thank you for this great work to the Angular team, and so I hand back to Steven.
Thank you, London.
So that was Deutsche Bank talking a little bit about this idea of business components. And this is actually a pattern that I've seen growing a lot over the last year or two, where teams are wrapping not just UX patterns, but also business processes and business rules into shareable components across large companies. And I think that's really exciting. I think that we can all think about that model and use that model to evaluate some of the ways that we're expanding our component libraries. Next up, I want to invite Jochen Super from Allianz, who's going to tell us a little bit about the way that they're using schematics to help Allianz move forward cohesively as a single company using same sorts of technologies, and some of the ways that they're going beyond theming. Jochen.
Hey, everybody. Wrong direction. So about 2 years ago, we started building a UI library for the branding of Allianz. We built that on the Angular Material CDK. And today we have many teams in Allianz running on Angular and many teams running our UI library. And I just want to share two things that we've done over the last couple of months. One is automating updates for major updates and also supporting different use cases that we have within Allianz. The first thing is we started building schematics. We had a major update from 7 to 8 in our library, And we said, let's build schematics to not kind of have breaking changes affect our users. So we built ng update for our library. And I just wanted to share kind of the 3 main takeaways that we had with this. The first is there is a learning curve, especially with ng update, because you're going to be looking at ASTs and you have to understand that. So for us, that was a learning curve. Good thing is it works. The second thing is even though we documented it and we shipped it, many teams still manually update it. So there is community work. You can't expect to kind of release this and then every team will use it. You have to talk to the people and educate them to do it. So that's, at least for us, something we need to do more. And the last thing was we shipped a breaking change, and what we got back from people using it was a smile. They said, this was so cool, we really liked it. So that's going to kind of make us do this more and more often. So for us, it was really nice. It was a little bit of work, although, to kind of get this up and running. The second thing we have is we have 2 different use cases we serve in Allianz. We have kind of a branding for customers. They visit our websites kind of once or for a couple of minutes. So for them, small animations like a floating label you see, it's completely fine. We have another use case where we have employees. They sit in front of an application for many hours a day. They don't want any kind of floating or changes of layout. They want it more rigid. That's what you see on the right-hand side. Now, to get from one to the other, there's some markup involved. So you see it's not only theming, you have to change kind of the markup of the component when you use it. In the end, what happened there was we had a lot of conventions. So if people would build internal applications, they basically had to follow a lot of conventions and different components. We documented them. We gave an overview. So we thought it's working fine, but we realized actually people don't read documentation all day, so they don't know those conventions by heart. So we thought, can we do better than just documenting conventions? And now we do so. So what we came up with, we use injection tokens, and they have presets which are actually our conventions in code. And now we package and ship them with our library. So any team that builds applications for internal users, they drop this module in their application, and then the form field looks like it's supposed to look for internal applications instead of having a floating label. Now you can overwrite this, of course, to still have the flexibility. What is really great for us is if the conventions change, we ship another package with the changed conventions, and it's up and running and working. So this is really nice also for us, and I hope also for the teams. Basically, the bottom line is what we were working on the last months very heavily on is moving a lot of things that were manual before or conventions before into code. So one thing, of course, is the schematics, that manual updates for people using the library now become an ng update command. We also use ng add to set up the project. We want to use more ng generate. And we also managed to move a lot of the conventions into injection tokens so that people can just drop them in and use them, and they don't have to worry about them. And we can also kind of continuously update them. And those are just the 2 things that I wanted to share with you. And also I want to thank Stephen and the Angular team for creating this ecosystem that we can kind of build on top of. Thank you.
All right, now that we've heard from 2 companies using Angular at scale, I want to change gears a little bit and talk about some of the companies that are participating in the ecosystem and really trying to enrich it. So we've got 2 examples here, and the first is actually NativeScript. And what we did actually last week was very, very special. We ran a special event, and I'm actually going to invite Santa Mira to the stage to tell us a little bit more about that event.
Thank you, everyone. Last week, we had the first ever hackathon called Hack for Good. It was brought to you by the Angular, the NativeScript teams. The idea was to have an online hackathon where everyone can register and submit ideas for non-governmental organizations. You had the opportunity to build mobile applications with NativeScript and Angular and optimally make the world a better place. For the first edition, we had over 100 registered people to participate, and in the end, we had more than 10 submissions. We also had some pretty cool prizes that I'm going to announce today. In the innovation category, the winner is Team Tech for Good PH with their application Bionic Hand Maps. The application allows you to submit areas and points in the map which need to get better, and also submit locations where you can do recycling. The winner in category Design is Team William and their application Tutor. The utility winner is the Team TNS with their application for the Ronald McDonald House Charities. And now getting to the big prizes. The second prize winner is Team Bessia with their project called Blogging. This is actually quite interesting. If you're not familiar with blogging, it is a concept that combines jogging with picking up litter, so definitely check this out. And the big prize winner is Alex Embling with his project about Plastic Oceans UK. So it is a kind of a local application. The app allows you to learn more about plastic pollution and how we can prevent it. Also, you have the opportunity to find local recycling centers near you, your home, or your office. And you can also track your recycled plastic. If you want to donate to Plastic Oceans UK, you can also do this from the application. And if you want to learn more about the hackathon, any upcoming editions, maybe next year, go to the ng-ns.org website and learn more. Thank you.
I'm really glad we were able to partner with the NativeScript team and Progress to put this hackathon on. I think it's really impactful whenever we can combine this idea of building technology, learning new skills that can be applicable day to day, but also trying to support those around us, right? The idea of identifying some non-government organizations that need some technology and combining that with learning new things is a very, very powerful combination. So I think this first event was very successful. And if you're interested in participating in a future event like this, definitely reach out to us, reach out to the NativeScript team, because we're thinking about next year and figuring out what we should do there. So next up, I want to invite to the stage Mike, who is representing Ionic. This is the last community highlight that we want to do. But one of the things that we've done for a long time is we've partnered with the Ionic team to really share as much technology as we can. A lot of the earlier versions of Ionic were based on AngularJS. They have a really great component suite for Angular. And we found that we can always learn from each other, right? There's always opportunities for us to share technology, not build the same thing twice. And Mike's going to tell us a little bit about that and some of the cool new things they're working on.
Cool. All right. Yeah, so we have been around building with Angular for many years now. And in the past, we have traditionally built our own tools and routers and different best practices and kind of followed our own path. And for a while, that worked well until we realized there was a big investment in doing this. And around the time we started thinking about our 4.0, we really want to go ahead and say, let's forget all about that and just kind of opt into what does Angular give us. So that meant going away from our own build tools to using things like the Angular CLI, opting to get rid of our own router and go all in on the Angular router and start to follow some of the Angular best practices. But we took it a step further where we started saying, okay, this is a really good base. What can we do that's more in line of what an Ionic app should be doing? So we started to extend the pieces that come with Angular. That means creating our own router component that can reuse a lot of the router information provided by the Angular router, but provide animations, gesture support. Started creating our own builders on top of the CLI, so that way we can provide more contextual information to the native platforms when you go to build for iOS or Android. And then also extending the Angular schematics, so that way you can get the default, so that way we can override the default component schematics and provide more Ionic-specific markup. We took a lot of these lessons that we learned with our Ionic Angular release and started to apply them to different projects within Ionic as an organization. One of the first ones that we've been doing is Capacitor, where we're starting to create a suite of schematics and builders to make integrating Capacitor into an Angular project much easier, and also to deploy to these native platforms in a very Angular-friendly way. Another one that we've been working on more recently is an app builder called Studio. This is a really interesting project because it has deep understanding of what your Angular project is doing and can provide more contextual information based on how the app is being built. So if you're inside a page or inside of a component with a route, it can show you that route information right away and give you all the details that you would expect. All this made possible because of the tools that Angular provides. Thank you.
Thank you, Mike. I I think this is another really great example of whenever we can not rebuild the same thing over and over and over in technology, we can collaborate instead of competing. This is a really successful story for everybody. About once a week, someone will come up to me and say, hey, Steven, I saw that talk you gave about Angular for designers. What's happening with that? Has anyone ever had that thought maybe? Because a couple years ago, we actually made a commitment. It was a very, very loose commitment and a very, very long-term commitment that said, we care about people that build prototypes, we care about designers that are using Angular, and we care about this use case. And so we talked about a product that is still under development at Google that I do not have an update about, but one of the things that we're really happy to see is that the community is stepping up to fill some of those needs in the designer space. And so one of the tools that's actually launched this month is from a team called Acqueo called UI Bakery. And so this is a paid tool that I just wanted to put on people's radar that fills some of those needs that we have where we really want to smooth the integration between designers and developers and prototypers. And we feel like these things can be better when you're prototyping and building proof of concepts and research projects with real components. And this is one of those manifestations. And so UI Bakery, they have an interface where you can apply a lot of the standard margins, paddings, add components, create custom components, all those sorts of things. And so if you are working with a team that needs to do prototyping, and you want something that's a little bit more drag and drop style as opposed to writing a bunch of HTML and installing CLI tools, this is definitely a tool to check out. The last company that I want to talk about that actually uses Angular a fair amount, you may have heard of it, it's called Google. Last year at Angular Connect, we talked about there being over 600 different projects that are using Angular. And at the time, I thought that was a lot. I was like, wow, 600 different projects? I mean, I know there's a lot of projects going on at Google, but I didn't know that there were that many. And it turns out that I dramatically underestimated the growth and the success of Angular, even in Google. So as of now, as of this month, we're at over 1,500 projects within Google. And the weirdest manifestation of this is that at Google, one of the perks is that you get massages every year, and you can buy massages and things like that. And I was logging in to book an appointment, and they switched. They're like, hey, we're deprecating our old app, and we're shipping a new application for booking those appointments. And it was built in Angular. And this just happens all of the time at Google, and it's kind of fun to watch when you're on the Angular team, because we never had to talk to that team. They just said, hey, there's a great technology, we want to go use it, we're going to adopt it. And so Angular is doing very, very well at Google, and we're really excited to continue to support that. One of the other pieces of community that I want to talk about is actually our GDE program. You'll see GDEs all over Angular Connect. You'll see them all over the globe at all sorts of different conferences. And this is a program that continues to grow and continues to be very, very impactful for us in terms of helping us share Angular with the world, but also in terms of collecting the feedback from the world and reflecting it onto the team so that we can hear from everyone. Because one of our problems on the team, and especially from the DevRel perspective, is that most of the Angular developers in the world are not in this room. Most of the Angular developers in this world are not on Twitter. They're not watching this live stream, unfortunately. But by having these connections and making a community and understanding that people are welcome, that is the way that we help those people use Angular better and become part of that community. And so I want to thank all of our Angular GDEs for being a part of that. One of the other programs that we've talked about and we introduced over the last year is actually our Collaborator program. And our Collaborator program was really focused on this idea that, hey, if people are contributing to our GitHub repository, they're actually helping us build Angular in a consistent manner that's really spending a lot of time and energy. We want to do more to support them. And so we launched the Collaborator program with a few initial collaborators that we're going to talk about throughout the rest of the conference. But I wanted to just highlight a couple top collaborators, because these two individuals have really gone above and beyond in terms of helping us. So we've got Jia Li. Someone said Jia Li is here. Are you here? There he is. So a huge thank you to you. So as you don't know, he works a lot on Zone.js. So he actually worked on it a ton before we brought it into the Angular repo, and then we actually brought it into the Angular repo to ensure quality, to ensure all those integration tests were working very, very well, and that all these technologies could move forward in lockstep. And he's been really, really instrumental to that. So a huge thank you to him. And the other top collaborator that we wanted to call it that's really gone above and beyond is Yoast, who's been working on the compiler, he's been working on NGCC, he's been working on a lot of the internals that's going to make the Ivy adoption process that everyone in this room goes through much, much easier, much smoother, so that you get the sort of backward compatibility that you expect from Angular. And so both these collaborators, I just, huge thank you. We could not continue making Angular without you. So with that, I want to hand it over to Igor, who's going to turn us a little bit from the community and turn us now towards the technology and the things that we're working on and we've been working on in the past.
Thank you, Stephen. I just want to say one more time thank you to all the collaborators and contributors, because we are very grateful for all the help we get when building Angular. And I just want to make sure that you understand that we appreciate every contribution that we get, no matter how big or small, or even weird, like this drawing that we were left with after our summer intern, Elisa Wang, finished her internship. Not only she built a lot of cool stuff with Angular, but she left our office decorated with all kinds of cool stuff. And this drawing in particular, I think, reflects and captures some of the quirky nature of Angular that is really cool. My name is Igor Minar. I'm the tech lead on Angular, and I'm super happy to be able to connect with you over the next 2 days and talk about Angular. In this presentation, I'm going to cover some of the stuff that the team has worked on over the last 6 months, and we're also going to look into the future, see where Angular is heading. As you probably know, if you've been part of the community for a while, Angular is following this 6 months release cycle, where every 6 months we release a new major version. And we do this because we want to make sure that you understand how we are evolving Angular. We want to bring new features to you, but do it in a way that is responsible and predictable. With every release, we not only bring new features, but we also make sure backwards compatibility is part of the release, and the upgrades are super simple. This year, in May, we released the version 8, and I'm going to cover some of the features that came out of that release. And currently, we are a few weeks away from the release candidate for version 9 that is scheduled to be coming out later in November. In May, the release that went out was really feature-packed. I cannot cover all the features, so I'm just going to focus on some of my favorites. And I'm going to focus on those that had the biggest impact in user experience and developer experience. There was no feature that is more important than the differential loading that Stephen already mentioned. The reason for that is that it impacted both the user experience and the developer experience. If you don't know much about differential loading, let me give you a crash course. Traditionally, when you build an application, you build your application and optimize it for production in a way that creates bundles that work both in modern browsers and legacy browsers. These bundles are composed of polyfills that target primarily the legacy browsers that don't have all of the new APIs, and use the syntax of JavaScript that is older, often more verbose. This assures that the application works across all the browsers. However, it degrades the experience for users of new evergreen browsers. With differential loading, what you can do is you basically build the application twice. You build it once for modern browsers using just a minimal set of polyfills, and you use the modern syntax of JavaScript, which is much more succinct, resulting in smaller bundles. This results in better user experience because the application loads faster, but it also results in better developer experience because as you're developing your application, your refresh cycles is faster, and if you debug the code, you're looking at code that looks much more closer to the code you actually wrote in your IDE. However, to support the legacy browsers, we built the application second time, this time with a full set of polyfills and an older version of JavaScript so that it works. So you get both of the best worlds. The modern browsers get modern version of your application, while the legacy browsers still work. When we rolled out this change on Angular.io, which is one of our guinea pigs for testing many of the experiments, we found that differential loading saved about 41 kilobytes. This is about 10% of the application. And once we launched this feature to production and people started upgrading to version 8, the reports we got is that overall there were savings in the range of 7 to 20%. And this is awesome because all you had to do was to do ng update and your application is suddenly smaller. The best part of this is that differential loading works with all the servers and all the hosting infrastructure out there. There's no changes required because differential loading works as a build step, and at runtime, we do feature detection to recognize if we're using a modern browser or a legacy browser and load the right version of your application. As I mentioned, one of the things that makes differential loading work is that we build the application twice. Once for modern browsers, once for legacy browsers. This can increase the build times of the application. And over the summer, we improved the differential loading implementation in Angular by changing and optimizing the build pipeline and essentially down-leveling the modern version of the application to the version for legacy browsers, speeding up the build by up to 48%. And I don't know if you are like me, but I don't like to wait for my computer to just build my application and watch the progress bar. So 45% improvement in production build speed is something that I really welcomed. Another feature that we shipped was related to deployment. We take pride in Angular being a solution that comes with batteries included. This means we support every step of the developer journey. However, until recently, that wasn't applicable to deployment. Over summer, we released an update which, through just 2 commands, allows you to deploy your application to production very easily. You run ng-add and install a package for your hosting solution. I'm listing just 4 that we shipped with when we launched. But over the summer, many more were added. So if you search on NPM, you might find one for your hosting provider. Once you have the package installed, then you just run ng-deploy. And all that happens is that your production build of the application starts to be pushed to the hosting provider, and the workflow of the particular provider will walk you through actually getting the application. This makes deployments much simpler and really helps us get the applications to production with just a few steps. Steven mentioned that we also think very deeply about making a community more welcoming. However, when we revisited the user journey of a new developer that uses Angular, and when they run ng-new, we realized that we were not doing such a great job. If you look at the welcome screen that you see once you build the application, it's not very useful, and to be very generous, it's not inspiring. So over the summer, the team worked with our designer, Stephanie, and we overhauled the getting started experience and ng-new experience. When you start a new application, not only the screen looks much better, but it also provides useful information about the commands you can run on the command line to extend and enhance your application. There are many other features that were part of the V8 release. I'm going to list just a few, quickly run through them. We added support for dynamic import. This makes Angular more compatible with modern standards, and I'm going to show a demo of that a little bit later. We added a way to customize builds using custom builders, and my teammate Minko is going to show some of that in tomorrow's keynote. We also made it possible to bundle web workers as part of the application. This allows you to offload part of the application into the web worker thread, while still being in the comfort and getting the support of the CLI when it comes to bundling, code splitting of your application. Even though it's been 3 years since we released Angular version 2, we're still thinking about the AngularJS developers. Many of them are still migrating their legacy applications to modern stack, and we wanted to support them in a way that is helpful. One of the things we've done is we added $location support to Angular, so that if you have a system that has a hybrid approach to upgrading, where you're using both AngularJS and Angular, you can use a single unified router for both of them, and the both parts of the application work. This makes migration much simpler and allows you to transition to Angular faster. Another one that we spend some time on is improving the IDE support, especially if you're a VS Code user. In the past, you might have seen some latency issues and unreliabilities in the auto-completion. This has been solved over the summer, and the user experience is much better. We also spend a lot of time on docs, especially on getting started, so that new users, as they're coming to Angular, have a better time. If you are following Angular closely, you probably noticed that in May, we also released a preview version of Ivy. Ivy, if you don't know, is a rethink of how Angular works internally with several goals. One of them is making the applications smaller, and we were able to achieve this. I'm going to show you in a little bit. We also wanted to make applications faster, and this has many aspects. One of the ones that we focused on was the compilation speed. Alex Rickaby is going to give a talk right after this keynote about the compiler and how the compiler works. And one of the big achievements that we achieved with Ivy is that we can turn on AOT compilation, ahead-of-time compilation, even in dev modes, because the compiler is fast enough to support this development. This means that you now have consistent experience between the development compilation and the production on compilation, which solves some of the inconsistencies that we've seen in the past. We also made Angular simpler, not only internally, because the internal implementation is simpler, some of the concepts are simpler, but we also reflected that in some of the APIs and some of the workflows. Let me show you an example. One of these features is specifically targeting debugging experience. One of the feedback we got from developers was that debugging AngularJS applications was much simpler because I was able to jump into console and poke around. Well, we added this feature to Angular now. So if you look, I have an application, we have Angular IO application, which has this particular slider. And let's say for whatever reason this is not working properly, what I can do now in console, I can select the element that represents the slider. This is just regular DevTools. But in dev mode, we now have helper functions that allows us to poke around. I can grab a component for this particular element using getComponent and point it at the element. This, sorry about the screen. This allows me to poke around the element and even call functions like this close one. This will update the state of the component, and using some of these helper functions, I can trigger change detection and actually apply the change detection and see the visual results. With this, you have much easier access to Angular. You can debug your applications. Hopefully, you will not need to, because the compilation is getting better at catching errors earlier. But if you do have to, you can jump into console, and the debugging is simpler. One thing that I cannot underestimate, and I'm going to come back to this in a bit, is backwards compatibility. We learned a lot about the importance of backwards compatibility and the pain any kind of breaking changes cause. So a lot of focus with Ivy was making sure that even though we overhaul the entire compiler and the entire runtime, we are as backwards compatible as possible. I mentioned that we achieved some size reductions when it comes to building an application with Ivy. Well, how much are these? We are still in the development phase. We are a few weeks away from RC. But we already see that the small applications are 30% smaller. Medium applications are either on par or slightly bigger. This is something that we're still actively working on. But large applications see the most significant difference, where we see reports of up to 40% improvement in payload size. How did we achieve this? What is so special about Ivy that allows us to get these results? Well, to explain that, it's probably the easiest to look at an example. I'll show you a template, very simple template with a div and hello world, that is compiled using the Ivy compiler, NGTSC, into code that looks something like this, where we have three functions, element start, text, and element end. This is the generated code that you will see in the browser once you're debugging your Ivy application. Makes it much easier to debug. But for the purposes of understanding the size implications, we can forget about all of the arguments and just focus on the functions. The important piece of information is that every feature of the Angular runtime is now expressed as a function. We call these functions instructions, and in this particular case, we have the start element and end element expressed as individual functions, and the text in between also expressed as function. As we add more features to our templates, the compiler will start generating more and more functions and adding these functions to the generated code. So in case of interpolation, we have an interpolate function, we have interpolate instructions. If we add attribute binding, we have an instruction for that. If we add a click listener, there is an instruction for that. If you add style binding, there is an instruction for that. And different versions, different sets of bindings have different implications and bring in different instructions. The interesting part is that you only pay for the instructions that you're actively using in your application. The Angular runtime is currently composed out of about over 150 instructions. You will probably not use all of them. And the ones you don't use will just go away as part of the optimization and tree shaking. In addition to this modularization and the ability to shake away parts of the framework that are not being used, the format itself, the generated code, is much more compact and easier to minify. And the combination of these two features allows us to get the benefits that I showed you earlier. With Ivy being out in preview, we set a clear goal for version 9. And the goal was to make it possible to enable Ivy for all the applications by default. When we talked about the experience we want for developers once they start upgrading to version 9, we discussed that we essentially want it to be as simple as running one command. We want you to ng update and update both the core of the framework and CLI. And what this does, it not only updates the dependencies, but it also updates the build system, starts using the new compilers, switches over the development mode to use AOT compiler, and additionally, we execute migrations. In the past, we successfully migrated the community over through several breaking changes where APIs were deprecated and we want you to start using new ones. You'll see more of that as we deprecated some of the older APIs in the past. The part of ng update will update your application, bring it onto the latest APIs. But in addition to working with deprecations, we also identified several usage patterns that, even though they were unsupported and invalid, just happened to work in the previous versions of Angular. This was unfortunate because we didn't want to bring these invalid patterns to Ivy, and that's why we created automatic refactorings that we are rolling out as part of ng update that will update the application and get you back on the correct use of the APIs. Lastly, the part of the process is also making all of the libraries compatible with Ivy. Because if you think about it, compiling the application itself is only half of the process. All of the applications depend on libraries. And these libraries need to be made compatible with the new runtime. For this, we built a new compiler we call ngCC for compatibility compiler. And what this compiler does, it takes a library, whether you know it or not, all the libraries were shipped and that are in NPM. They are compatible with what we call Vue Engine. That's the previous pipeline, the previous rendering engine of Angular. And on NPM, you'll find JavaScript and metadata files that are compatible with this previous pipeline. What ngCC does, it takes these files and converts them over to Ivy instructions so that the libraries can then participate in the Ivy runtime and be fully compatible. Why we've done this? If you look at NPM, the answer is quite simple. There are hundreds of libraries, even whole component suites on NPM today. On all of them are Vue Engine compatible. And because we take backwards compatibility seriously, we also take forwards compatibility seriously. We didn't want or didn't expect that library authors would just overnight update all of their libraries on NPM over to the Ivy format. And if they, by some magic, did that, it would not be good for the ecosystem because not all the applications might be ready to update to Ivy, and those would break or become unsupported. Therefore, we decided on a very different approach. We decided with starting with the initial state where both libraries and applications are Vue Engine compatible. We, in version 9, are enabling Ivy for applications only. And we're using ngCC to convert existing libraries over and make them Ivy compatible. Over time, as more applications update to Ivy, the libraries will also update to Ivy, and using ngCC will become not necessary, except for the cases where your application still depends on libraries that have not been updated to Ivy. This creates this very incremental transition that reduces the risk to the ecosystem, to applications library authors. And to summarize, in version 9, applications will start using Ivy. The applications will get the full benefit. Libraries will also get the benefit of using Ivy because NGCC will turn them on the fly during the build process or installation process into Ivy compatible libraries. In version 10, we expect the instruction set to stabilize, and at that point we want library authors to start shipping Ivy code to NPM, making NGCC less important, and we are hoping that by version 11, NGCC will become just a backup solution for some of the obsolete libraries that have not been updated yet. To make sure that this library compatibility really works, we went to the great extent of testing, even creating a continuous integration project in which we verify that existing libraries work. Today, we are testing against 173 most popular libraries, and we're having about 85% success rate with these, improving the compatibility with every big and every release. If you are a library author, please go to this project and add your library. We'll be happy to work with you in case something does not work. However, considering the magnitude of the change, and even though it's an internal change, we don't want to be in a situation where some people cannot update their applications to version 9. And because of this reason, we are adding option to opt out of Ivy in version 9. This will allow you to still jump to version 9, get the benefits other than Ivy from version 9 when it comes to dependencies and improve it, CLI and build process. And still be able to try Ivy once the compatibility improves. If you do have to resort to opt out, please let us know. Please file an issue because we want to work on this and iron all of these issues out so that all of you can get to Ivy as soon as possible. One of the things that I want to leave you with is that Ivy is not just about improving the build time, the payload size, but Ivy is also an enabler. It really allows us to do new things with Angular that were very difficult or impossible to do before. And I'm going to show you two demos that demonstrate this. The first one focuses on styling and style merging. And I want to give credit to Matthias Nimla from our team that built both the demo and also implemented this particular feature. If you are a component author, you probably worked with style binding quite a bit. And you notice that in the past, when you had a component that had internal styles, had host binding, also had bindings to the style property itself, this didn't really work. Or it worked in a very surprising way, where the last binding that changed completely overrode all of the styles of the component. This was something that was inherent to how Vue Engine worked in the past and change detection worked in the past. With Ivy, we took this opportunity to actually rethink how styling works. And today, once you are using Ivy, the merging happens in a very predictive way, and you can have very sophisticated styles. So in this particular example, I have this model dialog that has some internal styles that are applied to it using host binding. But I also have a directive that sets additional styles on this component. I can enable this, and you see that everything behaves just as we would expect. But I also have styles that are binding directly to the property or individual fine-grained properties. And the cool thing is that no matter how I update all of these bindings, everything works just as we would expect, and the styles are merged. I encourage you, if you're a component author and build reusable components, to go to the repo and play with this to understand why this particular feature is so powerful. And I'm looking forward to all of the possibilities that this will unlock, especially when it comes to sophisticated animations and other things where merging of styles is very crucial. The second demo I want to show you is component lazy loading. Angular had feature lazy loading from version 2, but only at the route level. If you wanted to do any kind of code splitting and lazy loading, you basically had to use routing and do it at the route level. If you were super advanced, you figured out how to do lazy loading at the component level, but it wasn't pretty. It required a lot of boilerplate and some strings and wires and patches to make things work. With Ivy, because the internals of Angular are much simpler, we are able to do things that were not possible before. Let me show you how you can implement lazy loading of components with Ivy. So I have a simple application. What I would like you to do is when I press this rocket, it will load a component and add it to the view. Right now it's not doing anything, but I already have the click handler set up here. So let's generate a component. Let's call it lazy. Let's make it part of the lazy module. I don't need templates or styles. And let's replace the template with an Angular logo, just so that we have something very visual and very easy to recognize. Now let's jump back to this lazy click handler. And what I would like to do here is get hold of the lazy component by importing it. I'm using the dynamic import. And now I want to attach it to the view. So I already have view container that I'm injecting in this component. I can call create component. And unfortunately for now, I still have to use component factory resolver, which is a way to work with the legacy APIs that are part of the Ivy, part of the view engine, to resolve the lazy component into a factory. And now when I click the button, I see that, I cannot see on this little screen, that the bundle was loaded and the component was added. Awesome. We really think that lazy loading components in this way will improve the speed of applications and will make it much easier to build more fine-grained applications. As I mentioned, we're still working on polishing these APIs. I'm hoping that by the time we have a release candidate, all you have to do is just load the component and pass it into the create component methods. This is not working with the current development version yet. Awesome. So we talked a lot about Ivy and some of our aspirations to make Angular smaller, faster, simpler, and backwards compatible. It's been definitely a journey for all of us and the whole team. And I would like to invite Steven to come back on stage and tell you about how you could be part of this journey going forward. Thank you.
Thank you, Igor. Wasn't that awesome? Component level lazy loading. It's finally coming. I'm personally really, really excited about this. So I want to turn a little bit now back to everyone in the audience, because at the end of Angular Connect, you're going to go back to your job, you're going to go back to your computer, and you're going to say, what do I do now? And I want to make that really, really simple for you. So the first thing you're going to do is you're going to go enable Ivy on your project. So this sounds scary, but it's one command in your terminal, ng update at Angular CLI at next, and at Angular/core at next. If you have some dependency that doesn't think it's Ivy compatible, you might need to throw a -- force flag on. Don't be scared. Run that command, and two things are going to happen. Either it's going to work perfectly, or something's going to break. If something breaks, we have a really easy path for you. It's called our issue tracker. And we really do believe that now is the time for people to be trying Ivy, to be giving us issues. We want feedback about Ivy. We want applications to work, because the more that we can do right now, the better it's going to be when we turn on Ivy by default for everyone in version 9. And we've been working, like, it's so funny. We talked to Mishko or Kara. We had Ivy working years ago. But we spent so much time working on backwards compatibility because we care about bringing everyone in this room with us with as little pain, with as little work as possible, because that's how we're all going to move forward as an ecosystem. And if you don't file an issue, Igor's going to feel bad because he spent hours on the emojis, getting those little emojis in the issue template. So definitely do that. So if you are a library author, we want you to keep doing exactly what you're doing, compiling your library with the Vue Engine compiler. If you're not doing your own custom build, you should definitely be using ng Packager. ng Packager is the kind of officially endorsed way of building Angular libraries that follows the Angular package format, and we're always going to make sure that it's doing the right thing. So when we switch the default, when we switch what we should be doing, it's going to automatically update, and you shouldn't have to worry about that. I also want to just call out again, you should go visit the NGCC validation repository that Minko built. That has all those repositories. Feel free to add yourself, feel free to look into the compatibility of your dependencies and really understand. And if you are a library author that's having trouble with Ivy or you're seeing issues that you're not understanding, reach out to us. We want to help libraries because what we've seen is that whenever we fix one issue with a library or we help them understand what's going on or fix their packaging format, that can unblock a lot of different applications. So libraries are going to be very key to our strategy going forward. So we talked a little bit about our values at the beginning, but one of the things that I want everyone in this room to think about is how can these not just be the Angular team's values, but where are there opportunities for us to all share those values? Because we feel like when we do this right, everyone here wins, but we want you to be doing this right and helping all of your communities and all of your organizations win as well. So when it comes to apps that users love to use, when it comes to building schematics, all those sorts of things, we think that not just your experience, but everyone that you collaborate with really, really does matter. And even on the community side of things, we've seen a lot of teams be very successful by creating organizations, by creating meetups local to companies. And so if you're not already attending a meetup or creating some sort of community or a Slack channel about these sorts of things, this is your opportunity. And that's how we're going to really work together to make everyone's applications better. We're also participating in whole new ecosystems. We see the rise of ng-add, ng-update, and builders as a really kind of astonishing amount of ways for people to build and empower others without actually contributing to Angular. When we think about contributing to Angular, a lot of people think, oh, I need to go into the Angular repo and send a PR. But you're actually contributing to Angular by doing any of these things for yourself, for your team. If you're interested in figuring out how to find some of these tools and maybe how to be discovered as a tool that's being published as part of the Angular ecosystem, Alana's giving a talk called Finding Angular. The thing to think about is using these same sort of tools to automate your team, right? Whether it's just blueprints to add the right sort of copyright that your team needs for all your files, to developing standards. Jochen talked about this idea of actually using code to enforce these conventions, using an injection token rather than trying to educate everyone about, hey, which mode is my application in and how do I choose for every single component? And we also see that there's always opportunities for integrations across applications. In the past, we've been big proponents of things like monorepository strategies and continuous integration across multiple teams. And we really think that this is a great time for everyone to adopt those sorts of strategies. Another thing that we've been doing on the Angular team is that we've been focusing a lot on the future for a long time. We've presented a bunch of conferences over the last few years saying, hey, this is stuff that's going to exist someday. And we've actually pulled that back a little bit for this Angular Connect. And so one of the things that you're going to note is that every talk given by someone from the Angular team is going to be something that you can go do today by opting into the Ivy preview, right? Just do that ng-update command that I gave you, and all of the things, all the compiler capabilities, all of the features that Igor talked about, all of the benefits that come and all the thinking and hard work that we put into Ivy, you can try these things today, and now is a really good time. So to just kind of highlight some of those talks, Alex, right after this one, is talking all about the compiler. So how do we get from your template into these Ivy instructions that Igor was talking about and what happens along all those different steps of the path? Manu's going to be talking a little bit about the processes that the team has. We haven't actually been as open as we would like in the past about how do we build software, how do we prioritize, what mistakes have we made along the way, and he's going to share some of our journey there. Mishko is going to be going deep into the technical thought that we put into and the challenges that we've solved while building Ivy about how do we make Angular fast. Joey is going to be getting into how do we manage a project at the scale of Angular across GitHub, right? We have multiple repositories, we've got a huge number of team members, we've got a huge ecosystem outside. How do we keep all of this in sync? Rado is going to be talking a little bit about constraints and how sometimes by constraining yourself, by using something like declarative templates, you can actually empower yourself and actually create a more maintainable and higher velocity application. And Kara is going to be ending things with a talk about how Angular works from the Angular team, really looking at, okay, now we've got this compiled instructions. What happens? What are the data structures? What are the models that are underlying all of that runtime to make it work as the application exists and as the user uses it? So really, we wanted to kind of shift things. And instead of just saying, hey, here's the future, we want to make everyone here feel part of the team. We want you to feel like you know not just what Angular is doing, but how it's working a little bit behind the scenes so that you feel more comfortable collaborating, contributing, and understanding and being a part of the Angular team. So thank you, everyone, and we're really excited for Angular Connect this year.
Check, check. Hey, hey. Okay, there seems to be a little mix-up this morning with the lanyards, and I just want to tell you guys that the yellow lanyards mean you do not want your picture taken. And I think some of them might have accidentally gotten handed out. So if you have a yellow lanyard and you didn't ask for one, then just go swap them out, because if you get your picture on the Angular Connect website, you're basically famous at that point. So you really want to get the white lanyard if you want your picture on the website. Okay, so that aside, they asked me to do this introduction, and I was super excited because I am like a huge AG Grid fan. And I've been following AG Grid for like years, since they first started. And the reason I love, if you guys might already know this, the reason I love AG Grid is because it's wicked fast. And the reason it's wicked fast is because the code underneath is really nice. And so I've just always been impressed with them, and I started following them, and it's been a couple years, and they've built a really impressive team of developers, and still the code under the hood is very nice. So I really want to give a warm welcome, and please, let's give a hand for my friend Niall Crosby.
Thank you, Bonnie. Hello, Angular Connect. Hello. Have you ever had one of those moments in your life where you think, I can't believe this is actually happening? Well, for me, this is one of those moments. AG Grid is the premier sponsor of Angular Connect 2019. How mad is that? That's absolutely brilliant. As they say in London, that's wicked. That's sick. But no, it's really great. I've been coming to Angular Connect now I'm one of the 5-year people. I was here in 2015, and I spoke about AG Grid, and every year it's just gotten bigger and bigger and bigger. And this to be premier sponsor is just kind of shows how we've grown. And I just want to take this moment to thank everybody who's made that happen. So for the organizers of Angular Connect, the guys for the AngularJS meetup in London, but then also the users of AG Grid, especially those 5 years ago who took a punt when we weren't that well known, and they chanced AG Grid in their important applications. So I'd just like to say thank you guys for helping us along the way. Right, I'm going to do a real quick survey. If you use data grids in the applications that you build, just show me your hand. Stick your hand up in the air. All right, I'd say that's maybe half, slightly less than half the people in the audience. Thank you. So I see the JavaScript developers split into two groups. There's those of us who use data grids every day and absolutely depend on them, like I used to before I started AG Grid. I was working for the banks in London, and every application we built had a data grid. Then you have another set of developers in JavaScript who think data grids, they're not that necessary, that your UX is probably bad if you have a data grid in it, which is absolutely fine. What I see is that people who are delivering apps for consumers don't want to use data grids, but those who are developing apps inside businesses where you're working with a lot of data, data grids are critical. If you don't know what a data grid is, here's one. This one's called Mike. Mike, this is Angular Connect. These are the people you're going to have to perform in front of in a second. So as Bonnie said, one of the things that we're proud of is how fast AG Grid works. Mike here has 10,000 rows inside of it. That's 10,000 rows loaded into the browser. Any moment now, Mike is going to get updates. He's going to get 1,000 updates per second. And as this happens, just notice how fast everything is inside the grid. Right, there we go. The updates are coming in. Green means number went up. Red means number went down. So the scrolling, sorting, everything works really, really fast. But the question is, why would you want to have 10,000 rows inside a grid? Well, what you do is you start grouping. And you group those, and the grid will group the rows in the browser, and it'll also do aggregation. So for the group level, it'll calculate the average or the sum for everything inside that group. And as this is all happening, again, 10,000 rows, 1,000 updates per second, the grid is just extremely fast. There's no degradation in performance as your user is navigating through the grid. So this was actually the demo that I gave at Angular Connect last year. And what I'm going to talk about now is, well, some things that happened in 2019 and where we're going forwards with AG Grid. And there are two revelations that occurred to me over 2019. So first was, well, we knew we were doing pretty well in the grid space. I think we were becoming the dominant grid for JavaScript enterprise development. But during the year, I got contacted by these two gentlemen, by Brian Love and Lucas Rubelka. Brian and Lucas were asked to write a report for O'Reilly on the state of Angular for enterprise development. And they went through the Angular framework and suggested different libraries that you should use. Now, for the grid section, they have a whole chapter dedicated to the grid. They didn't go through all the different grids that were available. They just said AG Grid is the grid that everybody's using in enterprise. they had a catch-up with me as they were doing research for the book, and over this Skype call, they actually said to me that from what they can see, everybody in enterprise that they know is now using AG Grid to build their apps, and it's pretty much taken over. That to me was a revelation because I knew we were doing quite well, but for the industry to be standardizing an AG Grid, that was awesome. That was like amazing to realize. Then revelation number 2. This happened earlier this year at a conference where this gentleman, James Harrison, approached me. Now, James's company, they build finance applications, and they've been a customer of AG Grid for a few years now. And at this conference, he came up to me and he said that with AG Grid, it enables us to build applications that we would not otherwise be able to build if AG Grid didn't exist. That's not the first time I heard this. The first person to have said this was actually me. When I was working in the investment bank in London back in 2014, I was given a project to build, and the data grids in the market wouldn't be able to do the things that we wanted to get done in this project. So I ended up building AG Grid as an open source project. So with that, I was able to build my project and was able to do things that would have otherwise not been possible if it wasn't for AG Grid. And then another time this occurred to me as well was last year, we were in New York visiting one of our customers, one of the big investment banks. And they had this huge database of risk data that they had to collect for regulatory reasons. And with this big database, they wanted to expose it in a meaningful way to their users in the risk department. So what they did is they chose AG Grid, and they built a suite of applications giving a portal into this data to allow the users to access it and do grouping and slicing and pivoting, just like as if they were inside Excel, but it's connected to the live data set. And in that, they're able to do different business functions. So AG Grid enabled this risk department in this big investment bank to behave differently and do better work. So the revelation, to sum up, I knew that we had disrupted the dev tool space. So we'd made a big impact in developers' lives who were picking what toolings they were going to use. But we had also disrupted the business space. We were actually changing the types of applications that could be getting built. And using AG Grid, the community of AG Grid developers are able to do things that they would otherwise not have been able to do if it wasn't for AG Grid. So I'm going to show one example now of where we're moving things forward. A lot of you who put your hands up that you use data grids, you probably had the experience where you've built an application, it has a data grid, and then your requirements, the business says, can we also have charts? Your normal response is, that'll take about 3 to 6 months, and I'll have to hire another 1 or 2 developers. In AG Grid, we're trying to challenge that. We don't want people exporting from our grid. If you have an export to CSV or an export to XLS button in your app and your user pushes that button, that means your app has failed, because your user isn't able to do the things that they want to do inside your app, so they're bringing the data someplace else. One way we want to help solve that is to give the charting experience that you would find in Excel, but inside the data grid, and all you need to do is put this one attribute in to your grid configuration, enable charts. So next time somebody asks you to build charts, just do this. It takes 5 minutes, tell them it took 6 months, and take a holiday. Right, let me show you a demo. This is from our website, so if you want to try this at home, kids, feel free. But if you're going to use the scissors, make sure an adult is around. And this is just a standard grid, and I'm going to just go and select some cells here. I'll then right-click, bring up the context menu, and I see all of these chart options, and I'll pick the first one, grouped. I'll just move the chart down to the bottom left. I can grab the handle here, and you can see that the chart is updating on the fly as I pick different things. Okay. Thank you. And then we've got loads of different chart types in here. We've got the different bars, the columns, the pies. That's called a donut chart. I didn't know that until about 2 months ago. Lines, scatters, areas, different palettes. It goes on. It's really, really rich in functionality. It's almost like a mini app going on inside here. You've got loads of fine-tuning of the data. If you want to pick columns that aren't beside each other, you can pick them here. We can take different columns out, stick them in again. Here's a format panel where you can change different things around. Here I can put the legend to the left, to the right, blah, blah, blah. Lots and lots of stuff you can do. I won't go and show you more, but basically it's a very, very rich charting experience with just one line of code for inside the applications. I like Mike, that grid, lots of flashy lights, looks like a Christmas tree. So I'm going to bring Mike back, and I'm going to do a small bit of charting. So this is still Mike with the 10,000 rows and the 1,000 updates. So in a real-life scenario, you might want to group. Let's say I'll group by portfolio. I'll bring it to the group section. I'll let go. I'll then drag the, say, these many cells, right-click, chart, column, grouped, and there we go. Let me make that a bit quicker. Thank you. So that's the stuff that we're doing at AG Grid. This is the way forward. This charting at the moment, this is all in production. If you download AG Grid, you'll have access to these charts right now. We're incubating the charts inside AG Grid. That means that you can't use it as a standalone charting library yet because we're still building it. You can use it now in the grid, but if you want to use it separately, that's going to be available maybe in 3 or 4 months from now, but it's definitely our plan. So then, where does that leave us going forwards? Well, we kind of knew at the end of last year we were becoming the de facto data grid that there was, and that's been proven over the last year with feedback that we're getting. And we're now moving into charts. So our slogan has been for a while now, we want to be the best data grid in the world, and it's kind of beginning to feel like we're getting there. What we want to be going forward is we want to be the best data grid in the world and the best charting library in the world for JavaScript. We want to give the whole suite to enterprise developers. So when you are building enterprise applications, you'll pick your framework, and then you'll also pick AG Grid. And that will be the foundation for building fantastic enterprise applications to build apps that we wouldn't previously have been able to build. And with that, do our bit to make the world a better place. Yeah, make the world a better place. Yeah. Whoa. Woo. Ladies and gentlemen, you look like an awesome bunch of people to be with here for the next 2 days. I'm really looking forward for Angular Connect 2019. Thank you very much.
Wow, thank you so much, Niall. That was incredibly cool. I'm not sure I've ever seen a sponsor talk before with people getting a round of applause in the middle of it for the features. That's so great. Thank you so much, and thank you for your sponsorship. So, everybody, very exciting times ahead. The conference is going in full swing now, so we've got mini workshops happening. The expert zone is kicking off with a tooling session, and tracks are going to be on both track 1 and track 2 after the break. So, see you all shortly.
Just one line of code for inside the applications. I like Mike, that grid, lots of flashy lights, looks like a Christmas tree. So I'm going to bring Mike back, and I'm going to do a small bit of charting. So this is still Mike with the 10,000 rows and the 1,000 updates. So in a real-life scenario, you might want to group. Let's say I'll group by portfolio. I'll bring it to the group section. I'll let go. I'll then drag the, say, these many cells, right-click, chart, column, grouped, and there we go. Let me make that a bit quicker. Thank you. So that's the stuff that we're doing at AG Grid. This is the way forward.
everyone ready for the first talk? This is a full house right now. Oh my goodness. Alex, everybody is so excited to see you. I have the pleasure of introducing our first speaker of Angular Connect. Alex is a software engineer at Google. He also has done so many things. So he's been at Google for quite a while. He's been on the Angular core team for more than 3 years now. He's also really into sailing, so you can ask him about that if you see him. Throughout his time at Angular, he's worked on the service worker implementation for progressive web apps, server-side rendering support. He's also done a full rewrite of the HTTP API. Currently, Alex is actually working on the Angular compiler, which is why y'all are here right now. And he's getting it ready for the next generation architecture, Angular Ivy. You can also see Alex on the Ivy panel, which is going to be at 10:40 tomorrow morning. So everyone give Alex a big round of applause.
All right, good morning, Angular Connect. Let's just make sure this is hooked up. Perfect. All right, welcome. It's awesome to be kind of on the first talk of the first day here. We haven't even kind of begun to get started with this conference, and I've already run into so many people that I know from our community. So welcome, everybody. For those of you who don't know me, given that Tracy just introduced me, probably all of you do now, my name is Alex Rickabaugh. I'm a member of the Angular Framework team, and this is actually my 5th time talking at Angular Connect. I've been here every single iteration since the first conference back in 2015. And so I've been working on the Angular compiler, and that's what I'm here to tell you all about. Both how it works in general and some of the cool things that we're doing with it for Ivy. And I've been working on this compiler for almost 2 years now, but I thought it's important to start with the question, why do we have one at all? What is this compiler actually doing? And so I sat down and started brainstorming ideas for what I wanted to show you, and I realized that my own understanding of the compiler and why we have it has changed a lot over the last 2 years I've been working on it. So 2 years ago, Mieszko sat down with me in one of our kind of one-on-one meetings, and he surprised me by asking me how I felt about taking on ownership of the compiler project and getting it ready for Ivy. And I think the word that came into my head at the time was scared. The compiler was this black box to me. It's a different code base than the rest of Angular. I knew vaguely what it did, but I had no idea actually how it worked under the hood. And so today what I want to do is open up that black box and show you a couple of interesting things. I can't go into all the details with the time that I have, but just a few of the different things that you might not expect the compiler to be doing, but that we actually do for you as part of making your apps smaller and faster. But why do we have one at all? So the main job of the compiler is to turn the templates you write into the code that runs at runtime. And in Angular, you write your templates declaratively. Right? You specify what you want to happen, the components you want to render, the bindings you want to check, but not how it should happen. You don't describe the mechanisms by which change detection works. Browsers, however, do not understand declarative Angular template syntax. So we have to translate your templates into something the browser can understand. Calls to document create element to actually create the elements in your views, and calls to change detection to actually check, did this binding change from its previous value? Okay, we need to actually go update it. And so you might ask yourself, well, if this imperative code is needed anyway, why don't I just write it and save myself the trouble of going through a compiler entirely? And there's 2 very good reasons why it's worth the trouble. First, writing declarative templates means you deal with a lot less boilerplate. Right? The less you have to think about how something is happening under the hood, how you're doing rendering, the more time you have to focus on your business logic. And secondly, leaving the implementation up to Angular allows us to optimize things a lot for you. So browsers are not a static target. What was fast yesterday may not be as fast tomorrow. And Angular evolves over time to keep up with this and to keep your applications fast. And what allows us to do that is the flexibility of being able to change the implementation on the fly. So as I mentioned, the compiler's job is to take declarative Angular instructions, both your templates and decorators that you write, and translate them into imperative code. So here we have an example component, which is this pop-up panel. It's got a selector, it's got a short little template and an input. And when we feed that to the Angular compiler, it's going to look at this component and generate this imperative code. Right? Here we're calling into the runtime to create a component definition. We're passing some information about the selector, and we're passing this very imperative template function that's calling the Ivy instructions that we've talked about a little bit already. I won't go into any details about how this works at runtime. If you're interested in that, Kara's giving a great talk tomorrow on the subject. So our compiler can do this transformation in one of two different ways. The first is what we call just-in-time compilation, or JIT. And this is what used to be development mode in Angular. So when you build an Angular application in JIT mode, you're still taking your TypeScript code and feeding it to a TypeScript compiler, and it gets translated to JavaScript. But all of the Angular decorators that you've written actually end up in that bundled JavaScript, and they run in the browser. And when those decorators execute, they call our compiler, and they translate your templates and your other Angular features into imperative code. The other mode of operation that we have is ahead of time, where instead of running the plain TypeScript compiler on your applications, you run our Angular compiler, NGC. And NGC does the same thing that TypeScript does. It takes your TypeScript code, it translates it to JavaScript. But also, it takes the Angular decorators that you've written in that code, and it precompiles them into the imperative instructions for rendering in the browser. And that way, you don't have to pay the cost of doing that at runtime. So over the next 25 minutes or so, we're going to dig deeper into how the compiler works across 4 different topics. We'll talk about its architecture, right, how it actually, on a macro scale, processes your code. We'll talk about its compilation model, what that is and how it's changing. And we'll look at some of the lesser-known features of the compiler, the things it has to do in the course of compiling your code, including the last big one that we'll take a look at is template type checking, which is one of the most powerful things that we can do. So to understand how the compiler is set up, it helps to kind of know how TypeScript works under the hood, because our compiler is based on TypeScripts. So the regular TypeScript compiler has 3 different phases: program creation, type checking, and an emit phase. And the Angular compiler, as I mentioned, is built on top of that, and it uses all 3 of those phases. And additionally, we add 2 of our own, an analysis step and a resolve step. So let's go through these one at a time. Program creation is the process of TypeScript discovering all of the source files it needs to understand your program. And this begins with your tsconfig.json file. From that, TypeScript learns an initial set of TS files that are part of your program. And it looks at the imports of those and discovers more files. They might be in your app, they might be libraries that you imported from Node modules. And it looks at their imports and so on, until it's finally seen all of the code it needs to understand the types in your program and check them correctly. And in the Angular compiler, we actually add into this process a little bit by adding some extra files that you didn't necessarily write. And this is why it's possible to import, for example, ng factory files, if you're doing kind of some of the more advanced things in Angular today. The next phase of compilation is exclusive to our compiler, and that's called analysis. And here what we're doing is we're taking the full set of files in your program, and we're looking through all of the classes in them and trying to find ones that are decorated with Angular decorators. Right? We're understanding what the parts of your application are, the components, the modules, the services, and the directives. And when we find one, we kind of try to understand it a little bit. So if it's a component, we'll parse its template. And during analysis, we're only looking at these classes kind of on a one-by-one basis. So if we see a component, we might not have seen the module for that component yet. So we don't know what module it belongs to. We're just trying to understand them in isolation. And later on, after analysis is complete, after we've seen all of the classes, then we go into the resolve phase. And we look at everything again, but this time in the context of the larger picture. So we look at the component, we know what module it's in. And we can make more global decisions and optimizations based on that. And we can also surface errors related to the structure of your application. Like if you put a pipe in the imports of an ng module, we can tell you that's probably not what you intended. So just like the plain TypeScript compiler, the next thing we do is type checking. So we ask TypeScript to tell us about any errors that might have snuck into your program. And we also report on errors in your Angular templates. And as I mentioned, we'll get into how that works in a bit. And the last phase of compilation, we also share with the plain TypeScript compiler, and that's the emit phase. And during this phase, the TypeScript code gets fed through a series of transformations, and it emerges down the line as down-leveled JavaScript code that's ready to run in your browser. And during this step, as we're emitting JavaScript code for each class, we're also adding to it any of the imperative Angular code that we're generating if that class needs it. So we're adding all the template functions to components and things like that. This is actually the most expensive step in compilation, right? Translating TypeScript code to JavaScript. So those 5 phases describe at a high level what happens every time you invoke the Angular compiler. But every Angular application out there actually depends on running the compiler not just once, but many times. And you might not realize this, but even the very simplest app depends on Angular Core, which was compiled with our Angular compiler previously before it was shipped to NPM. And so those multiple compilations work together according to something called our compilation model. So let's look at what this looks like in TypeScript. So in TypeScript, if your project includes a file lib.ts, as you know, the compiler runs and it produces a lib.js file, right? And this JS file has no type information. It's ready to execute in a browser. But you can also ask TypeScript to produce a different file, lib.d.ts. And this is a type declaration file. It doesn't contain any imperative code. You can't execute it. What it does is describe the shape of the types declared in the original file. And this turns out to be pretty important. If you build an application that uses this library, and you import that library from NPM, TypeScript needs to know what are the types of the things you're importing, because it needs to check whether you're using them correctly. So to put that another way, what the DTS file is doing is it's carrying information about the types in this library from one compilation to the next. And so in Angular, our compilation model is quite similar. So just like with plain TypeScript, if you take a lib.ts file and compile it, say it has a component in it, for example, you get a JS file out. And the JS file includes the imperative code to run in the browser to render that component. But we also change the DTS file. And we include information about that component that future compilations will need. So any application that uses that component makes use of this information. So we encode inside the generic type of the component definition things like its selector, what its inputs are. And this allows us to do 2 things. One, it allows the future compiler to make use of this component, but it also makes it really clear that these pieces are part of the component's public API. And if you change them, the DTS file will change, and that probably means you need a new, breaking change for your library. So that means when we build an application that uses this library, the compiler knows, looking at this template, that this useful component is actually an instance of this thing that came from the library because it sees the information in the libdts file. So now we're ready to dive a little bit deeper into some of the things that the compiler actually does in the course of building your applications and libraries. And I picked a couple different features that I want to talk about that I think you'll find interesting. We're going to talk about ng-module scopes and what they are. We'll talk about this thing called partial evaluation. And finally, we'll go into some detail about how we actually check the types of expressions within your templates. So, ng-module scopes, right? What are these things? Well, we're all pretty familiar with referencing components and templates. So here we're using a user view component, but you might not realize that it's actually really tricky for Angular to associate the HTML element that you've written in your template with the component class that's somewhere in a library that you're importing. And that's because you, as a user, never actually wrote an import of this component. You only wrote an HTML element that happened to match its selector, right? And there could have been many components which match this selector. It's not likely, but it can happen. So how did Angular know which component you actually meant here? So if you've used Angular much, you probably know the answer. It all depends on the ng modules. So here we have a pretty simple arrangement with the module declaring 2 components. And this problem is relatively easy to solve. So because the application component is declared in the app module, all of the components declared in the app module are usable in its template. And we call that set of components the module's compilation scope. So the compilation scope here has both the app component and the user view component. But the picture can quickly get a little more complicated. So here's a slightly more complicated version where we've extracted the user view component into its own module, right? And not only does this module declare it, it also exports it. And that gives the module something we call an export scope, right, in addition to its compilation scope. This is the set of components that this module makes available to any module that happens to import it. So I've used a green arrow here for export as opposed to a red arrow for declaration. So in this case, the app module's compilation scope includes both the single component that it declares, which is the app component, and the export scope of all the modules that it imports. So in this case, the user view component via the user module. So by building this graph of module compilation and export scopes, the compiler is eventually able to figure out that this user view element that you wrote in the app component template can only be a reference to the user view component class, and it can generate code accordingly. And this is actually an optimization that the compiler is doing to help the tree shaker. We're looking at the template and figuring out, of all of the components in the compilation scope, which ones you're actually using. Because you might have a module that imports all of material, but if you only use the material button, we will only generate a reference to the material button component. And that helps the tree shaker be able to remove things that you aren't actually referencing. And I was actually pretty surprised at how complex it ended up being for the compiler to identify which components are in a template and be able to import them. And until I started working on this optimization, I didn't actually realize that ng modules had these kind of two different dimensions of both compilation and export scopes. So the next part of the compiler is my absolute favorite feature, partial evaluation. Did you know that the Angular compiler contains almost a complete TypeScript interpreter? Right? This is actually pretty crazy. So why would the compiler need to interpret TypeScript code? And the short answer is because we need to know at build time the actual value of certain expressions that you've written in your decorators. So for this ng module, we have declarations and exports. And in order to figure out the compilation scope and the export scope, we need to actually know what the value of these arrays are, which components you're actually referencing. And here, this is pretty easy because both fields are just array literals. We could read the TypeScript code and go, oh yes, this is a reference to one component, this is a reference to another. But this is actual plain TypeScript syntax, and you can do some other things with it. So here's a slightly more complex version. In this version, we've extracted the two components into an array, and we've used this to kind of deduplicate the declarations and exports. And this is a pattern that I see in almost every Angular application that I look at. It's a pretty simple refactoring, and it seems very natural to read. But think about what this means for the compiler. Right? It has to not only understand that ng module takes an object, which has the property declarations and the property exports, and that those are arrays, but it now has to be able to follow this reference to a completely different array that's somewhere else in your code and understand what's coming from there. So in order to do this, our compiler will actually attempt to almost run TypeScript code that you've written in your decorators and try to determine for a given expression what its value will be. And while doing this, we do things like follow property accesses, we expand object and array literals, and we can even execute some simple function calls. Right? Think about router module.forRoot. The compiler actually has to run that. And we can use this to understand even more complex things, such as importing a variable from a different file. Right? Thanks to partial evaluation, the compiler will actually evaluate the imports reference here and read the constant in the other module. And this gets really interesting. So here we have, this time the array is in a config object, right? Which is grouping together a couple different things. Not only does it have this module list, the developer here is also trying to calculate the size of the browser's viewport, right? Using document body, scroll width, and height. The problem is that when we're trying to evaluate this code at build time, There is no browser. There is no viewport. There's no document object. So how can we calculate a value for config when half of the things we need to determine it don't exist? And here's what we actually do for this case. We learn that config is an object with two properties, one of which is an array of modules, right? That we can understand. And the other is an object with two properties that we can't understand. And in this case, we return a special indicator type we call a dynamic value that indicates we reached an expression that we couldn't get past. We don't know how to evaluate document body scroll width. And this has two benefits. The first is that we can make use of the information we do know, right? We can still use the modules array anywhere we want to. And the second, we can give you a really nice error message and tell you when we encountered something we couldn't understand dynamically. And this is one thing the previous compiler for Angular tended to struggle at. You would get error messages that your metadata was not correct or something, and they were a little hard to figure out. So here what the user's doing is trying to use this viewport size in an inline style sheet. And the problem is the compiler needs to know the style sheet string here, because it needs to add style encapsulation. So this doesn't actually work. And what the partial evaluator will do is see, oh yes, your styles property here is an array of one value that we couldn't figure out because it took as an input another value that we couldn't figure out. And we should be able to use this to give you a really nice error message. This is something we're working on. So now we get to our last and final topic, which is template type checking. This is a pretty large and complex feature in the compiler, and we're going to look at it from a couple different angles. I think it's important to start talking about what the problem is that we're trying to solve. So here's a fairly simple Angular template. We have one component, we have one binding, and a slightly complex expression with an async pipe. And even in this pretty simple template, there's a lot that needs to be correct at runtime for this to work. Firstly, account view here should be a component, right, with an input called account. The getAccount function not only needs to exist, but it has to take the right parameters of the right types, and it has to return either a promise or observable because we're going to pass it to the async pipe. And whatever this user thing is, it better have an ID property because we're trying to read it. And lastly, you might not realize that the async pipe will actually return null before it gets any actual values. So the account input had better accept null as a possible value. And so there's some significant challenges to being able to type check templates. First of all, templates are HTML. They're not written in TypeScript. Right? The TypeScript compiler doesn't support checking HTML. And secondly, while Angular template syntax and TypeScript look similar, they're actually different languages. So Angular syntax, for example, has null-safe navigation, where TypeScript does not. And the TypeScript compiler just really isn't set up for people to be able to ask it arbitrary type checking questions. So the way we've made this work is actually really cool. The first thing we do is transform all of your templates and all the expressions in them into blocks of TypeScript code that we call type check blocks. And we never emit this code as JavaScript. You never see it as a user, right? We're never going to run it in the browser. They exist so we can feed them to the TypeScript compiler and have the TypeScript compiler give us back errors. And then we present you those errors in the context of your template. So let's build one of these things, right? Here's what the start of it looks like. This one is going to be checking the app component, which has this template. And it takes one argument, this context variable, and any expressions that refer to properties of the app component we can read off of this context variable. And next, we're going to declare two variables. The first is an instance of our account view component. The second is an instance of the async pipe, and we'll need both of these to be able to check this binding. Note that neither variable has a value, right? And that's okay because we only care about the types here. We're never actually going to try to run this code. So next we express the binding itself as a write to the account property on the component, right? And if this property doesn't exist, TypeScript is going to yell at us. And finally, we convert the expression into a pipe.transform call of a call to getAccount. And again, if any part of the types here don't line up, TypeScript is going to let us know. And so if you take this code and feed it to the TypeScript compiler, you might get back an error like this. right? Component.account is not an actual property. Or it might tell you that user ID is the wrong type for the getAccount method. So we're getting the kinds of error messages that we want, but there's a problem. TypeScript is showing us to them in the context of this random code that we generated, which is not helpful to you as developers because you never wrote this code. It'd be much better to show you the error as coming from your actual template. Right? And you might imagine that what we'd want to do is somehow generate source maps for this code that we're generating, and then feed that to TypeScript and have it give us back the error, just like we do with JavaScript. But unfortunately, TypeScript doesn't support this. So we use kind of a really clever trick instead. So here's a simplified example of what we actually feed to the browser, or sorry, to TypeScript, to check this binding. And in addition to the translated code here, where we've taken your template expression and turned it into TypeScript, you also see we have some comments with numbers. And those are offsets into the template of where we got that expression from. And so now when TypeScript gives us an error, and it says your error is here on this expression, we can look at the comment there and see where that expression came from in the template. And that lets us give you error messages in the context of your actual template HTML. So you can see here there's an error that the user ID in this binding was not of the correct type. But what happens if these templates are in an external file, right? Not in a TypeScript file? In the previous iteration of Angular, the View engine, this was kind of a problem point. You would get error messages that look like this. And if you've dealt with these much, you've probably learned not to trust the line offsets. They can kind of be a little confusing, or things happen to start at the beginning of a line all the time. There's not much indication here of where the problem actually is. We fixed this in Ivy. So now you get an error that's in the context of your template. We show you using TypeScript's really nice diagnostics exactly where the error occurred. And we also give you a pointer that here is the component that's actually referencing this template file. And that makes it much easier to kind of track down these problems. So the last thing that I wanted to talk about with template type checking is support for usage of NG4. And this has been another problem with the kind of the old ecosystem where it was not possible under the previous architecture. So suppose our template wants to repeat this account view component for some number of users, right, using an NG4 iteration. How do we go about type checking that? And the reason it's complicated is because the NG4 directive is actually generic. It accepts this type argument, T. And if you think about it, it kind of makes sense. NG4 is going to stamp out a bunch of rows, one for each user. So it has an input that's an array of users, or array of Ts, and a generic type for each row. So if we try to write a type check block for this template, we're going to run into some problems right off the bat. First of all, we need to know what the type of this directive is, the NG4 directive. How do we infer its generic type? And secondly, what's the type of the user loop variable, right? To answer the first question, we do something kind of cool. We generate this special function called a type constructor. Again, implementation is not important. It's not actually going to run. What this is doing is allowing us to use type inference to figure out, OK, for a given set of inputs to the NG4 directive, for example, the context users, which is an array of users, what is the generic type going to be? Right? And so if context users is an array of users, then the generic type is going to come back as NG4 of user. So the last problem, how we figure out the type of the loop variable, I almost gave up on because it's actually really hard. So the way this user loop variable gets set in NG4 is you call viewContainer ref.createEmbeddedView. And you pass in this context object. And the context object has a $implicit property, and this represents the actual value for each row. And the problem is that this is highly dynamic. Nothing in the NG4 directive says that it has to create rows with the same values as you gave in an array input. Right? It can use any value at once for the row. It just happens that NG4 likes to repeat over arrays. So I spent a lot of time thinking about this problem and ranting to teammates. And so I remember one day I was kind of venting to someone when I was banging my head against this and explaining why it was too hard to do. And I said something like, well, honestly, the only way this could actually work is if the ng4 directive would just tell the type checker what type it's going to create for each row. And I thought about that for 10 seconds, and then I was like, well, of course we're going to do that. That's exactly how it should work. So that's what we did. We introduced a static function on ng4 that we ship with Angular Common, and this is called the ngTemplateContext function. And what this does is allow the type checker to ask the ng4 directive what type of row it's going to create. So in this case, it's saying if the ng4 directive is of type ng4 of t, then the type of each row context is going to be ng4 context. And that'll have a $implicit type of t. So now we know that if it's an ng4 of user, that each row is going to be a user. And then it all comes together. We can infer the type of ng4 from its inputs. We ask the directive what it's going to use for each row. And from that row's $implicit, we know the type of the loop variable. And so for the first time in Ivy, we're actually able to type check within an ng4. Right? This was a pretty big kind of blind spot to our type checker beforehand, so I think this is pretty awesome. Yeah. So I wanted to give a quick shout out and heartfelt thank you to 3 amazing contributors who have worked on this stuff along with me and who've been really instrumental in getting both the compiler and NGCC, our compatibility compiler, and template type checking up to standard. So thank you very much, guys. So that's all I have for you. If you've enjoyed this kind of like more technical presentation, I highly recommend you see Mishka's talk later on today about how we make Angular fast, and Kara's talk tomorrow about how the Angular runtime works. So thank you very much, guys.
So amazing. Thank you so much, Alex. Make sure to catch Alex in the hallway and get a selfie with him. We always love selfies with our speakers, so thank you so much for attending. Next up, we have some amazing speakers. If you want to go check out Philip on track 2, and we're just about to get set up with John. All right, who is ready for some John Papa? Woo! Love John. John is so amazing. I love him to pieces. If you haven't checked out his VS Code extension, Peacock, it is so cool. For those of you who don't know John, he's an amazing, dedicated father and husband. He's, of course, also a web developer. He's the alumnus of the GDE program, Microsoft RD, and MVP programs as well. He loves coding. He loves teaching. We've all seen him on the internet. And, you know, he really enjoys everything Disney with his family. He's also a co-host of a lot of amazing podcasts, if you haven't checked them out. Adventures in Angular, Views on Vue. He's also the author of the Angular Style Guide, which many of us have used, and many popular Pluralsight courses. So go ahead and give John Papa a big round of applause, and welcome to the stage.
Thank you. Good afternoon, or morning, or it's that time of day, isn't it? You all having a good time so far? Yeah. All right, good. So who's ready for some more Angular? All right, you're feeling a little sleepy, aren't you? I'll have to wake you up a little bit. So today's talk, when I was talking with the event coordinators, I wanted to do something a little bit different and talk about the ecosystem around Angular. And the title of this talk is Less Servers for Your Angular Apps. But I want you to first think about, when you're building applications, it's never just Angular. I often am quoted as saying, the hardest part about Angular is not Angular. It's the stuff around it. Angular is relatively easy and smooth to use. It's the pieces around it that you have to do to build an entire application. So today I want to talk about how we build applications and the assumptions that we have in those applications when it comes to servers. So we're going to challenge our assumptions today. All the things that we just live by day and how we build our web applications. So the questions we should be asking, first of all, are static assets, HTML, CSS, JavaScript, images, fonts, all those things, are they the same type of content as a web API, as data being served off a server? When we serve static assets, are they the same concerns and things that we have to deal with when we deal with a web API that we might build with Node or ASP.NET, for example? And if you agree with me that there's different things you have to do for getting your data versus getting your static assets, and there's a different number of calls you make for your applications, what is the maintenance and the load on those servers? And that could be anything. That could be the physical cost, how much money it takes, how many servers you have to prepare. What do you have to do to make sure Node or ASP.NET is actually running on your servers? How do you patch them? What about security? All the different things you have to do with your servers. How do you scale up or scale down? All these things have to come into play. And the difference between a static server and a web API is very different. For example, if you build a very public web API, website, out in the web that has millions of users hitting it, the static assets get hit for that first page once with Angular, right? Most of them come once, unless you're lazy loading a couple other times. But your web APIs will get hit a little bit more than once on your application. And there's different things that actually happen to it, so the loads are different. And then when you build a real enterprise application, you generally have more than one environment as well. Do you have dev, test, staging, prod, load? You have all these different environments. Now you need multiple servers. And let's say you just have one server. You're a smaller shop. You just have prod. You go from dev to prod. God bless you. Let's say you just have one of those. Sometimes you need to scale up or scale down, so you need multiple servers to handle the load as well. So how many servers do you need? I've worked in shops where we had 7 environments, and we had to scale out to 10 servers in the production one. And you start doing the math, and even at a couple bucks a server, those things add up. So there's a lot of things to think about, not just the cost, but the maintenance on them all, keeping them in sync. And then, of course, you're running Windows 10, I'm running Mac, you're running Linux. You all build it works locally on your machines, but then you go to production, you don't know what you're running. You're in CI, you don't know what you're running, so you have to make sure these things are all into account. This is real-world stuff, right? And it has nothing to do with Angular. You want to get your Angular running in the cloud, you're like, it works on my laptop, can I go home? And that's where I am. So let's explore first what I'm talking about with this. You've got, let's say, a Node Express server. We could pick ASP.NET, PHP, Java, whatever. Let's say we have a Node Express server, and we want to see what it takes and how we can actually deploy an Angular app with it. So with that, we'll walk through Angular using TypeScript and Node.js on an Express server. So in this application, and I like to point out a couple times during the talk that everything I do today, you'll be able to try. All the GitHub repos, there's an article explaining how to actually do all this. There's 2 tutorials that you can walk through. And if you want to deploy it to Azure, there's a link that you can go to get a free account as well, so you can try that. So everything you need, I'll give you resources at the end. But in this application here, I've got, and we'll zoom in over on the left, I've got my Angular app right there in my source folder. And then I've got my app, and I've got heroes and villains. Hey, guess what? John Papa did a tour of Heroes demo. So everything in here is running for my heroes, my villains, inside of Angular. And then I have to hit a server. So I've got a server folder right here. And my server folder is running Express. If I come down and look at my server, you can see in there I've got Express and body parser, and in a full-blown enterprise app, I probably have about another 20 middleware options in there as well for logging and security, maybe Luska or Helmet for that. And then I've got my function right here that just kicks everything off, checks for environment variables, loads up my routes, loads my HTML and my static assets. Everything looks pretty good to go. And then inside my services and routes folders, that's where I'm holding on to my routes themselves, like heroes. When I see, hey, you got /heroes, go call my service in Express that says heroes.getHeroes. So I come down to that one, and now you can see I've got my async function for getting heroes, and I'm using TypeScript, which, by the way, is really awesome for Node Express, because now I can actually get all the types for my request response objects. And then I can go ahead and make my call out to my database and return my response however I want to. So all this is running through Express, and it works just fine. Now, no app is real unless we can actually run it and debug it. So I've got a bunch of debug configurations up here. These are also in the article that I'm going to point at the end, so you can see how to set these up. But the debug configuration I'm going to show you is, let's debug Express and Angular at the same time. So I'm going to select that one here. I'll show you over here kind of what that does. There's something called a compound inside of VS Code. I debug Express and Angular, and it points to 2 different debug configurations. These are the same names that you'd find up here. So there's my launch Angular configuration, which, if you don't know how to get that, I'm going to show you how easy it is to type that whole thing. A-launch Chrome. If you've got the Angular snippets, it just kind of types it in for you. And you can also do it for Edge if you're using Edge as well. We've also got our Express debugging right there too. So all that is set up for us. Now I can just press this button, zoom back out. That's what happens when you delete something. I just deleted my launch configuration. There it is. Now we press green button. And what it's doing is cranking up a couple of things. It's cranking up the debugger for Express, so it's building my Express app, and then it's going to hook to it and debug it. And then it's also building my Angular application. And then once it builds the Angular application, it's going to serve it and open it up inside the browser. Now you can see the debugger is already starting up here on the top of my screen. It's going to look a little bit different when it's done. That's because there'll be 2 configurations for debugging for my application. So here's my app, my tour of heroes. And then over here in my debugger, we can see that I can debug either Node Express or Angular. Now, you don't have to select one or the other. It actually does it for you. But you'll see, if I go enable my breakpoints, I flip back to the app itself, and I refresh. I'm now hitting a breakpoint inside my Angular application. And then I press run, and now I'm hitting a breakpoint inside my Node Express application. It automatically toggles between the 2. You can step, go into it, jump over it, anything you'd like to do. So the nice thing about this is now I've got my Node Express app that I can debug locally on my machine. And if I want to deploy it, I can deploy it 2 different ways that I really enjoy. One is what we call loose files. We can just take the files themselves from the builds and then X-copy them up to a server in the cloud, or go through GitHub through a CI process and then push them to a cloud. I'm not as huge of a fan of that as I used to be, and I'll tell you why. I've been burnt by this a lot. I'm building on my Mac here. It goes to my CI machine. My CI machine's running Linux, slightly different, right? All of a sudden, somebody upgrades from Node 10 to Node 12 on the CI machine, and they start pushing to production. and it breaks. Things aren't working. Now you've got 10 apps, 20 apps, 30 apps, and that can break. So what I like to make sure is that the environment I have on my machine, when it works everywhere. So I like to use Docker to do this exact thing. And in the same repo, once I destroy the debuggers, there we go, you'll also see there's a Docker file in here. And the Docker file is set up so we can both build the Angular application. It does everything you would do normally, basically npm install and then an ng build prod. And then it goes out and gets whatever version of Node I want, does an npm install. I'm using TypeScript, so I transpile my TypeScript for Node with Express as well. And then I take the final results and I push them up into a container. And now I have this Docker extension over here in VS Code, which you can download. And what I do is I just build it, and I'm just going to start it up because it's already on my machine, just so we don't have to watch it build. And now you can see it's running on port 7070 right there. And if I go back to the browser, and let's go ahead and open a new window. And there it's running in Docker. Don't believe me? We can go in over here and debug it. We can now say Docker attached to Node right up there in the debug window. And I think I left my breakpoints on, so now if I refresh, it's not hitting. Oh, it didn't start. You actually have to hit the green button. VS Code likes it when you actually tell it what to do. And there you go. So now we're debugging it again through VS Code inside of Docker. So I like the debug steps because it makes sure that everything runs the same everywhere you are. Now, let me get out of this mode for a minute. The reason we kind of went down this path is to say, when we build these applications, this is kind of the traditional way we've been building it with the server and a client. Now, imagine I take this Node server, and I have to deploy it out with multiple instances of the server with a load balancer on top so everybody can hit it. Maybe I've got a light and dark mode or an A/B mode so I can make sure I can put new things in. The Azure terms for this are like slots. You have one version of the site now, you want to put another version in later. This stuff can really add to the maintenance of what you have to do because you might need multiple servers. And what if you have multiple environments? Well, all we're really doing on the server is serving the assets and using a web API. So let's think about this architecture. Often, we're envisioning this when we run into projects. Like every time I go to a new project, I'm thinking, that's how it's going to work. I got a web browser, I've got a back end, it could be .NET, Java, Node, whatever, and I'm hitting a database. That's usually what happens when somebody talks to me and goes, John, I've got this problem, help me build this app. And usually, it looks more like this when I end up going to it. They're like, oh yeah, we're actually hitting these other back ends with different databases. Sometimes we get HTML, sometimes it's XML, sometimes it's fixed length format, and oh, this one over here is JSON. And I'm like, yes, one of them is JSON. And then they're like, but yeah, that JSON's like 10 meg of data. It's like, oh man, real world, you know? Well, then you start thinking about, can I change my back end? The budget for the project is to build an Angular app. You're an Angular developer. You're hired to build with the Angular app. You're not building the Java, .NET, and Node apps. And there may not even be budget or time to do that. How many of you here work under budget and time constraints? Nobody, right? Yeah. So when you have those issues, what do? There's numerous calls, large data, lots of different things going on. I like this pattern I call the presentation API. So let me show that one more time. We've got the web browser and our back ends. All we're doing is shifting this thing called a presentation API in between the back ends and the front ends. Now, this is an extra layer, yes, but it's super fast. What is super fast at input and output? I wish we had a technology like that. Node is great at that. So Node's one thing. ASP.NET Core is another thing you could use in there. You like Go, you can go that route. This presentation API's purpose in life is to aggregate the data, to make the bunch of calls for you. Because what happens if you don't have that presentation API and you make those 4 calls or the 5 calls from the web browser and you're on slow Wi-Fi? Are you going to let the browser make all those HTTP calls, aggregate the data, try to transform your XML into JSON, merge multiple JSON sets together just to show username John Papa? I've seen that, especially on mobile devices. That's killer. So the presentation API can do that aggregation. It can add a layer of security. It can transform the data. It can reduce the data. It can do all those things for you, or it can make database calls directly if there's new things. Think of this as an API for your UI. So now we've shifted the web APIs to a different place. This is what Angular sees. When you go develop with Angular now, you can say, you know what? I can even mock out that presentation API and use what I need right from there. Because I love to mock out my APIs, so then I can just build the UIs that make sense for me and my team. So we talked about Node and Express as a server. But now we're talking about, okay, we just went to building a presentation API. What if instead of Node and Express as the presentation API, we used serverless? Something like Lambda or Azure Functions or Google Cloud Functions. We can use serverless to do the same thing, and now we don't have to have a physical server that we deploy to, because serverless is built to scale up and scale down as we need, and we don't have to worry about setting up an actual server. If we go back to that diagram, we have a web server still too. Don't we need a server for that? Well, if we move the APIs over to serverless, now we just need to serve HTML, CSS, and JavaScript. Well, do we have anything in the web that can serve static assets? Absolutely. We have storage and we have CDNs, and they do these really, really well. So now you're taking your static assets, serving them from storage, any kind of storage container in the cloud. You can attach a CDN if you desire, and then you can serve those assets from there. You can serve your presentation APIs from serverless functions, and guess what happens to all your servers? Poof. It's serverless. So do you always need servers? And the serverless term is interesting because it doesn't mean you don't have servers. It just means that you think about them less. Somebody else is managing those for you. So doing this, you can reduce a lot of the maintenance, a lot of that load, and you still get quite a bit of the benefits in the process. You also have security benefits too. Have you ever had a server in the cloud where you had to put patches on it with VMs? Or you want to make sure someone else is doing it for you? Well, with serverless, these things are automatically handled for you. So a lot of ways you don't have to worry about them. Also, any code you write, you don't have to worry as much more about these kinds of hacking. And it also will scale up and scale down for you. And you can put on different kind of notifiers and logging to determine what's happening to your server at the same time. Super high performance with serverless as well. This is great for things like when you have like a Black Friday sale. You always hear about these sites that are kicking into things like serverless and scaling up and scaling down. You get really fast performance, you get high scalability, and the cost, if you pick a consumption model with serverless with any of the major cloud providers, you only pay for when you're actually running the functions. That's it. Whereas when you buy servers, you're paying for the server whether you're using it or not. So you may have heard this term before. It's called the Jamstack. The Jamstack is one implementation of how to do this. I like to call it serverless web apps. Jamstack is cooler, but I'm just not that cool. So serverless web apps, serverless for the functions themselves. I don't actually have to serve the static assets, and they are web apps, right? They're Angular. So with serverless web apps, the Jamstack, what they stand for, J is for the JavaScript. We've got that. APIs, we've got that too with our serverless technology. And our markup, we've got that as well. So all these things put together help us build our serverless web apps. Now, we're here for Angular, so what could this look like for Angular? Well, here's the real surprise. It could work for Angular, for React, for Vue, or for Backbone, if you prefer, in your application. So remember, this is what Angular sees. We talked about if we're using Node and Express in this case, our web server could be serving from Node Express, so could our presentation API. Now, if we go another direction, with the storage, we could actually use storage to serve the static assets. So now, presentation API is serverless, storage is running our static assets, and Angular is just looking at our storage assets to load up the web browser, to see our content, and then it hits the functions whenever it needs to get its data. So let's see a demo with the same application on how this could work. We're going to walk through a little bit of the Angular code, which doesn't change at all in this case, other than where it's pointing for its APIs. We're going to look at the TypeScript, obviously, both on client and server, because the serverless functions, you can use TypeScript. You don't have to. You can choose JavaScript or C# or whatever else you want, or Python. But we can use TypeScript. This way we can stay in TypeScript on the client and the server. We can see how storage works in uploading our files, and of course, we'll take a look at serverless, and I'll be using Azure Functions inside of VS Code. So here is our same application. I'm going to disable the breakpoints again. And we'll take another exploration over here at the application itself. Remember, we have this server, but we don't want to use that. We want to use Azure Functions. So I've got an Azure Functions project over here. How did I get that? Well, the really cool thing about the Azure Functions extension is that you can literally come over to Azure Functions over here, and you can click one of these icons. I'll show you what they do. This one here creates a new project. That one creates a new function. And that one, which looks like it's pointing at the ceiling, because that's where Azure is, that's deploying the function app. So if you want to actually deploy it. But you can run the Azure function app right on your machine without even talking to the cloud. So don't worry about Wi-Fi inside the conference center. You can actually try it. So once you create that project, I put it inside this folder, and then every function basically gets its own folder. And I named these kind of overly explicit to show what they are. I've got my heroes get function, and there's two files. There's a function JSON, which is configuration for the function, and it shows how you can set up this function itself. And the only thing I changed was line 10. The rest of the lines got set up for me. I could set up authorization if I wanted to, other methods. And in this case, I wanted the route to be called heroes. I don't want it to be called heroes-get. That's just the name of the folder it's in. And the function itself is this. So the function, and it generates this code for you, all you have to do is fill in line 5. So line 5 is, what do you want me to do when I get this route? When you go to API/heroes, what happens? Well, here's the cool part. I wrote this project over in Node and Express. So when I go look at my Node Express app, here's my hero service for Node Express. Let me open up the hero service for functions. Look similar? It is literally copy and paste except for two things. Line 1, Express. That's where I'm getting request and response. Line 1 on the other side, go get this context object from Azure Functions. Well, then you're thinking, wow, what's that other thing? The other thing here is, well, yep, I got request and response on the left, but on the right, I just used destructuring to get request and response out of context. So I copied the files over that I wrote in Express with TypeScript, put them over in the functions, made two changes, which is super fast to do, and then I can run my functions app. So let's take a look at this. Now this app happens to run against both, so I'm going to run a different port just to be explicit. My functions app runs against port 7071, and the Express app runs against the 7070. So we'll run that here. We've got another debug configuration up here for debugging functions and Angular. So I'm going to click on that one, and I'm going to press Run with the green button. And now it's going to run a couple different things at the bottom. It's going to make sure Azure Functions is set up on your machine, so it's opening a terminal to do that. It's got a really cool ASCII art setting that up. It sets up my routes, and then in another window, it's setting up the Angular build process. So if you look down here, you'll see there's 4 tasks open. It actually opens some of those to build this app, and then the app loads up here. And once again, in the debugger, we can see that I've got launch Angular, and I've got my functions. So if I go back and I go to my breakpoints, oops, and I enable them, which I'm doing by hitting this button right here. Now I go back to my app, and I refresh. I'm debugging in Angular. And now, just to prove it's happening, I'm actually debugging right there in my function app for my code. So all this allowed me to set up my presentation API running in functions. What's the other half, though? The other half is making sure my code runs in storage, so I can actually browse to that application. So Angular, as we all know, I'm going to turn off the debugger, and we'll kill those. As we all know, Angular has a dist folder, and inside your dist folder, you have all of your assets that you're going to deploy. Mine's called Heroes Angular, and then you can see all the build assets down here, including my index.html. So I did that ahead of time just to make sure we're ahead of the game. All I have to do to deploy this to the cloud is I can right-click, and I can choose Deploy to Static Website right there. Another way to do that is to come over to this Azure extension for storage, and notice I've got one here called Angular Connect. I created a storage account. That took me about a minute to actually create, so I did that in advance. You just have to press the button here to create one. And then once I created that, you'll notice you upload it, and it puts those same assets up inside the storage account. So you can also hit this button here to redeploy it. So if I make changes, when I press redeploy, it's going to ask you where do you want to go, what folder do you want to look inside of. Again, you can do it from over here. You can right-click on the heroes, deploy to static website. Again, choose this one here. Now notice what it's warning me about. It says the storage container already contains 21 files. If you deploy what's on your machine, it's going to delete those and put what's on your machine there instead. Are you sure you want to do this? And I'm glad it's there because I've almost done this to the wrong app many times. And then when it's done, I think I've got it running right here. You can see, and I haven't set up a custom URL yet, but you can see this is the storage site that it hit in the cloud for the Tour Heroes application that we're running. So now we've got the app running in storage, super fast. We've got the web APIs running in functions, super fast, no servers, and all I need is to set up a custom URL of my own. I could set a CDN up if I want to, and maybe set up cores or something to proxy the storage account over to the serverless functions. And we saw how everything works through debugging in VS Code. And this is important to me, because I don't know about you, but when I write code, I make a lot of mistakes. And when I make mistakes, I like to go through them and figure out what's actually happening. I don't write it right the first time. So you can debug your functions code locally. You can debug your Express code locally. You can debug your Docker code if that's the way you go locally as well. And then you can take front-end JavaScript like Angular, and you can debug that alongside your Node Express or Functions app at the same time inside VS Code. So today, I hope you rethink how some of these apps are being built and some of the ways you're deploying them, and some of the ways you're building them to be able to toggle back and forth to kind of figure out what's the right scenario for you. There is no one scenario. It's choose the right tool for the right job. So challenging our assumptions, 3 main tips that I'd like to leave you with. Consider the presentation API. Maybe there's a better word for this out there somewhere, but basically it's another API server that can straddle, if you have that problem, all the different APIs that you have to talk to. Consider creating one of those, consider creating a storage account and using serverless with it. You can create your serverless functions, you can create your storage account, and then tie the two together to build your Angular app and deploy it to the cloud. If you need more full control over your servers, absolutely build your own server and deploy it to the cloud using Docker or loose files. That's another option that you can do. And it's absolutely fine either way. You've got to weigh the balance between the cost, and I don't just mean money, but the cost of your time, the resources, and the effort for building both types of solutions. And as promised, if you have any questions on any of this, you can walk through exactly what I did. There's a static site tutorial up at this link here. And I'll post this up on Twitter later too, so you don't have to worry too much about taking photos. Static site tutorial will walk you through creating a static site from scratch and deploying, I believe it's a React app, forgive me, that deploys the cloud, but you can deploy any app that you'd like. A serverless tutorial lets you build a serverless function from scratch and then take that function and also deploy it to the cloud. If you want to use all the cool extensions that I had, this AZ Tools extension will give you the Docker extension, the storage extension, the functions extension. It's excellent, and it works really well inside of VS Code. If you want to try pushing it to the cloud, there's a free link right here. You can sign up to get Azure for free. And if you want to learn how to do the Express app over to Functions, because I kind of made that a side note, where you can build an Express app and then move and migrate that to Functions. I wrote an article on how to do this. You can find it at that link. And then, of course, all the code that I showed you can get from this link right here. Sorry for all the links, but it was a lot of content, and I hope you have a great conference and that you challenge your assumptions this week. Thanks for coming.
Thank you so much, John. And if you don't have a Twitter, make sure to create one and follow John_Papa on Twitter to get those links. Thank you so much, Sean. Next up, we have 2 really amazing talks, Kim and Manu. So if you're going to change rooms, feel free to change rooms. If you're going to stay here and you're bored for a few minutes, I have some really amazing women in tech stickers on this chair over here. Other than that, we will see you in just a few minutes. All right, who is ready for some Kim? I'm ready for some Kim. Kim also brought this amazing camera, so you can come up to her after the talk and take a selfie with her. It's actually a Polaroid, so everybody go ahead and smile and put up your hands, and we'll give her a selfie for this one first. There we go. Okay, Kim, that's for you for later. But again, it comes out, so if you want like a signed picture of a picture with Kim, you can do that later on. Okay, so I love Kim. She's an Angular consultant. She's also a Google developer expert, and she also is working as manager of community and technical content for Auth0. Recently got a promotion. Congratulations. She's passionate about identity, authentication. She's constantly learning, and of course, passionate about the Angular community. Kim organizes Angular Ann Arbor, and she also enjoys running Angular authentication workshops if you've been to one before, and she loves mentoring engineers as well whenever possible. You can also see Kim today on the security panel at 2 p.m. So without further ado, let's go ahead and give a big round of applause for Kim.
Thank you, Tracy. So I am here to talk to you about the science of authenticating Angular applications. And Tracy already sort of said a lot of this, but my name is Kim Maida. I was actually promoted to the head of developer relations at Auth0. Auth0 is an identity and access management company. I'm a Google developer expert in Angular and web technologies, and I run the Angular Ann Arbor meetup. Now, I work in the field of identity and access management, and when I saw this tweet, this really sort of resonated with me because it's something I see a lot. So developers come onto a project, they're tasked with working on the authentication code, and then their lived experience ends up looking something a little more like that. So I want us to take a little bit of a step back here and do sort of an introduction to authentication for web apps. And I mean all web applications, not just single-page apps. So if we go back and talk about cookie-based authentication, for example. Cookies are how we traditionally secure applications that are sort of back-end web apps, things that are built in sort of like PHP or .NET, for example. And the way that cookie-based authentication works is something like this. You have your browser, and then on your server, you'll have a back-end application and maybe a database. And when the user is going to log in, they submit their credentials through the browser. Those credentials get sent to the server, which verifies them. And if everything is successful, then the server is going to set a cookie in the browser. Now, this cookie represents the user's session. And at this point, the user is authenticated. Now, on subsequent requests for pages that maybe contain sensitive data, or whenever there's traffic to this domain, then what's going to happen is that cookie is automatically attached with the request by the browser. And this is a browser thing. It'll just do this automatically. It's sent to the server. And then if everything checks out, then the server is going to return any HTML and sensitive data that the user requested. Now, if the cookie is expired or there is no cookie, then and a request is made for protected data, then what's going to happen is the server is going to return a 302 redirect status. And what this is going to do is it's going to tell the browser to do a full page redirect to go somewhere where the user can re-authenticate. Now, once that is done, then the server is then able to send secure data once more. Now, we are Angular developers, so we traditionally build single-page web applications with Angular. And the method of authentication that's more popular with single-page apps is to use token-based authentication. This works a little bit differently from cookie-based auth. It looks something like this. Again, we have our browser. And when a user navigates to our application, what happens is that application is compiled, downloaded, and then it runs in the browser itself. So where we get data is traditionally from APIs. Now, the authentication process itself is often done using something called an authorization server. And really what this is it's just kind of a fancy word for a set of endpoints whose purpose is to issue tokens. So when the user submits their credentials to log in, once they've done that with the authorization server issues a token which gets sent back to the application in the browser. We can then send tokens with HTTP requests that we make to our APIs to get data. And the API is then going to verify the token with middleware. And if everything checks out with the token, then data is returned typically as JSON to the browser. Now, here's a question, though. Why do we do this? Why don't we use cookies for single-page applications? And it really comes down to the fact, primarily, that cookies only work on the domain of the application. So if everything is on the same domain, your API and your application, then that's great. Cookies are going to work out for you in this case. But many single-page applications call APIs that may live on different domains. Or if they don't right now immediately, they may need to scale and do so in the future. So if you have an API that lives on a different domain from your application, then that same session cookie is not going to work because they don't work cross-origin. Now, maybe this is you. Maybe everything is on one domain. Your API is on the same domain as your front-end application. And actually, if you have that type of architecture, you may very well want to consider using cookies to secure your application. So if you have stable architecture, you're not calling any third-party APIs, you are pretty sure you won't be in the near future, then you should consider doing authentication with routes that are served from your back end. And then you can just use cookies to secure the data that moves in between the single-page application and the back end. There's one thing that you do have to sort of keep in mind if you're going to do this, though. And that's if we go back to how all of the whole dance works with the server and things, then when an app uses cookie-based sessions, and a user tries to access a page, then if they're not authenticated, that server returns that 302 redirect status, right? And then it redirects the entire browser to somewhere where the user can log in again and get authenticated so that a cookie can be generated. On the other hand, single-page applications request data using AJAX calls. So in this case, if the cookie is expired or there is no cookie, then the response that they get is still going to be a 302 authentication redirect, right? Because we're using sort of the structure of securing the entire ecosystem with cookies. So in your single-page application, that expects a response that's in the form of JSON, I'm sorry. So you'll need to add logic to the application to handle what happens when it gets a 302 status instead. And this is fine. A lot of applications do this. It's not really that much work to add this in and to sort of prompt the user to go somewhere to re-authenticate when you get a 302. But if you do know that you're going to need to scale, or if you already have APIs on other domains, or you know you're going to implement some soon, then really the solution is to use tokens. So on the topic of tokens, I want to talk for just a moment about storing them. And really, you should not store sensitive data in local storage. The problem with this is local storage has a distinct lack of data protection. So here are some of the concerns that we would need to keep in mind when we put something into local storage. For one thing, local storage is accessible to any JavaScript that's running on the page, which means that something like a cross-site scripting attack, if you have a malicious script on your page or a compromised third-party script, then anything there could read the local storage object and steal anything that's contained within it, which could be something as sensitive as a token, which gains users access to your APIs. Now, cross-site scripting can also sort of work the reverse way, and you could load malicious data into your local storage. Something malicious could load malicious data into your local storage, which can potentially make it somewhat of an untrustworthy source. And then finally, all local storage is shared within an origin. So what this means is that if you have multiple apps running on the same domain, then they all have access to that same local storage object. And if they all have independent authentication, then you can see how this might get messy really quickly. But the most common reason that we put tokens in local storage in the first place when we make single-page apps with authentication is for session persistence, right? Because the user still needs to have the token if they refresh or if they leave for a short period of time, they come back. It's not a great user experience if we're making people re-log in every time they come back, even if they were only gone for a second. So the question becomes, if we shouldn't store tokens in local storage, then how do we do this and still maintain that session persistence? And really, you should store sensitive data in app memory, but this doesn't solve the session persistence problem, right? So when a user authenticates, what happens with an authorization server is that it's going to set a cookie in the browser. And this cookie represents the user's session with the authorization server itself. So the cookie doesn't actually contain sensitive data. It just tells the browser, yes, this user is recognized by the authorization server, and they have an active session with us. So then if we refresh the browser, we're going to lose all of the tokens and data that was stored in app memory. But what we can do now is we can check that cookie. This is called check session. And if the cookie is still there and still valid, then we know that user has an active session with the authorization server. And what that does is it allows us to request new tokens silently without prompting the user to re-enter their credentials. So with that said, there's some guidance around using token-based authentication with single-page applications. And I'm going to start out with just a really quick history lesson. In 2012, when the OAuth 2.0 spec was initially adopted, single-page applications weren't mainstream yet. So for example, AngularJS didn't really become popular until around 2014. So at the time that this spec was written, it wasn't really written with single-page applications at the forefront. So historically, the advice that was given in OAuth 2.0 was that tokens should be delivered via a browser redirect. So what this looked like was something like this. The authorization server would send the token back to the application in a hash fragment in the browser. Now, there's inherent security risks with doing something like this. For example, the token is vulnerable in a number of places with this paradigm. It's vulnerable in the redirect URI, which could potentially be, the whole thing could be hijacked, so that the token gets sent to the wrong redirect URI, and then whoever owns that redirect has access to the token. It's also accessible in browser history, which JavaScript can access. So if you have XSS attack, then it can read all of your browser history and just grab the token straight out of there. And then also, it's potentially accessible in the refer header. So if a malicious page was requested right after authentication, then that token could be grabbed out of the refer header as well. Finally, the last part of this is that the application itself doesn't sort of automatically know where the token that is being given came from. Now, it could have been maliciously injected from somewhere else. It could be somebody else's token. You could be having like a privilege escalation attack. So the thing is, though, authorization servers and application developers have worked for years to mitigate these types of security risks. There's no new threats to this approach. And I want to make that really clear. There's not any new attack that has come out that all of a sudden makes doing this way more dangerous than it has been for the last 7 years. Nothing new has changed there. So the same mitigations will continue to work. But the thing is, now modern JavaScript is really just eating the world of web apps. And what this means is it's just time to recommend new best practices. So maybe we don't have to worry about these mitigations so much anymore. And the new best practices is actually the same approach that's used in mobile applications. And the way that this works is you have your single-page application running in the browser, you have your authorization server, and I'm going to go through this a little bit quickly, but essentially the gist of it is this. In your single-page application, you want to create a high-entropy random string. This is called a code verifier. And then from that code verifier string, we're going to compute another string, and this is called the code challenge. And we're going to use a hashing method called the code challenge method in order to compute this code challenge. Now, when the user goes to log in, we're going to send the credentials and the code challenge to the authorization server. The authorization server is then going to generate a code, and that code is going to be sent back to the browser and received in the URL in a hash fragment. And this is actually fine, because interception of this code by itself isn't dangerous. The code alone is not going to give an attacker access to anything. Because what we need to do now is, once we have that code in the browser, then what we are going to do is send the code and the code verifier to the authorization server. So this is a multi-step process now. And what is going to be done next is on the part of the authorization server itself, it's going to use the code challenge method, which it was given earlier, and it's going to calculate the code challenge from the verifier. And then it's going to compare the code challenge that it calculated itself against the code challenge that the application sent in sort of the first pass with the credentials. Now, if those two challenges match, then a token is issued and it's going to be sent to the application in a JSON object. So basically, all of the mitigations that I talked about before with all of the risks that are inherent in putting the token in the URL, none of that's really needed anymore. And if you want to read more about sort of how this works, you can check out the draft for best practices for browser-based apps on IETF. The link is at the bottom there. And this is a lot, right? It's a multi-step process. There's like, you have to generate all these random strings, and there's hashing involved. But the nice thing is authorization servers and sort of open source maintainers, people in the security world, have created SDKs that will offload all of this work. So you can use an SDK that will handle all of this for you. So if you have a greenfield application, you're building something brand new right now, and you need to add authentication to it, you should probably consider using the new approach. It's just more secure, and you don't have to worry about all of these other mitigations. But like I mentioned before, there's no new threats. So for existing applications, if you have big applications running in production, if you have things that you're already sort of down to the wire on, there's no new threats. If you've mitigated the risks to the sort of the approach that was initially drafted in 2012, you're okay. It's not going to be the end of the world. But if you can consider switching, then you probably should. Which brings us to the second half of my talk. This is an Angular conference. So how does Angular as a platform help us deal with authentication and the things that we need to take into consideration when we're authenticating apps? And what I'm going to do in order to address this is sort of an Angular authentication to-do list. I'm not going to stand up here and live code a to-do list. It's really just a checklist of things we want to remember. So one thing we want to be able to do in Angular is elegantly manage authentication events. This could be things like token availability. It could be user info. It could be login status. We need to be able to send the token to our API with API requests. And then finally, we want to be able to restrict access to certain routes in our application. So if we take the first item, managing authentication events. Angular has this awesome library packaged with it called RxJS, and this can really, really help us out in a number of ways. And one way that it can do this is it can help us interact with SDKs reactively. So I know that probably many of you have used other libraries, other SDKs. By and large, if they're not built for Angular, they're not reactive. They use sort of async await or promises or callbacks or something like that. So what we can do with RxJS is we can turn things like that into observable streams for easier consumption in Angular. For example, maybe we are using an authentication SDK, and that SDK maybe provides a callback that is going to return token data from our authorization server. So what we can do with RxJS is we can use something like bind node callback or bind callback, depending on the type of SDK that you're using. And this is going to create an observable that emits when that callback completes. So once you have something like that, then you can subscribe to this observable. And then you can also pass it options. You can pass options to the bound method at the time of subscription. And then you can do something with the result when that data becomes available. Similarly, if your library returns promises, then we can use the from observable creation method in order to convert a promise to an observable. So the other part of this whole cycle that RxJS really helps us with is creating streams of data to help us know when things are happening. So for example, like I mentioned before, token availability, user info, login status. So if we take the example of user info, we could do something like creating a private behavior subject in our authentication service, and this could represent our user data. And then when this data changes as a result of authentication events, then we can use the next method to to emit new values from this user's stream. And then, because our behavior subject was private, we can publicly expose it as an observable to the rest of our application, which allows us to subscribe to it and then react to changes. We could sort of make changes in the UI, show the user's name in our template when they get logged in, things like that. So these are really just a couple of examples of how RxJS can help us to manage things that are sort of related to the ecosystem of authentication. And I'm sure you can find a lot more ways to do this on your own. If you do, I would love to hear about them, so please let me know. So if we go back to our to-do list, we have now learned that we can elegantly manage authentication events by taking advantage of RxJS, which leads us to the next item, which is sending the token with API requests. Now, we use HTTP interceptors to do this, and what these do is they transform requests or responses. So when we call our API, we can intercept requests using an interceptor service, and as we're doing that, we can attach an authorization header with the value of our token, and then we can send the whole thing on its way so that it is then authorized and the API has the token when it receives the request. The way we would do this is in our app routing module, we have this providers array, and we're going to want to provide the HTTP interceptors token from Angular Common. And then we're going to provide a class that tells the interceptor what its actual functionality is. And then we can set multi to true, because we could define multiple interceptors. And if we do this, they're just going to run in the order that they're provided. So if we take a look at that interceptor service class, in it we have some necessary setup, which isn't shown here. There's an intercept function, and inside that function we might have something that looks like this. So first thing we're going to do is we're going to clone the original HTTP request that came in. It doesn't have the header yet. We're going to set the header on that cloned request, and then we can send it on its way to our API. Now, Angular doesn't have a way out of the box to only put interceptors on specific requests, but we can just use traditional good old conditional logic to do this in our interceptors ourselves. So as sort of a simplified example, you can clone and modify the request based on some condition that you define. For example, you have access to the original HTTP request, so you could grab its URL, see if the endpoint should be secure, and then if so, clone if necessary, and if not, then just send the original unmodified request on its way. Another thing we can do is we can create asynchronous interceptors. And this can be particularly useful if we have a page, for example, where when you come to the page, requests are made without some kind of user interaction. So we need to make sure that the user is fully logged in, the application knows that they're logged in, they've got all the authentication information before we actually go and start sending requests to the API. So maybe we could use RxJS to do something like create an auth token stream in our authentication service. And maybe this will emit the token once it becomes available. And we can use merge map here to ensure that if we have multiple requests that are being sent out, that none of the previous requests are canceled by a new one that comes in. So now if we come back to our slideshow, which died. Sorry, don't know why that happened. Okay. Keynote quit unexpectedly. Thank you. Never would have guessed. Okay, so back to our to-do list. We now know that we can use interceptors to send the token with API requests, which leaves the last item, which is restricting access to certain routes. So many of you are probably already familiar with route guards and the concept of route guards. Route guards implement 3 different interfaces, and the most commonly used sort of default one that everybody learns is called can activate. And what's significant about CanActivate is when you protect a route with CanActivate, the code for anything that's behind that route is actually still loaded in your bundle. So it's still going to be in the browser. It's still accessible to somebody who's savvy with dev tools. And if they want to look at the source, then they can see everything that's in there. Now, CanActivate Child prevents unauthorized users from accessing children of a specific parent. But it works similarly. Again, the code is still going to be in the bundle. Now, the last one is CanLoad, and this one's a little bit different from the other two because essentially it prevents lazy loaded modules from downloading to the browser in the first place if the user is unauthorized. And we'll start with CanActivate. So in our app routing module, when we set up our routes, then we're going to use the interface name as a property in our route settings, and then we can pass in an array. So we can have multiple guards. They're going to run in the order that they're provided. And our authentication guard service might look something like this. We're going to have a CanActivate function, and this function is going to return an observable, a promise, or a Boolean. So in this first example, I'm just going to return Booleans. But in my CanActivate function, I can deny or grant access based on some condition that I define. So maybe my authentication service has an isAuthenticated method that just returns true or false, telling me if the user's logged in or not. If they're not logged in, I want to return false from this function to tell the browser that access should not be allowed for this user to proceed to this route. I can also do something like sort of a side effect. I could navigate them off to a login page to indicate that they should probably log in if they want to access that section. And then if they are logged in, then I'm just going to return true. Now, guarded lazy loading works a little bit differently because we're going to asynchronously load sections of our application only for the authorized users. And it still holds true that you wouldn't put sensitive data directly in your front end. It's just things like that belong on an API where it can be additionally protected. But this does give us a couple of benefits. It gives us a little protection, and it does give us smaller bundle sizes, which can be really helpful. So in our app routing module, when we're setting up our routes, we're going to lazy load a routed module. And in this particular example, I'm using an admin module. So maybe this is a whole collection, it's a whole section of the application that only people with admin privileges should be able to access. So I'm going to use my CanLoad property. I'm going to pass in a guard, in this case, called role guard. Now, this guard I could potentially use with various different roles. So maybe if the user is supposed to be an admin, I have an admin section, I have an editor section, I have a user section, etc. And how it's going to figure that out is by using route data. So I can pass in an object to this data property. I can say the expected role for this particular section is that the user should be an admin. Now, my auth role guard is going to have a CanLoad function, similar to the CanActivate. And this function, again, is going to return an observable, a promise, or a Boolean. And in this case, I'm actually going to be returning an observable instead of a Boolean. And inside my CanLoad function, I might have something that looks sort of like this. So if we come in here, maybe I have a stream for my isAuthenticated status now. It's going to emit true when the user's logged in. It's going to emit false when they are not. And what I can do here is I can use something like the tap operator to execute side effects if I want. So I check to see if the user is logged in. If they're not logged in, then I can do something like, for example, have them log in and redirect them back to this place. So in our CanLoad guards, we actually have access to something called segments, and this is a URL tree. So we can get the URL, the target URL that the user is trying to get to. So once I have access to that, I can maybe call a method for logging in, and maybe that method has a way to redirect the user back to a path that I pass in after they're successfully authenticated, that they don't have to sort of navigate back through the app and find their way back here on their own. Now, if the user is logged in, but maybe they don't have the role that I expected, maybe they're just a user and not an admin, then I could do something like redirect them to an unauthorized page. So if we come back to our list, we have now covered how to restrict access to certain routes using the various different types of guards. And we've basically finished this list. So in this talk, in the first half, I basically covered authentication basics, talked about some best practices, and then also I covered some strategies that you can use with the Angular platform itself to help you make authentication go a lot smoother, be much more palatable and digestible when you're tackling it. So the slides for this talk are going to be posted here after I get off stage. And I really appreciate you giving me 30 minutes of your time today. Also, I have t-shirts, stickers, and a Polaroid camera. So if you want to talk about, if you want any of those things, or if you want to talk to me about auth, please do. Thank you very much.
Thank you so much, Kim. I have a few announcements as you all are going. And again, Kim does have stickers down here, a Polaroid camera where you can take pictures. I have some women in tech stickers down here as well. We have a community lunch, which is going to be on the second floor. It's going to be hosted by Maxime, Stephen Fluin, and a few other folks. Come check it out, especially if you're thinking about starting an Angular meetup or run one already. We'd love to meet you. In addition to that, next slide, if we could. Coming up, we are going to have, after lunch, Mishko speaking in this track. We'll have Dominic and Uri speaking in track 2. There will also be a mini workshop, and then expert zone on security. Next slide. Lunch break. Lunch break is hosted on floor 2 and 3. If you have dietary restrictions, you can definitely ping somebody and let them know, and we'll get that taken care of for you. And I believe Ed is here somewhere. No, he's not here? Oh, okay. All right. And I think that's it. So come on up, come take selfies with Kim, come grab some stickers, and we'll see you after lunch.
Hello, everybody. Hello. Hey, how you all doing? Is it good lunch? Tasty? Yeah, good. Everyone full? I didn't realize until I had one of the boxes, and then I was told that I could have more than one box, and I was thinking, this is going to be a hearty lunch. Lovely. Okay, so we're going to do another Slido poll to kind of kick things off. So everybody, could you please get your phones out again and head on over to slido.com or sly.do and put in the event code Angular Connect. And head on over to the Get Interactive room. And the question is, which country are you from? I think this is our only free text field entry. So let's see how this goes. Let's grab the results up. This means Germany's winning. Germany, the Netherlands. The United Kingdom's very small. Wow, this is amazing. So many countries. Wakanda, Romania, Netherlands, Finland, Brazil. Brazil, who's from Brazil in here? Wow, that's a big distance. Thank you so much. Slido now, which is good because this is a good time to start thinking about submitting questions to the Angular panel. So tomorrow afternoon, we're going to wrap up the day. We're going to get all the Google Angular team up here on stage, and we're going to be asking them a bunch of your questions. So you can take the time by going onto the Angular team panel, submitting some questions, and you can get those asked directly to the team. So it's time to kick off the afternoon, and we're going to kick it off by inviting on stage our sponsors and old Angular Connect friends, Jeff and Brendan from Narwhal. Thanks, guys.
Thank you, Ed. Thank you. All right. Hello. I'm Jeff from Narwhal. And that would make you...
Brandon.
All right, Brandon.
You're really going to hold that up, huh?
So we're from Narwhal. We are a... forgive me holding this giant book, but we'll make sure to cover everything. We're an Angular consultancy. We help teams with Angular and related technologies. We've got some of the top folks in the business. We help them figure out how to develop Angular and other things at scale. And one of the things we've built to help with that is a tool called NX.
Right. So NX is an extensible set of dev tools for monorepos built on top of the Angular CLI. It helps you generate your own custom. Generate on top of the Angular CLI, helps you generate your own components as you're used to, use modern tools such as Jest, Cypress, TypeScript, Prettier, and other tools. It also helps you, it's also extensible and customizable, so you can write your own custom code to generate things specific to your project. It's also intelligent, so you can have two projects together, front end and back end, work together seamlessly. Has a dependency graph, so you can analyze your build and only run the things that are impacted. It's also free and open source. So NX is out there, it's available to use, available to contribute to, so we encourage you to do that. And it's also used across many companies that are building these applications at scale with NX. So you get code partitioning, intelligent tooling, and helps you develop at scale, which are things that many enterprise companies need. So if you want to learn more about it, you can go to nx.dev, read the docs, and get started from there.
Yep. And one of the other things we built in addition to NX and some of our other open source tooling is a tool, a platform actually called Narwhal Connect. And we call this our developer empowerment platform. And this is a free tool that if you sign up, you can get access to resources we've created at Narwhal based on our experience building Angular with other folks, building NGRX, things like that, and things we've learned with our clients. So we've got books, topics that we've curated, resources for courses, cookbook recipes, live events, live workshops, just lots of things that we share with the community for free based on our experiences building large Angular applications. So you can go to connect.narwhal.io to get free access to that. And if you are an Angular console user, you can also take advantage of Connect inside the console and use the console to build applications with Angular CLI. So you have the same kind of all the schematics and things you have and are used to with Angular CLI, you can now have in your Visual Studio Code editor without having to memorize all the flags and different options and have that easily available. And finally, we're hiring. So we're hiring in North America and Europe. And we've got a pretty good thing going at Narwhal. We've got some great people like Brandon and myself. I'll put in there. So if you're interested in talking about hiring, we've got some of the top Angular folks in the community, very kind people, very nice and collaborative. So I encourage you to come talk to us or check out our careers page, and also come to our booth. We're giving away some things. We're giving away one of those fun, remarkable paper tablets, and also giving away some consultation time. And we're conducting office hours on different topics that some of our Narwhal experts will help with, like TypeScript, performance, NX, and GRX. So go to this URL, check out the schedule for that, and see when we'll be available. And we'll look forward to working with you. So that's it. Thank you very much.
Thanks.
Thank you so much. Cheers. Yeah, go for a quick unplug. Why not? Okay, right. Well, our next speaker is a man who needs very little introduction. He is the creator of the AngularJS framework. He works at Google, but previously worked at Adobe and Sun and Intel and Xerox. You can catch him on the Ivy panel tomorrow. To a lot of people, he's Miško, but to us, he's Papa Miško. Everybody, please welcome Papa Miško.
Yeah, I don't think I'm gonna live that down. Hi, how are you guys all doing? Good to be here. How's London? Are you liking it? Okay, so let's talk about I'm kind of hoping I'm gonna just dive deep into some technical stuff, and I hope you're gonna enjoy it with me here. Let's see, slides don't work, why not? Oh, here we go. So that's me. I am now a tech lead manager in Angular. My main focus is the Angular framework, the core of it, which is basically all the bits that end up in the browser. And I share that role together with Igor, and Igor basically works about all the stuff that makes the developers productive, and the two of us are complementary. Anyways, let's talk about performance, and the first thing I want to talk about is running performance tests. And I always joke that, the performance tests, you think you're running the test over and over again, but I don't think you're testing what you think you're testing. And I want to show you a couple of these things that can really surprise you. So first, let's talk about inlining and opt and deopt. So let's see. Let's go through a first example. So I'm going to make a very simple benchmark. And here we're going to try to see which of these 4 lines, how's the size? Should I make it bigger? I probably should. Oops. Okay, is that good? So which of these are faster? Now, I hope you agree with me that these are essentially identical functions that just happen to return different values. And because value is 0, this first side of the equation will always execute and will always return 0. Therefore, the value 1, 2, 3, 4 should actually not even come into play in any way. And so it shouldn't really have any performance impact. All of these things should execute the same exact way. So how are we going to benchmark this? Well, I have a very trivial benchmark here where we just grab the time, we run it some count number of times, and we write out what exactly the timing was. So let's run the first test case. And when I run it with, about 100,000 iterations, they seem pretty much about the same. So let's increase the number of iterations. As I'm increasing it, they still show up about the same number of times. And I go even higher, and something weird happens. The test case A is somehow faster than the rest of them. And if you go even higher, it consistently shows up as being faster. So what's going on? Like, these are essentially identical things. And so I wanted to show you what actually happens in the VM. So first of all, and I'm sure you know this, but you can run node v8 options, and it spits out lots of different options that you can pass into v8 itself. So these are options at top of node that only v8 understands. And so you can see there is like 800 lines of different options you can pass in. So I'm not going to go through all of them, but there are fun ones to look at, like, for example, trace opt and trace deopt. And so we can run those, and it will dump out a lot of interesting text for you, and you can go through that text and kind of figure out what actually is happening. But it turns out there's even a better tool. Somebody wrote this thing called a deoptigate. And so you can actually take that same piece of code and execute that. And it should open it up in our browser. Oops, where did it go? Opening in your default browser. Where's my default browser? Okay, great for the demo. What's going on? Seriously, where is it? Oh, okay, here it is. It went into the wrong tab. Okay, so it produces a file that you can zoom in, and specifically it places a red box right here, and you can click on it. And it tells you what it is. It says it de-optimized because of a particular bailout, which is wrong call target. So let's see if we can kind of think through what actually happened. So you started running the benchmark A, this one right here, and that took this function. And as it was executing this loop over here, the VM kind of noticed, I keep calling the same function over and over again, and it keeps like an internal counter. If the counter gets too high, the VM essentially wakes up maybe every 1 millisecond or so, and it kind of looks at the counters and says, which of the functions looks like a good candidate for optimization? And in this particular case, the VM kind of woke up every millisecond and goes in and says, it looks like what I can do is I can take the benchmark A and I can inline it in this location to make it run faster. And that's exactly what happens. So after the first benchmark runs for a while, the A gets inlined over there. And then we invoke it with B. And when we run it B, what happens is the VM says, oh, wait, I inlined A over here, and now you're calling me with B, so I made an assumption that turns out to be wrong, and so now it does what's known as a de-optimization, where it essentially undoes the thing that it did before. And so now because it did a de-op, the VM says, aha, I now know that this particular call side sometimes gets called with A and sometimes gets called with B, and therefore, it probably shouldn't inline over here. And so when the benchmark B runs, it no longer gets inline, and it's slower because now you have the overhead of actually making the call. And so it is very easy to make a benchmark where you think you're actually profiling what is actually happening in your application, but because real applications are much more complex, a lot of these optimizations get de-opted in the future. So this is an example of how you could make a, sorry, I actually make this bigger. How you can make a very simple test case and then shoot yourself in the foot because you're actually measuring the wrong thing unless you really understand what's happening inside of it. So what is the fix for it? Well, the fix for it is to run the same exact benchmark. I have that done in the same exact way, but instead of writing my benchmark library as something that takes a function and then runs it in the loop, I flipped it around. Instead, I turned my benchmarking library into a simple call. And my benchmark is basically a while loop that is true until the benchmark is in there. And then I just, inside of the while loop, I place the thing I want to benchmark. And by flipping it around, now instead of the function under test being inlined into the benchmark, now what's happening is the exact opposite. The benchmarking code gets inlined into my function under test. And in this way, we can make sure that we're measuring the right thing. So if I run this particular benchmark, which is right here, it will show that both A, B, C, and D performed in the same exact way. As you can see, the numbers are pretty much the same thing. Now, this particular benchmark, when you're running a benchmark, you kind of have a problem, and that is that you need to determine how many times you should iterate over something, how many times, because if you just put a timestamp before you run a piece of code and right afterwards, and you don't iterate enough times through it, first of all, you might be looking at unoptimized code. So then you can also be looking at the fact that your timer has jitter. And so you really need to be able to execute your function for a certain amount of time, which means you need to know how many iterations to run for. So a good benchmarking library will not only make sure that it doesn't fall for the trap of opt and deopt, but it also makes sure that it will figure out how many iterations your particular function should run for before it determines the time difference before it, right? Now, in this particular benchmark, what it does is it executes the function once, measures the time, and if the time is less than 100 milliseconds, it says, it's not quite enough, I have to run it more often. And so it keeps increasing the iteration loop until it gets approximately 100 milliseconds worth of data. And then what we do is you have two options. One option is you could simply average all of these measurements over a long period of time and look at the statistical deviation, how much faster or slower it is. But we have noticed that if we do an average, the average is not as predictive as if you take the best case scenario. And the reason for that is because when you are benchmarking a particular function, you are, your code isn't running by itself. There's other codes running preemptively in the background. So the operating system can wake up and do other things. For example, the browser can do garbage collection, or another application is running, and so on. And all of those ones slow the benchmark that you're running. And so by running the benchmark repeatedly and then selecting the fastest possible run, you are actually selecting the situation where no garbage collector ran, no other application woke up, and so on and so forth. And the numbers you get in this particular case are a lot more predictive than any other way of measuring it. At least that's the thing that we have kind of noticed. Okay, so we talked about inlining, and we talked about opt and deopt. And so I think one thing I would like you to take away from is that if you really want to measure things, I think it's really useful to measure the best case scenario, because that number seems to be a lot more consistent than any other number you can get. Okay, now let's switch gears a little bit and let's talk about how VMs lay out objects. And I think this is important because this will lead into how Ivy does things for themselves. So let's say we have an object, such as name, let's say John, age 42. So it turns out that memory inside of your computer is continuous. It's really just one big array, right? And so the VM's job is to take this object that has properties and then convert it into essentially an array, because that's what memory is. And the way the VM does that is it breaks the object into two parts. One is what's called a hidden class ID, and it contains some header information. It's just an array, but it contains some header information, which we're going to ignore for a second. But it contains key value pairs, where it says the name property is index offset 2, and the age property is index offset 3, such that if you look at the object itself, and you will notice that John, which is the value of name property, is actually at the second position, rather the third position, second index inside of the array. And so this is how the VM breaks up your object. So all of the metadata about the object goes into one location, and actually the values of the object goes into other location. So if you have two objects, for example, John and Mary, they will share the same object hidden ID class because the two shapes of these two objects are identical. So as long as the shape of the object is the same, and this is what we mean by the shape, we will share the metadata about the object in the same location, and then we will have the array, which represents the object itself, stored the same way. So that means if you want to perform a read, such as you can see over here, if you say object.name, you need to translate the name string into the offset into the array. Now, for languages such as Java and C++, this offset calculation can be done on the compile time because the language is static. But for JavaScript, the object lookup has to be done at runtime because JavaScript is a lot more dynamic than the static languages. And so whenever you do something like object.name, what the VM internally does is it says object.getProperty. It knows that the position 0 of the object always contains the information about the object itself, so it can extract the position 0 out. And then it passes in the key that it wants to be able to compute. And so it passes that into the function scans the list of possible keys, and it comes back with an answer, and the answer in this case should be 2. And so then we can basically dereference the object at the at the index 2, and we get back out John. And this is essentially how VMs work inside. So if you have a more complicated situation, such as when you have object 1, which notice has name and age, and object 2, which has a title and a name, and notice the name in this case is in position 2 rather than the position 1, they can no longer share their hidden class IDs. They have to have a separate hidden class IDs, and they store the information about one shape of the object in one location and the other shape of the object in the other location, and now the objects are no longer tied together by their hidden class ID. So that if you wanted to read properly object.name off of the object, as you can see over here, notice the line above it says object will sometimes be object 1 and sometimes be object 2, depending on the expression. So when we call getProp and we get the hidden class ID, which is object 0, sometimes it will return 2, and sometimes the index will be 3, depending on which shape of the object we happen to have. But in both cases, we're going to get the name out of the object, right? So that's kind of what's going on. So let's look at this in how does this perform. Okay, so I have a benchmark here, and what the benchmark will do is it will create 10,000 objects. And it will create 10,000 different kinds of objects, and we will place them inside of different arrays. So this array 1 will end up being 10,000 items long, and what it will contain is object of the same shape. It will contain value prop 0, value prop 0, value prop 0, value prop 0, and so on and so forth, 10,000 of these objects. So we know that in this situation, the array 1 will contain objects that will all share the same hidden ID. For array 2, we will create a value prop 0, but then we will create value prop 1, then we'll go back to 0, 1, and we will alternate like this back and forth. So we know that array 2 will contain 10,000 objects, 5,000 of which will be of shape 1, and 5,000 of which will be of shape 2. We will do the same thing for array 3, where will be 3 different kinds of objects. 4 will contain 4 different kinds of objects, all the way up to array 10,000, where there will be 10,000 different kinds of shapes of objects inside of it. The next thing we're going to do is we're going to try to go and read. We know that all of these objects have a value property, and so we will try to read the value property out of every single object that we have, and we're just going to add it to the sum. We know that in each cases the value property is going to be 0, so we don't have to worry about sum overflowing and becoming a double, because that also will cause a deopt to happen. And so in this case, what we're going to do is we're just going to read the value property all the time, and we know that we will have the same shape object in the array all the time, whereas in here we will have 2 shapes, 3 shapes, and so on and so forth. So let's execute this particular test case and see how we do. So in this case, the benchmarking is trying to figure out how long the particular test case should be run for, and then it runs it for a number of times, and then tries to pick the smallest possible value, and then display the smallest possible value for us right here. And here's the result. Now, not surprisingly, if you have the same shape object all the time, you see the highest performance. You see that that particular function executes once per, or rather, iterating over all 10,000 objects took 20 microseconds. And that's our best case scenario. And as we increase the number of shapes of objects that we have in a system, we are getting slightly slower. And so 1, 2, 3, 4, notice, are pretty much the same. Something funny happens at 5, and all of a sudden, we are about 2.5 times slower than we were before. And we kind of maintain the 2.5 times slower until we get to 10,000 objects, and wow, we are now 50 times slower than reading the objects internally. So the question is, what's going on, and how can we debug this particular thing? Okay, so let's go back to what are going on with our objects a little bit. Let's talk about it some more before I show you how to debug this thing. So what's going to happen inside of the VM internally is that when we have to execute this piece of code right here, which says object get property of the hidden class ID of name, and we're going to look that up, and we're going to have 2 in there. But it turns out that the get prop lookup is actually slow. And so VM, once it runs, it can collect meta information about what it's executing and produce what's known as an inline cache. An inline cache basically says that if the object that you read at property 0 is object class ID, and this is just a simple comparison, so this is extremely cheap, then we know the answer is 2. Because we ran it before in a interpretive mode, and while we were running inside of interpretive mode, we've collected all kinds of information about it. And so we know that if the hidden class ID of this particular object happens to be this special one, because in the past we have seen this particular one to be very, very common through this execution code path, then we can just short circuit the whole thing and just answer it with the answer of it saying this is 2. Otherwise, if we can't do that, then we have to go and call the get prop function, and the get prop function is the slow one. It's the thing that it actually requires us to scan the object hidden class ID, and it takes some time. And so doing this particular trick allows the VM to generate code that is significantly faster in execution time. So this works in the case where the number of objects is fixed, so we know that we always have the same shape object coming through it. Now, in this particular example, where we have 2 different kinds of shape of objects, the VM can also collect information about it and says, you know what, while I was running it in interpretive mode, I've collected information about this code, how it's executed, and I have realized that now there are 2 kinds of shapes that can come through these particular locations. There's the object 1 shape and object 2 shape. And I know that if object 1 comes across, the name property is in location 2, but if object 2 comes across, I know the name property is in 3. Otherwise, I just give up and I go the slow route and I look it up. And so these are inline caches, and VMs are willing to do this particular trick up to 4 times. Like different VMs can choose different number of ones, but typically the VMs do this up to 4 times. And so because they do up to 4 times, we can kind of explain as to what's going on over here, right? The first 4 lines were inline cache hits. Right? So for the first case, the VM only had to compare one hidden class ID against it, and it was always correct. And that's why that particular case runs the fastest. In a second case, the VM had to compare 2 different values, but both of these values, it always got an object either of one value or the other value, and so the comparison was a little more complicated, but it's still relatively fast. You can see the same thing happening for 3, we're getting slightly slower, 4, slightly slower, and at 5, the VM gives up and says, you know what, if you have more than 5 objects, I'm just going to call get prop, right? And so that's when it gets slower. However, why is it that between 5 and 1,000, we're relatively fast, but at 10,000, we get really slow? Like, what's going on over here? Like, there's something else going on in here that we can't really explain. And so I want to show you a couple of tools by which we can explore this. So the first thing is something called trace IC. IC means inline cache. And so we can execute this piece of code in our VM, and this will generate this will execute for a while. This is going to generate a log file for us that we can explore. And so the log file. So we need to install in order to look at this log file, you have to install something called V8 V8 tools. The instructions on how to install that are actually in this repo that I'll go show you on the slides on the end. But once you install this particular thing, you can open the log file, and it will give you oh, come on. Yeah, I have a nice sleep. Oh, sorry, I'm looking at the wrong one. It's an IC processor, not the tick. Okay, that's what's happening. Okay, let's open it up. And we can now look at it by function. I'm sorry, not function, file position. Okay, so this is our code, example.js, and it flagged all these locations, and we're going to look at the bottom one first. This is at location 44, so to cross-colorate this with our source code, 44 is this one right here. So we're talking about this value over here, so this is line 44, column It doesn't show me column numbers. Column 33. And notice what it says. It was trying to read value. This is the property that it's trying to read. And it says that V8 calls objects maps. So it says I saw two different kind of objects come through. And these are their hidden class IDs. And the dot means I was collecting information about these objects. And then after a while, the VM says, you know, I see that there is one shape. So this is called the transition. And it comes across this and says, okay, I saw this shape of object before, so I'm going to record its hidden ID. And then I've seen another transition where it goes from what's known as a monomorphic lookup to a polymorphic lookup. So remember, the VM is willing to generate up to 4 of these things. So notice that as we go up, so this is line 44, line 61 has, oops, sorry, it's a benchmark. The next one up is line 51 of example 3. And notice here, the VM saw up to 3 different kinds of maps. And so it transitioned to monomorphic state, from monomorphic to polymorphic, from polymorphic to polymorphic. Remember, it's willing to do up to 4 of these polymorphic states. And so everything still works good. But as you go up, all the way to the last one, all the way on the top, notice what it shows you over here. That at this particular location, it has seen 10,000 different shapes. And it has transitioned from monomorphic to polymorphic, from polymorphic to polymorphic a few times. Eventually, it went to megamorphic, and it stayed at the megamorphic read all the time over here. Most of the execution hits that happen at this location, about 100% of them, were in the megamorphic state, and that's why we were slow in this particular location. So this only repeats what we kind of already know. Now, it turns out that while this tool is pretty cool, there's actually a better way of looking at this. So there is another tool out there called the Optigate. And the Optigate will present the same exact information, but in a more, what I would call, human-readable way. So if this runs for a second while it's running here, I will collect the next one. Okay. Okay, so this is the tool it executed. If we look at our example 3 code, what the VM did is it placed these markers in here. So first, let's show the low severity. So notice the green phone icon means that this property read is monomorphic. So it's the best kind of property read you can have. In other words, every time the VM executed this piece of code, the object shape underneath was always the same, and therefore it could just short circuit the whole thing and get the proper thing. So those are the green ones. The blue ones are polymorphic. And so in this case, it's showing you that there were 2 different shape of objects that went through this location. And so while 2 is not ideal, it's still pretty good because it still can do inline caching. And now notice when we transition to array 5 with 5 different objects, it becomes red, saying your system has transitioned into the megamorphic state, and we are no longer executing the code on as high performance as possible. Now, this is kind of an explanation of what to do and how to use these tools to kind of understand your code, but we still haven't explained why there is such a sudden drop at the 10,000 level. So I executed the code one more time, this time with another option called --prof, which is called a profiler, and we can then open up the profiler inside of a prof tool that V8 has, and we get this kind of a graph. So let me take you through this. So here are functions, and you can click on function 1. So the benchmark one is the one which always has the same shape object, and you can see it is all green. Notice at the very, very beginning, there is some other colors that show up over here. Those are, if you look at the labels below, those are when the VM is running in the interpretive mode, collecting information about your code. And once the interpretive mode is kind of finished, the VM generates actual assembly instructions that it then executes. And that's why the green means it's running the generated assembly instructions, and those are fast. So all of these functions begin with a little bit of color there at the beginning that says I'm compiling or collecting some metadata. And then all of the green stuff says I am running in the most efficient possible manner. And you can see that 1, 2, 3, and 4, they're all very efficient here. But on 5, we now have a whole bunch of yellow that happens in here. So let's highlight this piece of code over here and do bottom up. And you can see that about 40% of the time, we were in basically the green area, the generated code, and that's our function, line 62. And about 60% of the time, we are in generated code. Now, what does this mean? The yellow code is, it is code that's the VM generates, but which is actually dynamic. So it is still generated code, but it's suboptimal in a sense that it doesn't execute as fast as purely green code. So that's some of the yellow right over here. And we can see that as we go to all of these, oops, that's selected. As we go through all of these benchmarks, we all have a little bit of yellow, and so this is when we are 2.5 times slower, and the 2.5 times comes from the yellow area. And we're good all the way up till we hit 10,000 shapes. And then when we hit 10,000 shapes, we select this bit of code here, and you can see we have a whole bunch of blues. So what's going on here? If you zoom in, we have a C++ code here now, and it says runtime load IC miss, whereas the yellow said load IC. So load IC is basically our get prop function. It turns out the VM generates 2 load functions. So first, it tries to go into what it calls a megamorphic cache. That is a cache that it collected by running, and it can resolve the property lookup, not as fast as inline cache, but still relatively fast. That's the 2.5 times slowdown that you see with everything that's relatively small. But because we have generated 10,000 objects in this location, that's more than the number of items that the cache has. And so every time we iterate through our 10,000 objects, and because every single time we have a different object, we are sure to be evicting existing cache entries from the cache and then replacing them with new ones. But we don't use that new entry because we have so many other shapes to go through that by the time we get around to read the particular shaped object again, we have already overwritten the cache with something else. And that's why we get a whole bunch of cache misses here. Okay, so those are some cool tools by which you can kind of understand how the VMs do things internally. So now let's talk about Ivy, how exactly we take all this information and use it to make ourselves fast. So now imagine you have 2 components. Let's say we have hello and you have my app. My app is very simple. It simply instantiates hello component, and inside of its content, it says it puts the bold world, and the hello component simply says hello, and then it transcludes the content, reprojects the content in the ng content. So the resulting DOM tree that you have is on the right. You simply have hello span, hello world, and then end span and hello. Now, while the tree on the left is what we render, the tree on the right is actually what we care about, because this is what we call the logical tree. The way to think about it is not that the world is really a child of the span. A better way to think about it is that the world is a child of hello, and there is a sibling to it, which is the content view of the hello, which then has the content projection. We have an arrow like that. And the reason why this particular tree is important, so we call the tree on the left called the render tree, the tree on the right we call the logical tree. And the reason why we care about this tree is because if you look at how Angular actually resolves things, either through injector or lookups or dealing with parents, it's all done on the logical tree, never on the render tree. And we have to store additional information in there, such as the injector, the component directives, the binding, the listeners, the cleanup work, the pipes, and all of this information has to get stored on a logical tree so that we can execute on it. However, this information, so one way to do that would be to create what we call an L node, or logical node, which would have pointers to parent, children, the next injector, bindings, pipes, styles, component, directives, and so on. And most of these things would be blank most of the time, because most nodes don't necessarily have an injector, most don't have pipes, and so on. And so this is actually a very inefficient way of storing this particular thing. So the good thing about this way of storing it is that it's simple and it's super maintainable. The cons of it is that it's very sparse, and because we are sparse, it's very memory intensive. And being memory intensive means that you're going to have a hard time running on your mobile devices. The other thing it does is it duplicates information across templates. So if you have a template which is inside of NG4 and you're executing the same template over and over and over again, your parents and your siblings and your children and where you have injectors will all be replicated over and over and over again. And so we will have the same information spread across multiple different things. And finally, it affects what's known as low cache locality, which basically means that because the information is sparse, when I cause a cache miss and the cache then loads it into its cache location, the cache loads something what's called a line, which is essentially 128 words of information. And if things are sparse, chances are that the thing you just loaded will just have nulls everywhere because you don't need it. And because of that, when you try to read something related, you will most likely cause a cache miss rather than reading it from the information that you just had. So what we can do is we can rearrange the data a little bit. We can use the same exact trick that the VM does on the Ivy level as well. Instead of storing our sparse data in an object, we can store all of our data in an array. So we're going to define a new thing called an LView. An LView is just an array. But you will have this problem that you need to know where exactly to look inside of the LView to get your data. And so instead of having an L node, which is the logical node, we would have a T node, which would be a node that's shared across all instances of the template. So if you're inside of NG4, we would only generate one T node no matter how many times the NG4 would unroll your template. So you could have an NG4 that unrolls a component 1,000 times, but there will be only one T node that will tell us about how this component got unrolled. And the advantage of having everything inside of the array is that now we can compact everything into as small as possible location as possible. So we don't store information that we don't need. We don't say like, oh, this component doesn't have any directives or any components, because we just look at the T node and T node tells us, oh, the bindings points to -1, and so we know that it don't even bother looking inside of the array. Now, this is all nice, but the cons of this is that it's kind of hard to debug and to understand what's going on. And because it's hard to debug and understand, it really would complicate the way the open source contributions would have to be done, because now you can't just kind of look at the code, it becomes much more complicated. And finally, it becomes hard to profile, because if everything is an array, then it's hard to separate which object is which array am I looking at. So we're trying to mitigate all of these things. And the way we mitigate is by this mode we call ngDev mode. ngDev mode is a flag that could be either true or false, and if it's true, then we execute a whole bunch of extra code and we decorate all of these objects with additional information that allows us to simplify all of these things. And so instead of LView having to be just an array, we actually subclass the array into an LView and we add a debug property on it. And so now all of these arrays have not only the regular information that you have, but they also have additional debug information that allows us to see it in a more kind of unrolled, friendly manner and explore what's going on. And that therefore makes it much easier to understand how Ivy works internally. It makes it a lot more approachable. And so this particular approach really is the best of both worlds. We can be super compact, but at the same time, we can produce all of the metadata for the developer so that they can understand what's going on. Makes it easy to debug, easy to profile, and also, fundamentally, easy to contribute, because we really want all of you to help us make Angular better. Now, this code, this extra code, has an impact on the amount of code that's shipped. That's why in the production build, when you say ngDev mode is false, all of the ngDev mode code is removed. So the extra code is there only if you're in development mode, and there's some speed cost to it, but only in development mode. Once you do a production build, all of the stuff is removed and becomes much simplified. So let's see if I can do a little demo here. So I have a very simple hello world, which is styled, and also it prints the letters of the alphabet. So that's pretty simple, straightforward stuff. One thing I want to show you is that Igor kind of already talked about it, but we can select any one of the DOM elements. So let's say we collect a span over here, and we have this ng property that exists in dev mode. And there are all kinds of useful methods over here, like get component, get context, and so on. So if I say ng.get component, and I pass in the selected node, oops. I can see that I'm going to get my application, I can look at all the properties, and I can explore it. So that's one way in which we make sure that the development under Ivy is going to be much more simplified. The other thing that I wanted to show you is that these objects have come on, I can type. Okay. We have the LView on it. So you can see that it says LView right here. And this LView is, it's just an array, right? And so it makes it super difficult to figure out like what's going on over here. But luckily, we have this debug property, and this gives us the same exact information in a much more readable view. So for example, we can say, what kind of views do we have? So we can look at child views, and we can see that this view has one child one, which is a container. We can go into the container, and we can look at its views, and we can see that that container has 26 subviews because this is an ng4, one for each letter, right? So if I go and I select one of these views, I can look at nodes, and I can see that that node refers to li. If you hover over it, you know, it highlights, like you can see over here. And I can also see what kind of styling, etc. it has. So for example, if I go and look at the nodes at the top, I can see that I have a span node, one of the root nodes, and the span happens to have all kinds of bindings, and so I can look at the styles, and I can see how the style bindings have combined together. Okay, how do I get to my presentation now? Here we go. So in summary, we made Ivy fast because first, we really are very careful about making sure that everything in Ivy is monomorphic. So we use the same tools that I showed you to kind of look at our code and make sure that all the code shows up with monomorphic property reads, and that's a first big hit. Now, it has two benefits. First, because it makes us fast, but second, because it doesn't pollute the global cache of megamorphic property reads. And not polluting megamorphic property read cache means that if the application code uses these megamorphic properties, we don't evict things out, and so we don't make the application unintentionally slower. The next thing is we always try to iterate over arrays rather than over object keys, because enumerating object keys is actually very expensive, whereas working with arrays is super cheap. We're also very careful about function inlining, which I showed you at the beginning, because it's very easy to get yourself into thinking that something is a lot more faster than in reality. We store data in these arrays for efficiency, for speed, and as well as for space efficiency, and these are the tview, tnode, and lviews we talked about. And we have lots and lots of focus tests that are basically built on the same benchmarking thing as I was demonstrating over here, that allows us to really focus individually on and reproduce what's going on. And once we have these tests, we can then execute them inside of the same set of tools that I showed you to kind of figure out what's going on inside of it. And with that, I'm going to close it. These are the link to the GitHub location if you wanted to play with these tools. It will be all set up for you over there. And thank you.
Thank you so much, Miško. What a great deep dive. Okay, a couple of minutes just to pick your tracks, and then we're going to get going again in here very shortly. Thank you very much. Hello, everybody. Welcome back. Our next speaker works on the Google marketing platform where she leads the front-end infrastructure, common components, and user management. Her core mission is to help build stunning apps with minimal effort while pushing the technology needle of what is possible. You can catch her on the performance panel tomorrow at 1:25. But everybody, please give a very big, warm welcome to Erin.
Thank you. Hello. How is everyone today? Good? All right. So I'm going to be talking about the architecture of components and managing complexity without a state management solution. You can reach me on Twitter, Aaron Coughlin 16, or the bit.ly link is Arc Components AC19 for this talk and presentation. So we had this in the introduction, but I work at Google. I'm a software engineer on Google Marketing Platform. This is it's a parent of many analytics products. So we have Google Analytics, Google Tag Manager, Google Optimize, and this is really like the root of all of those. I call myself a component architect too, because I love building components, and I like this whole entire of how you build an application start to finish. So I'm going to jump back a few months to when we were figuring out this talk. I'm sitting in this micro kitchen's what we call them, but it's basically just a little cafe with one of my friends, David. And we're talking about NGRX and Angular and state management basically as a whole. And we don't agree on anything. He loves NGRX. He's using it for his brand new application from the ground up. I, for my team, have other concerns with my team doesn't know Angular, they don't know AngularJS, we don't know RxJS, so let's throw a fourth one in there? Maybe not. So what we did, we kept talking, and what we came out with was actually the content of this presentation. So it is not whether you should or should not use NGRX. That's for every single person in this room to determine for their own team if it is right for them. There's tons of talks on pros and cons. Go check those out. It's also not a way to avoid state altogether. We're here because we have state. We're not writing static HTML pages. If we were, I don't know why we're using Angular. Maybe I shouldn't say that, but yeah. What we will talk about are the types of components and where state should live. So first type of components. There's three types of components. The first two are presentational and container components. These are a lot more familiar, smart and dumb. Third one is layout components. I'm going to go into each of these a little bit more in depth, but layout components is more of a new one I don't see as much, but it's like the layout of your page. So for presentational components, these are also known as dumb components. I will probably use that a lot, so just know that these are the presentational. I don't know, dumb sounds cooler to me. It's stateless, and it uses inputs and outputs for communication. So you send in values, it renders something, it emits an event when it's done, and some other one manages the state and makes all the updates. And one of the really cool things about these presentational components is that it's way easier to test. You don't need to make fake services, you don't need to make a fake backend or make any actual calls. You pass in inputs, you check that it did something correct, and the right output is emitted. Next are the container components. These are the smart ones. That's totally not a brain, but you can pretend it's a brain. Think of it as like the brain of the operation, all these little things coming out and organizing your application. It connects these presentational components to the state in your application. And it handles these emitted events. So the presentational one emits an event. I then respond to that event. I make a call to the server. I update the UI. I'm really the brains. I'm the one controlling everything. And these layout components. The screenshot over there is actually from Google Slides, but it's a layout of the way your page looks. For this one, you don't really have data. You don't need to update this when it changes. It's just different pages. So as an example, this is Medium. There's 3 different panels here. You can think of a layout as right, center, left. And clicker doesn't work. OK, I don't know why that worked. So the container is the top. It's the brain. Layout is next level, is how you split it up. and presentational is this bottom level of what actually gets rendered. So let's talk a little bit about data. How do we get the data into all of these components? I mentioned input and output between the container and these presentational ones, but then where does the data come from? We have something like HTTP client, NGRX, NGXS. Maybe it's your route. These all go into the container. So you take all of these different sources at the top, throw them into your container, it does whatever it needs to do with the state, passes it to stuff that actually renders it. So really here, we're trying to separate out these two different behaviors. We have the one responsible for rendering it, and the one that's actually responsible for organizing your data. And with that, I want to say there's a little warning here. So if you have an input that only exists to pass it to another input a level down, maybe it's not the right abstraction. So an example of this, just to make it more clear, is favorites. Okay, this really white component is called the Universal Picker. It allows you to navigate between all Google Marketing Platform products, so Google Analytics, Google Tag Manager, and you can search for anything you want. Customers loved this thing. We launched it probably 2 years ago. It was pretty awesome. But we missed one thing at the beginning, that little tiny star. So we have to add this star. Like, we don't want our customers mad. We're going to add this star. We're going to prioritize it. But let's see how we actually architected this the first time and why this passing properties down may not have worked. So we have 4 main sections here. The top is a tab bar, and you can think of this as the Angular material tab bar. Another one is the next level with the products. It's also a tab bar. It's just icons instead of text. Over on the side where it says Aaron's organization, that is a drop-down. I click on it, I can switch organizations. And these 3 list views is another one. We put each of those into their own component. All the data is in this main universal picker, and the 4 other components, they just take an input, they emit something when it's out. But the code was a little complicated for that list view. There's 3 columns in there. It's more or less the same content. So we went a step further. We split the 3 into 2. So now we have 1 component, universal picker, to the list, to a column. And we further split that up, because the rows are just repeated a bunch of times, into a bunch of rows. Now remember that little star. We need that star to have a value from our server. So like a feature flag, whether it's on or off. We're not going to just turn this on. We want to go over like a week or so and roll it out. With this design, we had to pipe that value, the feature flag, down my list, to my column, to my row, to the star, which was the component in the row. Yeah, that's a good face, Ward. He looks very unhappy with this. And we were too. It was very complex and hard to reason about where the data should go in here. So, yeah, there you go. That's another face. So very, very unhappy, mind explosion. Be careful here. But fortunately, we got to rewrite this. So favorites v2. Well, first, what went well? We had small reusable components. That drop-down was great. The little tab bars were great. And even though we broke it down into a single row, it had a single functionality. Single functionality. Second, we had this one smart component with all of our data. It was all orchestrated inside this universal picker, and we later could pass it through to the other ones. So those things were good. What didn't go well was we had components with no purpose. That column was just a repeat over items. In every field that we needed in the item, we had to pass through the column. So it had no purpose but to send data further down. Not so good. And it was hard to reason about. It was something I could not assign to a new engineer on the team who had no background in how we designed this. Like, they would have no idea what we were doing. They're like, why do I have to update 6 files to add a stupid star? It wasn't stupid, but it was difficult. So we wrote it again. For the next version, we got rid of that column in the row. So we have our 4 dumb components. We have the 2 tab bars, We're using Angular Material, so a lot of that functionality we don't have to care about anymore. Our dropdown, and then all 3 columns is a single DOM component, single presentational component. But it's not super straightforward because we still have the star. What we did with the star was we wanted this to be used in multiple places. And this is some of the decisions that you would go through when you're trying to decide whether to have a DOM component or a presentational one. We wanted that star to be reusable. We wanted to be able to put it anywhere on the page, not just in this component. I wanted to have a field. I want to click on it. I send data to the server. It updates. We wanted that type of information on it. So it didn't make sense for this entire universal picker to be controlling it directly. What we ended up doing was a little bit with services. I'm going to talk about the Angular service a little bit later, but we actually made the star itself smart. So where should your state live? First, why do we need state? Some of this goes without saying, but it's really this interface between your data and your components. You have a server, it has value. You have maybe a route, it has data. And somehow you have to get that to the thing that renders on the page. You need data from somewhere. And your state is that that communication between both of them. It also allows you to keep data consistent between the components. So if 2 components need to rely on some similar data, you can use a state to keep them in sync. And thirdly, it allows you to perform communication between the 2 of them. If you think of a service, you call update, other components actually update within it. So there's a few different types of state. You can actually break this down further, but the 3 I like to think about is really the server, the application, and your page. The server is data in the back end. You get it through either HTTP client or some other URL fetcher that you have. The application state is the things that persist across all of your applications. So in ours, we have this thing called an organization, and every single page in my application needs to know what organization I'm in. Maybe another is like a user if you have some kind of multi-login, or maybe an account ID. You want to know what account you're in throughout the entire journey. Finally is this page-specific state, something only needed on a single page. Think of maybe a form or something. You don't need the form data outside of the form itself. So how do you know which state to use, and how do you know where to put that data? There's 2 questions I like to ask myself. The first is, how many pages does the state affect? So is this a single page? Is this your entire application? And secondly, it's how long should the data last? Does it need to persist across sessions? Is it a single session? Is it in that form that I mentioned? Is it only in that form? Is it only on a page? And how long should you retain that data for? And like everything, there's a lot of options for how to do this. First, there are Angular services. I'm going to show an example of that right after this. Next are those state management libraries, NGRX, NGXS, several others. All are state management libraries. We're not going to get into that one, but that's another way you can store and manage the state. Next is the router. So for those states that have to live across sessions, putting some information in the router will allow you to send the URL to someone else. They can open it up and actually see the exact same thing you're seeing. So that's another way to store state. And finally, within a single component. So think of the classical to-do app. You have an array, and inside there is a list of to-dos. And that's all within a single component, in a single smart component. So some examples to make this a little bit more concrete. So Angular service. We have this thing called an organization. Organizations are everywhere in our code. They have an ID, they have a name, they have a logo. It's a fairly simple object, but how do we actually get this data? We created something called Sweet Context Service. We say it's provided in root, so it's a singleton across all of our application. I inject it, and it's the same actual instance. And we create a subject. So this is private. We don't expose this to any of our end users or any of our applications. So we have a replay subject that always will remember your previous organization. What we do expose, however, is the observable. So we take the observable part out, and we expose that. Anyone can subscribe to it, then they immediately will get the current organization. And when I need to update that current organization, such as in my dropdown, I can then call into this service, call set current organization, and by that subject next, anywhere in my application that's subscribed to it, and actually later subscribed to it because of the replay, will have the exact same organization. So this is keeping my state consistent across the entire application. Whenever it gets updated, we update this service, and everyone has the correct value. So the next one is router. And this is also, we're going to use organization again. That's what my app does. So the router here stores the persistent state. So stuff that has to exist every single session you go into it. It also allows users to share pages with other ones and actually end up in the same spot. So here's an example from our application. I have home. This is my first route. It's basically the entire container of the page. It's what renders the header on there. And the actual content of it is a child, which is this orgs. This really long string is my organization ID, and that is the current state that I am in. So I am in organization CBT, blah, blah, blah. So you can think of this as this org ID. I have some kind of parameter, and it is org ID. The final piece is settings. So this is actually the content of the page. I am looking at the settings of these organizations. So the route kind of cascades down, and in there, we're actually encoding some information that we want to use. Final is a query param. Auth user 0 is actually just the current user. So our applications support multiple users. And so if you have 4 users, you have user 0, 1, 2, and 3. But that's in the URL for all of ours. So when you log in, I know who it is. Probably don't share that part, because you'll end up in the wrong person, but that's in here as well. So how do we get that value? So here I have my smart component. And what I do is I inject the route of this component. So I have something, inject the activated route, and then I inject an organization service, which is my HTTP service to fetch data from my backend. I create a read-only observable, and actually read-only observable of this organization. So I want to be listening to any updates in it, and I want my actual UI to get updated with it. So on the activated route, there is a list of all the parameters. It's param map. It is also an observable. So we can pipe and get the org ID off of this map. So I now have the current org ID, that long string that I used. And what I do with this is I send it off to my server, and I get the value back. So here I'm setting up this whole entire chain of getting data from the router and taking that information, sending it to my server, getting the data back, and now I have all of the information about my ID, my logo, and the name of my organization. So this type of pattern here, where you're resolving these different params and then actually updating the UI accordingly, it helps keep it in sync. I change the org ID in the URL, this gets updated, and my UI switches to a different org. If you actually want to put this everywhere, you can use a route resolve instead. I don't go into details here, but that's just getting some of your data earlier. So favorites v2, I told you this was coming back. So we have our star, and we have our setup here with the 4 different dumb components in that very smart star. So we pass in, there's a single input. We pass in the ID of the account or that little entity into our star. So that's the only value we have. We need to know which of the rows in the list is the star related to. The universal picker gets data from the route. I showed you the current org on here, where we're getting our current org ID and getting the data. We also have account IDs oftentimes coded in there, so whatever current account you're in, those are all coming from our route. And with that, we can list all of the accounts from the server and really combine this data. So we're taking our server data with the list of accounts, putting a checked value, which is a Boolean of current, essentially, on it, and then rendering all these stars. When the universal picker gets this data, we also can set the stars. So we don't have an easy way to get a star for a single account. Or rather, we do have a way, but if I have to make that call 10,000 times because you have 10,000 accounts, it's a lot slower. So this list one actually is filling out all of the information, and because we're getting all the accounts, we just add an extra field in there for that state. We go ahead and set the stars in this star service. So the star service is now a smarter Angular service, and it's keeping track of a map of every single star to their true-false value of true and false, or their Boolean value of true and false. And our star component can look up the value of a single star based on that ID, and when it's updated, we actually go ahead and update the star service, and our map in that service now has a new value, and our component is updated. And it helps keep these two things in sync. The star service has it's like last modified time, so we use that to actually invalidate some of the other data from our list. So we know we have an update past when we initially fetched it, and we can invalidate that and fetch new data. So this is kind of how it's all set up. The star component actually is doing a lot here, and the universal picker is doing a lot. We're skipping all those I skipped the drop down because that actually is truly dumb, but these are how the smart ones interact. So let's look at how to bring this together and summarize what we've learned. How do we architect a web page? First, it's always look at the requirements. We want code to be simple. I want to be able to give it to some engineer who's maybe new to the team or less familiar and have them actually understand how we set it up. So making the code simpler. We want it to be easy to maintain. I don't want this code breaking every week because some weird connection between like some component and another component just didn't work and then it broke. We also want to do things faster. So we want to be able to launch features as fast as possible. And the better architecture we can have and the more upfront planning we can have about where the data lies, how we're fetching data, and how it's then delegated to components makes that happen. So let's think of the principles we've talked about. First, we want to reduce the application-wide state. And this is really thinking about where the state should live. You're not going to put every single object, an array, or anything any component needs and expose it to all the other components. So you want to scope it to the section of the app that needs it. I used the form earlier as an example. If only the form needs the state, there's no reason some other page in your application also needs that value. So you can scope it to the correct location. And third, we want to separate out the container components from the presentational components. We want to upfront decide what needs to be smart, what needs to be dumb, and what trade-offs we're making. We saw with that star, I made a trade-off in switching it to be a smart component as opposed to a dumb one, and what those trade-offs mean for your team. And with that, I want to say thank you for listening. I will be around in the expert zone tomorrow at 1:25. Thanks.
Thank you so much, Erin. Okay, so we're running a little bit late. We've got a short break now, but we're going to all come back together again at 4:05. So talks are kicking off again at 4:05. Please try and be on time. Thank you. Yeah. Do you want me to announce that?
Hello, hello, hello. Good afternoon. How has it been, Angular Connect? How's it been? Oh, come on, come on. I know it's afternoon. There we go. All right. So this next talk, super pumped about, is Max, and I'm gonna do it justice. Koretsky. I gotta work on my role, and Max is adept at architectural patterns in JavaScript frameworks. He likes to go out and find them and then explain them in plain English. So you're in for a real treat today. He is a self-taught software engineer that believes in the fundamental knowledge and hardcore learning. He's a founder of, we've all probably heard of it, at least I use it all the time, Angular In-Depth blog, right? And the Angular In-Depth blog community. And on top of the Angular contributor, he is a top Angular contributor on Stack Overflow. So he's also a GDE, Google Developer Expert, in web technologies and holds the title of the Microsoft MVP. And he works as a developer advocate at AGGrid. So I want all of you to give him a warm welcome. And tomorrow, if you're interested, he has a performance panel at 13:25. So give a warm welcome for Max Koretsky. Woo!
All right. Hey, can you guys hear me okay? Okay, so this thing is working. So yeah, my name is Max Koretsky. I'm also known as the Wizard because I really like to dive deep into internals of frameworks, other stuff, and share my findings with the audience like yourself. So today we will be talking about what makes Angular fast. So it's kind of similar to what Miska talked about it, but more in a conceptual way. So I hope that this talk will be very valuable for you. Now, I'm the guy who started Angular In-Depth. How many of you know of Angular In-Depth? Okay. Oh, cool. Like 33.2%, I think. And I work for AGGrid. Yeah. Our mission is to build the best data grid in the world, and as far as I can tell, we're doing a great job following our mission. The next slide is usually where I discuss, the slide is about me, where I discuss my writing activities, speaking activities, community engagements. And it's funny that I went online on YouTube to check comments for one of my talks. And the first comment was, it's interesting that this guy has never written a line of code, and yet he teaches us how to write code, how the code works. And I realized that although I talk a lot about my writing and speaking activities, I've never said that I worked as a software engineer. So I changed my slide, and I can assure you that I have been programming for about 6 years. I know what JavaScript is. And besides that, I run Angular In-Depth publication. We get about 800K views a month, so it's pretty big. Yeah, I'm also very active on Stack Overflow, Google Developer Expert, and just recently I won the National IT Award in Ukraine in education category. Okay, so let's talk about what makes Angular fast. And these are the three components that I distilled. So you need to write optimized code, the code that is optimized for the execution by virtual machine, V8, right, in Chrome usually. You need to use correct data structures. Particularly, Angular uses a very interesting kind of data structures that is known as probabilistic data structures. And you need to have a compiler, right? And as we all know, Angular does have a compiler. So let's start with the optimized code. What kind of code you can find if you explore Angular sources. Now, there is a document actually in the repository. It's called perf_nodes. I explored it so you can go and see all the stuff, all the interesting stuff that you can find in Angular code. What you can find there is, for example, they don't use recursive functions, because recursive functions cannot be inlined. And Mishka talked about inlining how VM optimizes code. So they don't use this kind of functions. Sometimes they use regular for loops instead of for each method on array. They use linked lists instead of arrays for shared arrays. They don't use top-level variables because usually minifiers cannot rename them, so it results in a bigger bundle. they use bit fills, and importantly, they ensure monomorphic property access. Now, this is something what Mishka talked about, and I hope that what I will be talking about, or the perspective I will give you on monomorphism, will complement what Mishka was talking about. And so if you will be re-watching these talks on YouTube, I recommend that you first watch my talk, that I will give you a conceptual understanding of what monomorphism is, and then watch Mishka's talk, where he actually shows you how it manifests itself in the code. Okay, so monomorphic property access is very important, like Mishka said, and this is what I found in the docs. So it's about 100 times faster than megamorphic property access. But what is this monomorphic property access? It's a magical phrase. Well, actually, it's just a property access. Like this function, update node. It takes an object, and inside this function, we access the property x. So this kind of functions we write every day. Interestingly, these kind of functions are part of the code inside the framework that are executing very often. Usually, they are part of change detection cycle. And you can know that it can be executed several times per second. So, is this property access monomorphic or not? Well, it's impossible to tell by looking at this function, because whether the property access is monomorphic or polymorphic or megamorphic is determined during runtime by the VM. And I'll show you now and explain to you how it is determined. But first, we need to understand that property access in VM is pretty complicated. Right? Mishka talked a little bit about shapes and hidden classes and how VM stores objects. So if you're looking for more in-depth coverage, you can check out any of my talks on YouTube. Previous talks, I went pretty in-depth into how monomorphism works, how VM stores shapes. And this is a pretty complicated topic, actually. I had to read, I don't know, one article, I came back to it 3 times to reread it, and still couldn't figure out some parts. So luckily, I had some help. Benedict from V8 core team helped me a little bit to figure out some parts of it. So if you don't understand all of it, or some part of it, don't worry, because I was in the same boat. It's not easy, really. So what we need to take from this is that property access is pretty complicated. So as we all do, and VM maintainers, they want to somehow optimize that process. And inline caching, this is, again, Mishka talked about it, is the process of optimizing this property access. And the key word here is cache. So instead of going each time trying to figure out where exactly the offset is stored, trying to resolve the shape that corresponds to an object, we can go through that long, long process just once, and then cache it all, right? So let me show you an example. So here we have this function, getX, that returns just the property. Okay? So somewhere inside the virtual machine, particularly inside VM, every function is represented as the closure object. Okay, so closure getX. And every function has a cache. It's called feedback vector. This is the terminology VM uses. So you can think of it as just an array, very, very big array. And for each particular property access inside the function, so this is important, VM creates cache for every single property access. There is a cache there, and this is called inline cache. So what happens? Suppose now the function starts running. Right? Your code is being executed by VM. Virtual machine collects this information. It knows how many times your function has been executed, and it's all this information is stored in this cache. But besides that, there is something else that virtual machine stores there. So we call this function getX. We pass in an object. Now, if we call it for the first time, virtual machine needs to go through the process of trying to resolve the value. So first, it needs to find the corresponding shape. This is where all the metadata is stored, particularly offsets to the property. Once it has gone over that process, it knows the information that it can now cache, right? The first thing it can cache is the shape. So it stores the shape that corresponds to that object, basically the description, right, of that object. It can also store the offset. This is the information that indicates where exactly in memory you can find that property. Okay? So next time when we go through that process, we need to first compare the shapes, and Mishka showed that called if, right? He called that ID something. I forgot. Yeah, hidden class ID, yeah. So it compares hidden class ID, and if it matches, then there's no need to go through that lengthy process again, right? You can just pick the information from the cache. Okay, so we stored that, and there is also interesting thing called state. So VM determines the state of the cache. And inline cache is first and foremost is a cache with its properties. So every cache has entries, right, length, and capacity. So if there is only one entry in the cache, the state is defined as monomorphic. Okay, so this goes from here. Mono means one, morphic means of a form, in our case, shape or hidden class, right? It's a general notion. And this is where the phrase monomorphic property access comes from, right? So monomorphic property access is the access if the function has been called, it doesn't matter how many times, but as a parameter, you pass in object or many objects that share the same hidden class or the same shape, right? So it means that in the cache, there is only one entry. Okay? Now, we've seen that. So we know now about monomorphic property access, and it means that there's only one entry in the cache. So here I'm calling the same function 3 times. I'm passing objects with different values, but they all have the same shape because the set of keys is the same. Now, what happens if you pass in another object, right, with a different shape? The state transitions from the monomorphic to polymorphic. It means that there is more than one entry in the cache, right? In this cache that I showed you, in this cache on the closure, there's more than one shape, okay? So it goes to polymorphic state, and as I told you, every cache has the capacity. So in V8, this inline cache, the capacity is 4. So you can pass in and cache not more than 4 different shapes. Okay. So what's interesting here is that I didn't know that, but I was running some experiments, and it appears that if the object has the same set of keys, but different prototype, VM considers it a different shape. So I'm passing, calling the third time function here, and I'm doing object create to change the prototype. So now our cache is polymorphic. And if you continue calling the function and passing in different types of shapes, right, you will, the state of the cache will transition to megamorphic. And megamorphic state, it means that virtual machine still uses the cache, but it's the cache for all object accesses in all the application, right? And Mishka showed the problem with sharing one big cache, right, is that the new values will override old ones, right? And we saw that what happened when we called too many times, like 10,000 times, right? The time increased dramatically. Okay, so how does Angular benefit from it? I'm going to quickly go over that. We have different type of view nodes, and potentially, or if we follow the object-oriented programming principles, we would need to create different classes for each different type of a view node, right? Because they all have different fields. But in order to ensure monomorphism, Angular creates a single class for all data structures, and just using some field, like for example, type field, to distinguish between what kind of node that is in runtime. Okay, so that is monomorphism. Now, let's talk about data structures, another interesting topic. And actually, before I started working on this talk, I didn't really know that such kind of data structures existed, because I don't have proper computer science background. I learn as I go. And, well, my hope is that I touch it a little bit here, and you all will also become interested in what kind of data structures exist beyond regular data structures like array objects, right? So probabilistic data structures, why they are needed? Well, they are usually used as an optimization layer. They cannot be used by themselves because they have some limitations. I will present some of the limitations later. But they have very little requirement in memory, and they're very, very fast. So these are two characteristics of all probabilistic data structures. Now, Bloom filter is the data structure that Angular uses, and it also appears to be the most iconic probabilistic data structure in the world. Like, at least that's what the article I read said. So I believed it. Yeah. Right. So the Bloom filters are used in databases. That's like the hardcore usage. They're used in networking, and they're even used in cryptocurrencies. So the Bloom filter is designed to answer one simple question: is the element in the set or not? Right? It's just like an array. But if you have an array, to find out if there is an item in the array, you would just we need to go through one by one and doing the comparison, right? So 1 million elements. It's a long way to figure out if there's element in the set or not. So Bloom filter allows us to do it much quicker. And actually, you can have two answers: no, right? Okay, element is not in the set, and yes. But it's tricky, because probabilistic data structures do not give you the answer yes. The answer is maybe. That's why they are called probabilistic. And you can do some tuning. You can actually define this probability of answer yes. And I think, at least from what I've looked at Angular, they ensure that it's always yes. I won't have time to cover how they do it, but it's interesting. So it's maybe and no, right? Varying probability. Now, I hope that by now you're wondering, how is it possible that you don't know for sure if the element is the set or not? Yeah, this slide, I forgot about it, right? So all probabilistic data structures, they share two common characteristics, and Bloom filters as well. They use hashing functions to encode items. So you feed them a good item, and you get a hashing function result, which is just a number. And they don't store entire items. So you cannot use probabilistic data structures as a replacement for regular data structures like array. They usually go one with one. So we take a set of 3 elements. I'm going to show you how Bloom filters work. Just a quick overview. Right? Bloom filters are just bit fields. So you run some value through the hashing function. In our case, for example, this is very, very primitive hashing function. Just takes the first value, produces the number. And what you do, you set this bit using bitwise operators. So for John is the whole value, right? We got just number 2. So we set the number 2. The second bit in the bit field. So then, if we need to know if John in the set or not, what do we need to do? We take John, we pass it through the same hashing functions, we get the same number, and what do we need to do now? Who can tell me? Nobody? Okay, we need to check if this bit is set or not. Right? Because we know that in the beginning we set this bit, so now we just need to check it. And if this bit is set, then John must be in the array or in this set. Right, but I told you that it's never yes, right? It's always maybe. The problem is that your hashing function can produce the same number for different values, right? The collisions are possible. And so it may be that some other value produced number 2, and now the other value is there. So you always first check the Bloom filter, and then if you get the answer maybe, now you can go and check the data structure that pairs with it. And this is exactly what Angular is doing. And it's using this technique in its dependency injection system. So we all know that in Angular, we have hierarchical injectors, right? That follow the pattern, the hierarchical pattern of components. Okay? So for each component, Angular creates an injector. And now, if we need to resolve the value, for example, the bottommost component requires a widget manager that is registered somewhere at the top. Now, in order to get that widget manager, the runtime has to go through multiple injectors until it reaches the topmost. And in each of those injectors, it needs to check if there is item in the set or not, right? If this widget manager is declared inside site analytics component, widget component, and so on. And again, if components or injectors contain a large number of services and you have quite lengthy hierarchy, it takes some time. So here we're using just regular data structures. And we learned that we can complement regular data structures with probabilistic data structures to perform that check. And this is exactly what Angular is doing. It adds a Bloom filter to each injector. And we know that if injector gives us answer no, it means that it's 100% correct. We can now go and check the other injector. And it's very fast. It's just one bitwise operator. It's extremely fast. So what Angular does, it first checks the Bloom filter. The first Bloom filter. If it gives us answer no, that's OK. We believe it's 100% correct. So we go up. Then we go and check the second Bloom filter. The answer is no. And only when we reach the latest, the bottom or upmost injector, or Bloom filter, we get the answer maybe. And we now know that, OK, maybe not there, so we'll just go and check the injector. And that's what Angular does. It checks the injector, it finds the service that is required, and then injects it down. OK, so that is probabilistic data structures, and particularly Bloom filter. And the last piece I want to talk about is Angular compiler. So Angular, as it appears, has a compiler. And why does Angular have a compiler? That is actually a valid question. Why does a framework need a compiler? And I asked this question on Twitter. What do you guys think? Why does Angular have a compiler? The most common answer was, well, to translate HTML-like syntax that the way we define templates to runtime code, right? Because browser doesn't understand interpolations, for example, directives. And that is correct answer. Here we have Angular like template, and then we run the compiler over that, and it produces some JavaScript. This is the output of the new Ivy compiler. However, other frameworks have compilers too. For example, in React, we have JSX compiler. So is it the same? Does it perform the same role as in Angular? This was the question that I wondered and tried to discover. So this is similar template-like view definition in React. So we run JSX compiler over that, and it also produces JavaScript. Now, if you compare the output, however, you will see the real difference between JSX compiler and Angular compiler. The JSX compiler defines a view using JavaScript. There is no runtime code that is produced by the compiler. So it's a view definition, it's a particular definition of H1 element using a JavaScript object. Whereas Angular's compiler produces runtime code, and which is more important, it produces direct render instructions. These instructions, they're very fast, and they allow you to process changes in the framework in a very short amount of time. For example, in React, you would need to go through every single element and check if it changed or not. But with direct render instructions, each instruction knows to which element it corresponds. And for example, in our case, the instructions produced by Angular compiler, text binding, interpolation, they can just check this particular node. And as you can imagine, it's a lot faster than checking every single element that you have in the view definition. And this is, of course, enabled by the static nature of HTML templates in Angular, right? Because when you define them, Angular compiler has a lot of information to work with, so it can produce this kind of code, right? We use directives to signify which parts of a template are dynamic so that it needs to be checked during change detection run. Okay, so direct render instructions is the output of the Angular's compiler, and that is the biggest difference between, for example, JSX compiler in React. Svelte, for example, framework, the other framework that follows this pattern as well, also produces runtime code that is optimized for execution. But an Angular compiler is very sophisticated, and it allows the framework, or particularly what's important is that it produces the code that is run during change detection cycle very, very often, and this code must be most optimized. There's also the other benefit to having a compiler, and Angular team has talked a lot about that, and this is, of course, smaller runtime, right? Because if you have just one text binding, the compiler needs to produce only one or the single instruction to process that binding, right? As soon as you start adding more stuff to the template, for example, you start adding directives like ng-style, it needs to produce more elaborate JavaScript. Same goes for other directives like ng4. But if you don't include them, if you don't use them in your template, you won't see these instructions or the runtime, the code that is responsible to, actually it's function bodies, because each of those instructions is just a function. So Angular doesn't include this logic for these functions into the resultant build. And that results in a smaller bundle. Okay, so this is a mountain. Why mountain? I always give these talks, these deep technical talks, and maybe one or two person in the audience sits and nods, right? The other ones, people just look at it. And I understand that this is difficult to get it. It's very difficult to produce, to try to elaborate and explain these technical details. But my hope is that you not just watch this talk today and think, okay, this is not something that I want to do or want to look at. My hope is that you will go home and rewatch my talk, Miska's talk, where he showed how exactly to track all these monomorphic property accesses and the effects that it can have. And then maybe you will buy a book about data structures and start reading about data structures that exist in programming, right? Because we, as regular JavaScript developers, we use arrays and objects. We don't need to know what is hash map, or, I don't know, trees, all these other kind of data structures that, for example, server-side developers use. But my hope is that this talk will inspire you to go and buy that book, go read that article, go rewatch that talk, and by doing so, you will all become extraordinary developers. Thank you for your attention. Good luck.
So up next, in this room right here, we have Gil Fink with Profiling Like a Shark, profiling Angular apps like a shark. And in track 2 is going to be Marta with Offline First in Angular. so excited about this next one. And Gil Fink here has all the titles. He's a web development expert, a GDE in web technologies, Microsoft Development Technologies MVP, and Sparksy CEO. You got it all, man. He's currently consulting for various enterprises and companies where he helps to develop web-based solutions. And he's also, if that wasn't enough, a co-author of several Microsoft official courses and training kits, co-author of a pro single-page application development book, and a co-organizer of the Angular Up and React Next conferences. This is a busy fellow, let me tell you. Let's all give a very warm welcome to Gil Fink.
So thank you, Alisa. I'm very excited to be here. And I want to start with something, you know, web applications. We are all web developers, yes? Yeah, of course. And we start to develop our applications, and our users have a lot of expectations from us, that the applications will be very, very performant and sometimes work offline and do some great stuff. So we build the application, and we ship it, and we are happy. And then the first user comes to our application. And the second one comes to our application, and they're stuck with the loading. And loading is so slow. Which leads to frustration, you know. And then they try your app. It loaded, and they're starting using. And they're using navigation in your application. Or use some drop-down list, and it works perfect on your machine, but on their machine, sometimes it quirks. Or maybe a toggle. And all we wanted to do is to ship the best app that we can, and our users love our app. We want best apps, but best apps are probably applications that not only work on your machine, but perform well on the user's machines. And users use more than just desktops like we do when we develop. They're using mobile phones and tablets and et cetera, and these devices have different CPUs and different ways of running your application. And this is the talk that I'm going to present to you in the next 27 minutes, which is how to profile your application in order to performance tune your application. So Alisa told you a lot about me. I'll just rephrase it quickly. I'm Sparksy CEO. I'm both GDE and MVP, Microsoft MVP and Google GDE. I wrote a book called Pro Single Page Application Development back there in 2014. You can use it as something that will make your screen more taller. But it gives you the content of how to develop good single-page applications, but with Backbone. Angular Conference, Backbone. OK, let's move. And I wrote some Microsoft official courses that can be learned in Microsoft's learning centers across the world. So if you did the HTML5 programming course by Microsoft, go to the 7th page, and you will see my name there as the author. What we're going to do here is the following. First of all, I'm going to talk about how browsers render your applications. This is a very crucial thing, because once you know or understand the process, you will know how to figure out some things when you are profiling. Then we'll go and profile some Angular applications with problems, and you will see how I work in order to you to go back to your place at work tomorrow and then do profiling and find performance bottlenecks. So let's start with understanding the browser rendering process. First of all, as I said, we have devices, and all the devices' refresh rate is 60 times a second, meaning we have 60 frames per second in each and every device that we are using. That means that you have only 16 milliseconds to ship every frame. And to make it much harder, each and every browser has some work that it needs to do. So if in reality, a frame should be below 10 milliseconds because of the browser overhead. And if you are doing less than 60 frames per second, you will get junk. Junk with A, not with U, even though junk and junk, it's the same, okay? With performance. Your performance will be bad. Now, each and every browser ships the frame to the screen in the following process. This is called the pixel pipeline. First of all, JavaScript. The JavaScript will handle the work for you for every interaction that the user is doing, and it will run some stuff that you are doing in order to create visualization or visual changes. These things also occur when you change CSS transitions or use CSS animations or web animation API. The second step is the style, okay? But the browser figures out, according to your CSS selectors, how to draw the elements in the page, meaning draw in the content of the elements and where the elements should be, okay? Then the browser understands where the elements should be, and the layout step is starting. This is the most crucial step. It organizes the whole page, so if you see some changes during the loading where elements move from one place to another or things like that, this is problems with layout that you caused in the application. So this is applied according to the web layout model, the box model. I hope that you know that. If not, go and read about the box model later on. The fourth step is the paint, meaning that the browser paints the pixels to the screen according to the color that you set style, according to the place that the element needs to be, and etc., etc. The last but not least step is the composite. The composite is the step that, you use z-index sometimes, so the browser needs to understand if there are overlapping elements and place one element on top of the other. Okay, this is the last step, and this is the whole pixel pipeline. Now, when we're talking about pixel pipeline, we're talking about reflows. What is a reflow? A reflow is a process in the browser that the browser, according to some visual change, need to calculate the entire layout again. This is a very expensive process, and the whole pipeline, the pixel pipeline, will run again. You want to minimize this process. A repaint occurs when a visual change doesn't require the calculation or the recalculation of the whole layout. That means that you change some color, red to green, then all the pipeline will run again without the layout, which is expensive. But the painting is also expensive. Reflows and repaint, please minimize the effects. Changes to the DOM, changes to colors, etc., should be bundled together, okay, in order to create better performance. The last option is that we have a process that doesn't include repaints and reflows. That means that you're changing something in JavaScript. For example, you have some timer that runs and calculates some calculation, which doesn't affect the DOM or the CSS or the style. Okay? So these things happen. Then the process will run, but only with JavaScript, style, and composite. Now, when you start working on your application, start thinking about the Rail model. What is the Rail model? It's a user-centric performance model. Rail means response. Each and every event should be responded below 50 milliseconds. Animation. You should produce the next frame in 10 milliseconds. If you're going more than 10 milliseconds, you're doing wrong things. Idle. We are developers. We sometimes love the laziness. So make the application lazy, okay? As much as we can, we should maximize idle time, okay, to be responsive. And load, meaning deliver the content under 5 seconds, okay? We won't discuss how to deliver content under 5 seconds. There are good sessions around the world. Go to Adi Osmani's sessions about how to do lazy loading and etc. And you will understand how to make your application interactive under 5 seconds. So now, after the background, let's start profiling. How do you do profiling in web applications? DevTools Performance tab. Who opened the DevTools Performance tab in the last week? Please raise your hand. Wow. Okay. So the people who didn't raise their hand right now, you'll probably learn something new, or you not. But let's start with a small demo. God bless you. Okay, so here is an application that I have that prints some colors. It's an Angular application. Let's open the DevTools. And what you can see here is the Performance tab. In order to record the performance of my application, I would just need to do Control-E or press this button on this button. Let's press it, and let's do a refresh. And let's stop it. Now, we get a timeline with a lot of details. Don't be afraid of those details, okay? This is the first thing that you need to understand. Those details are very helpful, but you need to understand what they are telling you. For example, what I can see here is that the entire loading of the page took around 4 seconds. Okay, that's good in the Rail model, but that's not such a good thing if we're talking about an application that draws just some color things on the screen. Another thing here is that I can use these handles to minimize my view or maximize my view in order to understand things here. I can look at the timeline here, and I can see here a lot of details like frames or what happened here. There was a very long task, the loading of the application, and it resulted here in the onload event, the DOM content loaded event, first paint, and first contentful paint. Okay? Now, we're talking about profiling, and there are a lot of details here, but what I'm going to show you is that we can go and look at the summary of the whole thing here. Okay, we have 2 seconds of scripting here. The loading took 7 milliseconds. The rendering took 8 milliseconds. So we are doing a lot of scripting right now. If you're doing a lot of scripting, that means that there is something problematic in the code. So how can you understand where are the problems? We can go to Bottom-up tab here. And we can look at the total time, and we can dig in and see things. For example, the bootstrap here from Angular took some time. There is the main TS that took some time. These are from the Angular, and I can assure you that the Angular code is very performant. We will continue and search for things or problems which might arise here. So I have a component here, the color component, that took some time to load. And we can see here that there are 2 indications of problems that I need to check out. For example, color component in the ng-on-init function and color component in the decimal to hex function. Let's take a look at decimal to hex. And once I click this link, I can see, a lot of details about things that took a long time. For example, this line of code took 1 second. It ran a lot of times, and all the times that it ran, it produces some string, and it produces it in 1 second. That's not a good thing. Another thing to notice here, don't take console log to production. Look at it. 195 milliseconds wasted because of console logs. Okay? So, one tip, remove console log when you go to production. So let's take a look at the application itself. Here we have the colors page, and this is the color component. And once we are doing profiling, we are like a detective. We try to understand what we wrote, to understand how it performed on the screen, and then to make assumption of how to improve our performance. So I have a function here called decimal to hex. The function is calculating a number and transform it to hex form. And I'm using that function here in the component itself to set some background color. So I'm setting the background color here with that function 3 times. And a better solution, which will produce better results, will probably be something like this. Okay? Just use the RGB function that is part of the CSS spec. We didn't know that, but now we know that there's something that exists that is better than better than our own calculations. So this is something to remember. Not all the solutions that you are using are the right solution for performance. Okay? Now we can go to the profiling here again, to the app. Go to the performance, clear it, run it again, refresh the page, stop, and look at the results right now. Okay? So let's see if we have a change. Nope. Well, I'm scrolling and scrolling and searching for that ng on init. It's still here, okay? But the decimal to hex performance is better. And the ng init is better. It didn't took 4 seconds, it took 1 second. We can do better. I can remove the console log and it will run super fast, okay? But these are the things that I try to teach you, okay? Sorry for that. So how does the process of profiling works? We establish a baseline, meaning that you will open a browser in incognito mode. Why is that? You don't want all of your extension running and doing some stuff and affecting your profiling. You will collect data using the performance tab. Then you analyze the results. You will try to find some places in the bottom-up, for example, view, in order to see if there are wrong things that we did. Then you make the assumption and you tune up your code. And you test and measure the code again. If that works, cool. If it's not working, then you collect the data again, analyze the results, tune the app, and test and measure, and etc., etc. This is the process, and I hope that you will start doing that process during development time and not on production. So let's profile another application or another web page here. So in this app, I have another page called Movies, and it has a problem. One major problem. if I want to change the title and just add a random number to the title, I want to press the button and that the number will appear very fast because it's just concatenation of strings. But it's not appearing very fast. There is something wrong here. So let's profile it and let's understand what is going on. Okay? So I can profile, change the title, wait, and wait, and wait, and wait, because profiling has some overhead, and stop. Now, we have the results here, and I can go to bottom up and try to understand what happened or what are the problems. Sometimes Chrome developer tools are very smart, then they will mark the problem for you. Okay? You won't need to dig in and to understand what's going on. So movie.component here is doing something that is wrong. Now, in this page, we have a lot of movies inside of a movie list, and that movie list is problematic. Why is that? Because, let's take a look at the code here. Each and every movie here has change detection default. That means that ng-check will run for each and every component, movie component, even though we just press a button on the movies component and we want to change something there. Okay? So, of course, the solution for that will be on push. Okay? But now you probably understand what is going on. Okay? Why we are using on push. Okay? If the component isn't going to change and it's just a rendered component, then it doesn't need to, or it's not supposed to run or to affect our performance in the web page. Okay? So I can change here the default to on push, and you will see the changes, and everything will work much faster. Another step or another thing about profiling is memory leaks. A memory leak is a memory that you used or application used that isn't returned to the memory pool. That memory isn't freed by the application. It gets stuck in memory. The memory gets stuck, and what happens is the memory of the application starts to decline until you don't have any memory and the application crashes. And JavaScript has memory leaks that has memory leaks, but you can create memory leaks with JavaScript, okay? Accidental global variables are something that can cause memory leaks, but easily resolved with linters. Just check that you don't have globals. Forgotten timers and callbacks are another thing that can cause memory leaks. Out of DOM references, you put some element out of DOM that includes some references to it, and boom, you have a memory leak. And closures. We all love closures in JavaScript, but a closure is a function that, it's a variable inside a function that finished running, and that variable is kept alive. Okay? So in potential, closures can cause memory leaks if you are using tons of closures and you are not releasing them. Let's talk about Angular and memory leaks. So I have here the same in this application, an example of a memory leak. You have here a number of subscriptions. We'll take a look at the code in a minute. I'm moving to a second page, return to the page, and we have 2 subscriptions, even though we thought we have 1. Why is that? So we start with the lucky service. Okay, this is from Trilo. Go to this link. You will see the same example. Hopefully, you will get the understanding of what I'm doing here, because I don't have much time. So this is a service that exposes an observable, okay, for some random number. And in the component here, what we are doing is subscribing to that number, and then we change the number accordingly. We can see here the number changes. Okay? And what we are forgetting to do here, because we use the service, is unsubscribing. Meaning that once we navigate from this page to another page, we still have the subscription live. And then, once we return, we will have 2 subscriptions in the page, and et cetera, et cetera. What's going to happen is the memory will be flooded with a lot of subscriptions. So how can we fix that? Of course, we can implement the ng on destroy and do unsubscribe to the subscription. Okay? But beware that observable can help you create memory leaks. So please unsubscribe from them in your applications. So let's summarize. Our users expect very, very fast and fluid applications. What I'm suggesting is that you will add performance tuning processes during your the development time and find junk with A before you ship your application. You can profile the application using the performance tab in Chrome Developer Tools, and you can understand how to create or how to find memory leaks by understanding how things are running inside your application. Don't wait for your users to complain about performance. Tune them today. Thank you.
Coming up next is our final talk of today, 2 talks of today, with Brandon Roberts, automating your Angular projects with schematics. And in the other track, we've got Gerard, who's talking about the coming fad, future of accessibility for developers. So stick around, last talk of the day. You all hung in there through the coffee and the tea and the talks, and we have made it to the final talk for day one in track one. And this one is by Brandon Roberts. Woo! I know, right? We're here. We made it. So, Brandon, an Angular engineer for Narwhal, awesome company, building developer tools and helping enterprise companies become successful using the monorepo approach. Awesome. He enjoys learning new things, helping other developers solve problems, and contributing to open source. He is a GDE, technical writer, and also a maintainer of the NGRX project, building high-quality reactive libraries for Angular. Let's ramp up the energy one last time, everybody, for Brandon Roberts. Come on. Woo! Get it up, get it up.
Mic set up here. Hello, 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 hello. Okay, is my screen up there? Okay, great. So this is automating your Angular projects with schematics. And I wanted to give this talk because schematics are used somewhat in the Angular ecosystem, and I think they're very cool, and I think a lot of people would find value in those. So we're going to talk about, how we can get some of that value. So first of all, I know everybody's really sleepy. You've been sitting through all the good talks all day, and this is the end of the day, last talk. So, but we'll get through it together, right? I was right there with you when I got here a couple of days ago. So, as we mentioned before, my name is Brandon Roberts. You can follow me on Twitter at Brandon T. Roberts. I tweet out GIFs. I talk about sports, and I block people on Twitter sometimes because that's just what you have to do. Software engineer at Narwhal, which you heard about earlier when we gave our sponsor talk. So good thing there. Also a GDE, gotta list all these titles, right? And also a maintainer on the NGRX project. So I'll just plug that if you want to get involved there. You can always do that, or get involved with Narwhal or NX, and come see us there also. So the areas that I wanted to cover are, what are schematics? We'll give a formal definition and talk about the kind of key terms that you come across when you use schematics. Talk about why you want to use them, what are the use cases and examples, how do they work, the different pieces that you'll interact with, and different tips that I've come across while building schematics and just things that I've learned along the way. Because I want to make schematics not so scary, so we'll see how we get there. So what are schematics? Schematics are used for scaffolding. They are generators that perform operations on your file system. Like I said, a big usage of schematics is for scaffolding. When you set up a new project, or there are things that you consistently do over and over when you're working with your applications, you want to automate those things, and whether that be generating additional configuration or updating files or existing files, maybe you have processes within your organization, schematics help you along that path. Do those things not repetitively. You can automate those. So schematics are very popular, like I said, popular in the Angular community, but they are independent of the Angular framework itself. They're part of the Angular dev kit that provides low-level APIs that you can use. You want to write schematics that target your own needs. As I mentioned before, there are things that you may do in your own projects or at your job that you can take advantage of schematics for. They're also popular with many third-party libraries in the Angular ecosystem that use schematics that you just kind of use as part of your daily routine. So just to give an example of some of those, I mentioned the Angular framework uses schematics, like when you set up adding like PWA capabilities to your app. There's also CLI, of course, is probably the biggest consumer of schematics for all the generation and update commands. And of course, Angular Material has predefined schematics for like dashboards, navigation, and other layouts. And of course, if you've used NGRX before, we make heavy use of schematics to aid you in setup and development of features. And I talked about NX that uses schematics to generate components for Angular projects and even React projects. So as I mentioned before, it's not necessarily just Angular specific, but it's very flexible in things you can do. So I want to talk about the schematics in kind of two areas. There are schematics APIs in the two concepts, schematics APIs and then configuration. So as I mentioned, Angular Dev Kit is the namespace where all the schematics APIs are. So we'll go through some of the definitions of what these are and their common use cases, just so that when you attempt to do schematics yourself, you'll know the terminology and it'll seem more familiar. So the first one is a rule. I'll just go through the terms here. There's a rule, there's a source, a tree, an engine, and I'll, like I said, explain these a little further in detail. And then there are also utilities that they offer to build schematics. So then in your configuration, there is a schema that you define for your schematic, and then the collection that defines the number of schematics that you offer or the number of ones that you've written that you can execute on a project. So as I mentioned before, the first one is a tree. And a tree contains your original file system. It's more like a staging area for changes. It kind of works somewhat similar to like Git. You make some changes, you stage those, but it doesn't commit those changes yet. It's just a staging area. It uses a virtual file system where, like I said, it can perform changes against the staging area without actually impacting your file system yet. It's built on top of Node APIs so that you can ensure that there's cross-platform compatibility. The next one is a rule. So the bulk of what you'll do with schematics are rules. And a rule is a function that applies to a tree. Most of the time you'll write functions that return a rule, and that will get applied to the files that are in your tree, some files you want to operate on. And they are immutable. So rules don't modify the existing tree. They return a new tree whenever they perform an operation in that staging area on it. So it will contain all those transformations that are to be applied when you're writing a rule to apply against a schematic. Next is a source. So a source is a function that creates an entirely new tree. This could be from an empty file system. You could read in existing files that are bundled in your schematic. These are considered sources. So a URL is one of these sources, and it just reads in files that are loaded in from a given file or given URL and returns a tree with those files. So let's take a look at a schematic in its simplest form here. And that's something I want to emphasize is that schematics add value that's worth the investment, right? So writing simple schematics is pretty straightforward, and they can help you, help others. You know, you invest in these schematics and people take advantage of them. So this schematic is pretty simple. It just has it's just a function. It takes in options. And this rule creates a file, just a markdown file, just for example, and writes those contents to that file. So to define, for a schematic, each schematic has a defined schema. And the schema helps you define properties and options for the schematic that are available to the user. So it's also used to validate input for the schematic itself. So the schema is defined in a couple of ways. It's defined in JSON and in TypeScript. And the JSON is used to declare the validation for the available options. It supports many data types. So if you looked at schematics before, you use ngGenerate. It can be, you provide things that you request a string, or if you pass the routing flag, it could be a Boolean, or even lists or prompts are enabled in the most recent version of the Angular CLI. So here's just an example of the JSON schema that you would define for a schematic. The couple of properties here that exist are name and service options. The name has a description and a type, which is just a string here. The spec here has a description, a type, and a default. So it gives you flexibility. If you want more custom options, you can provide those, such as prompts to receive user input, if you want to provide a custom list or other information. But this is just declaring what the schematic properties are in the JSON. The TypeScript file is used to define an interface that you adhere to when you're creating rules. So when your schematic runs, it parses those options that you provide, and this gives you a type-safe way to consume those options in your defined rules. So when I defined the schematic before, I just had any as my options, but I can import that schema and have typed options of what's available for my rule that I write for a schematic. As I mentioned before, collections are defined in a JSON file, and this is just the path to the collection is defined in your package.json file. So in your collection, it's just going to list all the schematics that you offer, whether they be ones that modify files or generate files. They all have the same structure here. They have a description of it gives you help options for that schematic, the factory function that I've talked about that returns a rule, and the schema that provides the validation for that. Also talked about the virtual file system. So it uses Node underneath to create like a host system so that it's not applying changes directly to your system as it's running. And also represents your file system, like I said, virtually that you can operate on. And has those stage operations that you can chain together to perform multiple things. So if you look at another simple example of a schematic, you can create files, you can read files in, read files, modify them, and all these things aren't, like I said, they aren't applied instantly. So you can do multiple things at once and chain them together. So the schematic engine is something that you don't normally interact with directly. The Angular CLI uses it internally to control the creation of a collection and execution of the schematics. It does things underneath like create workflows and schedule tasks, such as package installation using the package manager that it detects from your system. It also brings together the virtual file system as a host, reads the metadata from the collection and the changes to apply. And then once everything is the verification checks pass, it commits those changes to your file system successfully, and then that's the end of that particular workflow. So what can I use, or what can you use schematics for? As I mentioned, the big thing is automation of common tasks, things you do repetitively. Standardization. If you know your company creates your features in a certain way, you can standardize that with schematics. You can use this in large and small environments that you'll get enough impact either way. Structure and process. The way you do things in an organization, you want to keep those, like I said, a certain way. So file generation, you can also use them for file generation using standard and dynamic templates. So these templates, if you just want to generate files that don't require any changes from the user, you can just use those to generate them, or you can customize them and make them more dynamic. You can use these for install tasks. Things such as adding prettier or Jest or your own custom setup to your projects. You can use schematics to automate these things and update tasks such as updating files within your code base. So as I mentioned, file generation. You're most familiar with the Angular CLI ng generate command for generating components, services, and other items. And these are using defined templates that can be static or ones that are not based on user input, and dynamic templates that generate different output based on the user options. So they're extremely customizable. Because, I mean, at the end of the day, we're like making copies of files for distribution and trying to make things easier. So there are a few template utilities that you come across when you're writing schematics. So I'll just list a few of those. The apply function, as I mentioned before, helps you apply rules to a source of data. I showed before you can read files in from a URL and apply rules to that source. Apply templates is when you're dealing with dynamic data that you want to apply to a specific schematic template. Use URL for loading in files to move those from a staging area to their permanent location, because you can have schematics that are bundled with or files that are bundled with their schematics to use those. So you mentioned move, and then there are string utilities to manipulate strings into many different cases, whether it be Pascal case or camel case or in their title case, many of the different ones. So these come from two main areas, the Angular Dev Kit schematics and the Angular Dev Kit core. So just a few imports that you use when you want to build these schematics. And what you import these, so let's say I want to generate a service. I want to generate some files that I have stored in my schematic. Well, once again, you define a function that returns a rule. The files directory here reads those files from that schematic. And this is where, like I said, your templates reside. The apply templates lets you set properties and methods that are available to the template. So here you see that I have the classify and like dasherize methods that I can use to make those available to the template to make them more dynamic in case I'm passing in data to that template. You can also provide your own properties to the template. Here I'm just providing an additional name and API endpoint for the template schematic, or for the schematic template, excuse me. So the template itself is just, in most cases, just looks like TypeScript. I've added a .template extension here just to makes it easier to parse, because it won't be compiled as part of the rest of your schematic code. So that's one thing to note, just to denote them that way with a template extension. So here I'm using the classify function. I'm taking in the name. I'm just using, I have a schematic template here for creating a service with a custom with HTTP client installed, already injected. So you can think of this as something you do quite commonly, so a schematic fits well here. So when that schematic is run and that service is generated, it will replace those items in the template with the options provided from the user called with those functions. And then you can, of course, move on and do things with the service as opposed to having to generate the service, import HTTP client, and do all those things that you would normally have to do. As I mentioned before, common tasks including register with ng modules. These are things that are done with schematics, generating components, other items that are generated as part of your development process. You can think of other things like updating your constructors for a file that's already generated, modifying configuration, and generating organization-specific files. So for automation, there are a couple of ways that you can leverage schematics to update files. The first one being just a find and replace. You can read in the contents of a schematic, find and replace, and the second part is ASTs. So in general, find and replace is easier to implement. You're just reading and overwriting the contents of a file. And of course, you can use regex, or if you want to get fancy or anything like that, but I think we know what happens when you try to write regex. So there's a more consistent way, of course, to manage these file changes, and that's with an AST. So what is an AST, and what value does that provide? AST is an abstract syntax tree, and what that is a structured representation of your code. It gives you a way to process that each line in your code represents a token or something that you can iterate over. It's represented as a tree of nodes. So TypeScript gives you the ability to generate an AST pretty easily from your code, from your TypeScript code, so that you can look at it and see the nodes. There's a wonderful tool called a site called astexplorer.net, and you can actually paste your TypeScript code here and tell it what kind of language you're looking at, and it will give you an AST of that structure. So you can see all the different nodes, what the whole string, and you can look at different languages and see how you can parse that code. So as I mentioned, TypeScript has methods to let you create an AST. And as I mentioned, ASTs are pretty complex in nature, so you could give a whole talk on ASTs themselves. But as I was just showing here, you can create an AST for a given file path and its contents, and it'll give you get a hold of that AST for the code so that you can traverse over its nodes and replace them as needed, as opposed to doing a file replacement or regex or something like that. As I mentioned, it's more complex, but it also provides you more flexibility as you can target specific nodes, and it's just more targeted in nature. So install tasks. The most common one being ng-add, installing additional dependencies, and setup and initial setup of files. So if your library or using a schematic, it's pretty straightforward if you don't need to initiate any additional file changes. You create a rule, your rule receives the tree, and uses the schematic's context to add a task to update your dependencies. And then you lastly return the tree. So just even basic support for ng-add for your library is pretty straightforward. There's also update tasks. These are just similar to ng-update. When you run ng-update using the Angular CLI, behind the scenes, it runs migrations that are defined in your library. So migrations are run between matched versions. They handle subtle modifications and updates to your library that may not be breaking changes, but they also help you transition your code base from one major version to the next. And that may include breaking changes. So migrations can give you a way to migrate those changes, like I said, whether it be file updates or transforming files through AST changes. So the same pattern here, you have ng-update, and it points to a migrations file in your package.json. And if we look at the schema for a migration, it looks pretty similar to a schematic. You give the schematic a name, a description, the factory function, the factory function that it references, but it also has a version number, so that in the future, you're going to accumulate these migrations over time, but they're only going to be applied to that version that it matches and forward, because it's using semantic versioning under the hood to check those versions to see which migrations it should apply. Also, if you're providing a set of writing schematics or providing a set of them for developers, it's just a few tips. Extending the Angular schematics collection is a way which you can extend multiple collections that give you a standard set that you can fall back to when if you want to set your schematics as a default and then have those be the fallback. Use sensible defaults. You want your schematics to be customizable, but you don't want to overload your users with too many prompts or options out of the box. You want to give your preferred method or preferred output by default, and then give them the ability to customize those. Use utility libraries or sites, as I mentioned before. ASTExplorer.net lets you look at the AST just online by pasting the code in. There's also TS-Query, which is great for working with ASTs. It has a syntax similar to CSS selectors that you can use. And even the Narwhal Workspace schematics, or Narwhal Workspace library has a lot of utility functions because we've written a lot of schematics before, and common functions that you can use to modify your package JSON files to just make those easier to work with. Also, I would tell you to compose your schematics. In most cases, you can lean on the existing schematics that are out there. If you write a factory that returns a rule, you can use external schematics that aren't built into your library, such as the same ones Angular CLI uses, which is in an example here using schematic/Angular. So you can generate a component and a module and chain those operations together without having to recreate those component or module schematics in your code base. So to recap, schematics are generators that perform operations on your file system. There's a lot of value in automation of these tasks that you can invest in that will help your team be more productive because they're not having to use that time to do those things manually. It helps you standardize their development. I showed you examples of how to use ng-add or use ng-add functionality or ng-update functionality in your library, and using utilities to build schematics. So if you haven't seen Brian Love and Kevin Schuhart's talk on schematics before, I talked to them before, and they gave me some good insight about just the tools in general. And the thing that stuck out to me was, he said, don't write too much code just to write a little bit of code. So schematics are powerful. They can do a lot of things. They're very flexible. But you don't need to take a hammer to every single thing that you want to use them on. So if you want a GitHub repo of the schematics that I've mentioned through this talk, you can visit the URL here. And this has, like I said, has an example of using a schematic in an Angular project that you created with your library. And I hope you found this talk informative. I hope you go out and try to create some schematics yourself. And of course, you can reach out to me on Twitter if you have any questions, and I'll do my best to answer them. Thank you.
Thank you so much. Okay, I've got a few important bits before you all shoot off. That's the end of the talks, but it's not the end of the conference. Still plenty of other things happening. Tomorrow, there is a big climate strike happening outside. And to get through the front doors, you're going to need to show your passes. So please take your passes home with you this evening after the later festivities, and come back in with this around your neck. Otherwise, it's going to be quite difficult to get you back in the morning. We're open from 8 a.m. There'll be kind of some light breakfast and coffee and tea, those kind of things. And we're going to kick off at 9 a.m. sharp this time round. So if the slides go. There we go. Right, okay, so right now we've got food happening outside, which is all provided by City Pantry. Thank you very much. We've also got the amazing Angular Ale and other drinks. Angular Ales is kind of scattered throughout, but you'll find the biggest stash with Oasis Digital, who are the people who are providing the Angular Ale, so you can go say hi to them at their stand. We also have a live jazz band, which is kicking off around about nowish, so that should be a lot of fun. At 6 o'clock in track 2, there's going to be some lightning talks happening. That's going to be hosted by the brilliant Bonnie. We've also got a guided walking tour of London happening. That's going to happen, the ground floor is the meeting point for that at 6 p.m. I am also going on a bar crawl with hopefully some of you. I have one confirmed person at the moment. So if you'd like to go on a bar crawl, oh yes, okay, people go on a bar crawl, look at this. Yes! Okay, we're going on a bar crawl. I've got a great route planned out for us. We're going to meet at 6 o'clock as well downstairs. And if you'd like to go to the Angular London meetup, which Josh and Pete are hosting later today, with a bunch of the speakers that you've seen today, you can head on over to the Skills Matters building for 7:45. You can sign up on their website. In fact, you have to sign up on their website before you go. Thank you all so much. I hope you enjoyed the talks and enjoy the rest of the day. Thank you very much.